What's going on, guys? This is Junior here, and today I'm going to give you a demo of the application that we're going to be building in this course. Now, if you've taken any of my courses before, you know that I create project courses, which means whenever we have a course, there's going to be an entire project that we're going to build from the ground up. Now, this course is going to be a little bit special because I'm going to show you how you can actually build a true real world application, like something you can actually just take, maybe make a few modifications to it, and then you can take it and make it your application for your company, or you can sell it to someone that asks you to build them some application. And all you'll have to do is just manage your database and make changes and modifications wherever you need to. But this course is designed to teach you all the main features that you see in applications today that you use every day, whether that would be your banking application or social media applications, all the features that you usually see with these applications. We're going to try to build a few of them in this course. So if you really want to take your skills to the next level, from business requirements to application design to database design, from the back end to the front end, then this course is for you. It's specifically designed for people that want to be full stack software engineer using Java backend with Spring and Spring MVC and Spring Boot. Well, we're going to be using an SQL database. So that's going to be a relational database that can be Postgre or MySQL or any of the other databases. And the front end built with the latest version of Angular at the time of the recording of this video. So if you really want to learn, you really want to become a software engineer, a full stack software developer, then this course is for you. So I'm not going to do a lot of talking. I'm just going to go ahead and dive into the demo because I really want you to see exactly the value that you're going to be getting from this course. So I have Chrome open and I have navigated to the application. You can see that I'm not using a local host or any IP address. I actually have a domain name. So this application has been deployed and it's deployed only on my network. So if you try to go to securecapital.org, then you're not going to see this page. I don't know what you're going to see. I just know that you're not going to see this because this is only deployed on my network. And I will show you how to do that as well, because you're never going to see an application running with an IP address or localhost. So we really have to take things very serious and build them the way that they are, the way that we use them every day. So of course, when you're in development, you can use localhost, you can use some IP address of some computer that you're using just to develop the application. But in a lot of courses, they don't show you how you can take this application and deploy it. So we're going to go over all that. All right, so let's go started with the demo. So here, when I first come into the application, if I'm not logged in, I'm taken to the login page. And I can show you that. For example, if I remove this and I try to go to the home page, then I'm get redirected to the login page because I'm not logged in. And you can see we have a message, you must be logged in to access this page at the bottom. So if I'm not logged in, I can't access the application. A few other things we can do, we can actually create an account. So I can click on create account here and you can see I have a form displayed so that I can enter my information. And I'm going to show you that in a second. And also we can go to forget password. So if I forgot my password, I can come here, put in my email address that I have for the account, and then I'll reset my password. I'll get an email and we're going to get into all these details. I'm just showing you the different pages that you have when you're not logged in. So let's go back to login. So here I'm going to be using a real email because I need to show you that the system is actually going to send me an email so that I can verify the account, because that's how real world application works. So if someone gives you an email, you don't just blindly give them an account. You will ask them to do another step, another verification step. And that's what we have implemented in this application. So I'm going to paste the email that I'm going to be using here. So this email is the email that you can use to contact me if you have any questions. It's a real email. So if you're just testing the application, make sure you use a real email because it's going to be sending you emails to reset your password or verify your account. So you want to make sure that you use a real email. We're not going to be using anything like test@test.com because that's not going to work for us. So make sure you use a real email because you will be getting emails, and if you don't use a real email, you won't be able to access the application. So for example, say I put this email and I know that I don't have an account with this application and I'm just going to pass in some random password. Now when I click on login, the form is going to be disabled, the button is going to be disabled, and the links also will be disabled, because when we have something being processed in the back end, we don't want the user to be able to send the request again or click on a different page. At least we want them to wait a couple of seconds until the response comes back. Either they logged in successfully or there was an error. So if I click on login here, I get an error immediately because I don't have an account with that email address. You can see no user found by email, or whatever the email that I put in. So I'm going to show you that we're going to create a new account and we're going to go through the flow and everything. I just want to show you what would happen if we don't have an account. So say I go to forgot password. Of course, I'm going to paste that email again, and then I'm going to click on reset password. So the system is going to process it again. All these links now they're disabled. As you can see, I just clicked on this and it didn't take me anywhere. And you can see we get another error message that says there's no account for this email address. So we don't just send random messages to the front end. We actually take the request, we process it appropriately, and then we send back an appropriate response, which is what you want to see in a real world application. So I can come here, I can see clearly that there's no account for this email address, which means that we can actually use this email to create an account. And that's exactly what we're going to be doing. So I'm going to go back to create an account, and this is going to take me to the create account page. And here I'm just going to pass in my information. So I'm going to pass in my name and then paste that email address again. And then I'm going to choose some password. Okay, I just choose 1 2 3 4 5 6. Of course, never use a password like this. I don't know if you guys noticed, for example, if I remove the email address, you can see that the create account button is disabled because the form is not valid. Okay, so I'm gonna go ahead and put that back, and immediately you can see that the button is enabled so that I can click it and then create the account. Now there's a validation on this, which is the email address. Okay, so the email address has to be unique every single time. So every user has to have one single email that they use, and that email cannot be used twice. So just to show you this, since I'm already here, I'm just gonna cut this, and then I'm gonna pass in the email address of an existing user. Now I'm gonna blur this out because again, this is another email that I use, and that's actually my private email. So you know, I don't want to share my private email with everyone, so I'm gonna blur it out. But here I'm gonna pass in an email of an existing user. Okay, so I put in the email of the existing user, and then I'm gonna click create account. You can see that everything is disabled again. The system is going to process it, and then I get the message. It says email already in use. Please use a different email and try again. So we have appropriate message for every single situation. And now I'm just going to go ahead and put this email that's not being used yet. And then I'm going to click on create account. And again, the system is going to process this. Form is disabled. Make sure the user can't click on anything. And then the account has been created. And once that happens, you can see that I get a confirmation screen. And this confirmation screen is also the same component. You can see we've been on the register component. So I'm going to show you how you can use different logic and different states of the application or of the component in this particular case, and then show different pieces of UI, which is really important for your user experience. So now the account has been created. So I'm going to go back to account login. And of course, if I wanted to, I can just click on create another account. So I can click that. We're still in the register. We're back to the create a new account, and the page has never been loaded. So the page has never loaded since we navigated to the register. So I'm going to show you how you can implement this so that you can enhance your user experience. But we're not going to create another account. I'm just going to go to account login, and then here I'm going to pass in the email again and say I'm going to pass in the correct password. In this case, it doesn't really matter. I just want to show you what's going to happen if I just create an account and I didn't verify my email. So if I do this and I click on login, again, the system is going to take the request, process it, and then I get user account is currently disabled. The system was able to recognize that this email belongs to an actual user, but the account is disabled because the user hasn't verified their account yet. And this is why I have this other tab open, because I have the email open, and we're going to go there right now so that we can verify our account, because we won't be able to access the application until we verify that this email address is ours. We can access it and then verify the account. And this is what you would typically see in real world applications. So I'm going to go back to my Gmail, and then I'm going to refresh, and you can see I have this new email, which is the new account verification email. And again, if you see things are blurred here, it's because I have emails coming from a lot of my students, so you don't need to see all these details. So I'm going to go ahead and click on this, and you can see I have a message here, say, hello junior, your new account has been created, blah, blah, blah. You need to click on this link to verify it. Okay, so this is an actual flow that you can have whenever you're building an application. It's an extra step to verify that you don't have, a bunch of robots accessing and creating an account on your system. So that's a very typical scenario that applications that you're using today have. And now I'm going to show you how we're going to build this. So now I can go ahead and just click on this link, and the system again is going to process the request. You can see that we have a very unique identification here. And now it tells me the account has been verified. Okay, so you see that I have another piece of UI again in the same URL, and the page didn't load. We didn't navigate the user somewhere else. We're just using application state so that we can show different pieces of UI. Now the account has been verified, which means I can go ahead and log in if I provide the correct password and email address. But before I do that, I want to show you something else. So if I come back here and then I click this link again, so I click it again, the same thing is going to happen. The system is going to process the request, verify, and then I get a similar message. But there's a difference. You can see now it says account already verified, whereas before it says account verified. So the system is smart enough to understand that this user account has already been verified, and it's smart enough to recognize that this link is valid. So this is a valid link, but the only thing is the user has already verified the account. So this is things that are very small, but they really enhance the user experience. And that's what you want to build in your application. So I can click on login here and then go to the login page. But since I already have it open here, I'm just going to close these tabs, and then I'm just going to come back here. And then now I put in the correct password. I'm just going to go ahead and try to log in again. So I'm going to click on login, and you can see the error message disappeared. I didn't close it. It disappeared because the state is different when we're in login state. And you can see that I entered the system. So I've been successfully logged into the system. Now I'm going to tell you a little bit about this application. So this application, obviously it's not a real application. I just made it up. So this application, what it's doing is it's managing customers and invoices. So we have a bunch of customers and we're going to be sending them invoices. And this is a business requirement that I just made up so that I can show you how you can build this. So what we're doing is we have a bunch of customers, say they have their own business or whatever the case might be. Maybe there's services that are being provided to them. And our company is to just keep track of these customers and then just bill them. So we're going to send them invoices so that we can collect the money from them. We don't care where the service is coming from. We just get a lot of requests to send bills or invoices to these customers. And this is a very practical example because there are true real world applications that are just doing exactly what we're doing here, even though ours is imaginary. And a customer can be a person, they can be an institution, as you can already tell here. You can see some of them are institutional and some of them are individual. So we can have customers that are people and customers that are actual businesses. The one thing I want you to understand is this application has two main features. The first feature is what the application actually does. So customers, invoices, managing customers, and we have also these statistics at the top here. So that's one feature of the application. The second feature, which is very important, is the user feature, which is where we're going to manage the people that are accessing the application. For example, the user that I just created. And we're going to spend a lot of time going through these two different features and all the things that we can do. And I'm going to start with the user feature, and then we're going to dive into the customer/invoice management, which is what the application is. So you just saw that I just created an account and I logged in. By default, I have this picture because I haven't uploaded the picture yet. And if I click on this, I can either log out or I can go to my profile. So if I click on my name here, you can see that it takes me to my profile. Now in my profile, you see that we have two sections. The first section is information about the user. So profile, password, authorization, their account, and their authentication information. And then at the bottom, we have account activities, which is another feature that you see a lot in applications that you use today, because you want to keep track of who is accessing your account, what's being done, etc., etc. You can see that the device that was used was a Linux desktop and the user was using Chrome, and the IP address, in this case, that's my network IP address or my local IP address. And if this application was deployed, like actually deployed on the internet, then that would be the IP address of the computer of the user that tried to access your information. Either that would be you or some random people trying to access your account. And also the type, so what really happened. And you can see here that we try to log in, which is the first time that we tried to log in. So there was a login attempt. And then the second time there was another attempt, but this time we were able to log in successfully. So we're logging every different activity that is occurring on the account, which is really important because as you log in, you can tell that, okay, I didn't do this. I think this is something that somebody else did, or somebody else was trying to log into my account, and you'll be able to see their IP address, which means you'll be able to somewhat track them and maybe determine their location, and you can actually report that. So all these features are implemented. Obviously, don't want to go over every single one of them if I can remember. So I'm trying to keep it short, but still give you a very good overview of the value that this course has to offer you if you're trying to be a full stack software developer from the back end to the front end. And when I say backend, I'm not just talking about the backend code. I'm talking about taking the business requirement, turn that into a design, and then build a database design, and then build the backend, build the front end, or build the front end, or build the backend. So we're going to go through the entire software development cycle, and that's exactly what this course is going to teach you. But that's the account activity. Now, before I go through every single one of these tabs and show you exactly what we have implemented in the user feature, I want to log out and then show you some of the things that you can do. For example, when you don't know your password or whatever, and then how you're going to reset your password, how that's going to work. We're going to come back here in just a minute. So let's go ahead and log out. So I'm going to go ahead and log out. Okay, so I've been logged out successfully. Say that I forgot my password. So I can come back here and then click on forgot password. Again, I'm going to pass in this email address, and then I'm going to click reset password. Same scenario. That's going to be disabled. Input is disabled. Links are disabled. Now, once the password has been reset, they send me an email so that I can reset the password. You can see here, it say, hey, we send you an email to reset your password. Now I'm going to go back to my email, and then I'm going to go back here and then refresh. And you can see I have a reset password request. So that's the request that I just put in to reset my password. So I'm going to open this email. Now I have another link, which is very similar to the previous one, but the only difference is it's a password verification. So I'm going to go ahead and click on that. Now the system is going to take this request and then again process it. And now after the system processes the request, we get this form where we can enter a new password. So here, I'm just going to put 1, 2, 3, 4, 5, 6 zeros, and then I'm going to do the same here. Well, before I do that, I'm going to put some random password here just to show you what would happen if I don't have the same password. So if I click update password, I get a message, password don't match, please try again, because, you know, my passwords didn't match. So I'm going to do 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Now I put 6 zeros. And as you can see, my password has been reset. So now I just changed my password and I can log into the application with that new password. So I just wanted to show you how you can reset your password if you wanted to. So now let's go back to the application, and I'm going to click on the account login, pass in this again, put in my new password. So if I put the old password, of course, it's not going to work. I can just show you that. And you can see it says bad credentials, incorrect email or password. So let's put the new password. Okay, that's 6 zeros, and then I'm going to log in. And you can see that I'm now logged into the application. Another feature that I want to show you is that when we reset our password, the link that we get is valid for 24 hours. So before we go in again to show you all the features of the user, let's go ahead and log out one more time. And what I'm going to do, I'm going to go ahead and log into the database because of course this is my application. So I have access to the database. I'm just going to log in and then change the expiration date on that link so that I can show you that if the user let 24 hours pass, then they won't be able to use that link anymore. They have to reset the password again. So for example, if I go back to my email and then I'm going to close this because we don't need it anymore, and I'm going to click that link again. So I'm going to go ahead and click it. You can see the same thing is going to happen. The system is going to verify, and here it says the link has expired. Please reset your password again. So if you let 24 hours go by and then you don't use that link, then that link is going to be expired and you're going to have to request another password reset. So I just wanted to show you that feature because this is also really important. You don't want to put some URL out there that is indefinitely valid. You want to make sure that you control everything in your application. So now this user will be forced to reset the password again and then get another one that's also going to be valid for another 24 hours. All right, so let's go back to the application and I'm going to close this tab. There is one last feature that I want to show you before we go back in and then look more in detail at the user feature, is that if I put in my correct email address and then I keep putting in a bad password. So for example, I'm going to put a bunch of 5. What I'm showing you here is how we can mitigate brute force attack. Okay, the email address has to be correct, which means that's an actual user in our system. So let's say there's a hacker and now all they have to do is to figure out what the password is, which is something that we don't want, but the email is correct. If the email is incorrect, we're just going to tell them, hey, we couldn't find an account by this email, which we saw in the beginning. But now the email is correct, but the password is incorrect, which is what hackers do. They might write an algorithm, put it in a loop, and then they put a break in the loop until it's successful, and then they just keep hitting your system. So for example, if I keep doing this, so let's do 1. Okay, let's do 2. Okay, again, we get the same error, and that's 3. Okay, same error, 4, same error, and then we're gonna do 5. All right, let's do 6. And now you can see that on the 6th try, my account is locked because I set it within a 15-minute window and 6 attempts. So if you try to log in 6 times within 15 minutes, then the account is gonna be locked, because we don't want someone to keep hitting our system with a correct email and then trying to guess the password. Another thing you can do, which I'm just thinking about now, is to show them how many tries that they have left. So when they do it the first time, maybe we're just gonna let that slide. And then if they do it the second time within the 15 minutes window, then we can say, hey, you have, 5 more tries left. That just came to mind, but maybe in the course when I'm teaching you, then I might touch on that. So you can see now the account is locked and the user can't access the account anymore. At this point, there's nothing I can do. There's no link that I can click on to unlock the account. But if you want, when you're implementing this, if you want to take it a step further, you can give them a link to unlock the account, which is usually not done. Usually when the account is locked, you have to contact some administrator so that they can look at what happened. Maybe someone else was trying to log into your account. So maybe that's not a feature you might not want to implement. But I just wanted to show you another feature that we have, which is to mitigate brute force attack. Okay, so like I said, I have access to the database, so I'm gonna go ahead and log into the database and unlock this account, and then we're gonna proceed to log in, and then I'll show you the features inside of the application. We're still gonna be looking at the user feature, because the user feature is actually one of the main features of the application. We're gonna spend a lot of time building the user feature, because in most applications, if not all applications where you have to authenticate a user, building that user feature is very, very important, and it's a lot of time consuming. So we're gonna spend a lot of time on that in the course. Once you learn and understand everything, you'll see how easy it will be for you to take this a step further and then implement more features that are more specific to the applications that you're building. So let me log into the database and then unlock this account, and then I'm going to log in again, and then we're going to continue. All right, so we've logged in successfully into the application. Now what we're going to be doing is looking at the different features of the user. So let's go back to the profile. You can see that I have all my information here, and the password, again, I can change my password internally. I have to provide the current password and then a new password this time. And in the authorization, this is where I have my roles and my permission. So you can see that this user has role user, and their permission is to read user and read customer, which is why I can't change any of this information. You can see that if I go to my profile, everything is grayed out, and this is by design, because we don't want these users, they have only users role, to be able to change anything. And this is really important, because if this is your company, you want to make sure that you control the access inside of the application itself, because you don't want everyone to be able to do everything. And then in the accounts, that's where we have all the account information, so I can unlock my account, I can activate my account or deactivate my account. And then in the authentication, that's where we have multi-factor authentication, which is something that I haven't shown you guys how to do, but in this course, I'm going to teach you how you can set up multi-factor authentication, and we're going to be using the phone number for that. We're going to send a verification code to the user's phone number, and then they need to enter that code so that they can log into the application. Otherwise, even if they have the correct email and correct password, they won't be able to access the application because they have multi-factor, or in this case, two-factor authentication set up in their account. The activity log here is just to show this information. So sometimes you might not want to show this information. So then you will just click on this and it will just disappear. And then you can click it again, then it will appear. Also, you can see in the log, I have a lot of different attempts. So this is where I put in the bad password. So that was a failure. And in all these behind the scenes, I didn't record this. I forgot what password that I put in. I kept typing in 1, 2, 3, 4, but you guys didn't see this. And then I remember it was like 6 zeros. So that's why we have all these login attempts. I just wanted to clarify this. Now, what I want to show you is I can, of course, come here and change my profile, but I can't because I don't have this permission. And by default, when you create an account with the application, an admin has to give you more permission, because when you create an account, you become a user, as you can see here. So what I'm going to do again is to go back in the backend, and then I'm going to make this user an admin so that they can change the information. So I just made this user a system administrator. So now I can either refresh the page if I want to, or I can just log out and log back in, and then everything should be enabled, because if you're a system admin, then you can access everything. So I'm going to go ahead and refresh the page, and you can see now everything is enabled. Okay, so you can see I can, put in an address, a bio, a job title, and everything. So the first thing that I want to show you is in the authorization. So if we go inside of the authorization here, I've already shown you guys the password, pretty much the same feature. So we're going to put a new password here. and then this is gonna, load and then tell us that the password was changed. So I'm not gonna go through this again. I'm gonna go into the other features. So the authorization is where we can change the roles. You can see now I have role admins, and the list of permissions is a little bit more. So now I can read, I can create and update, and that is true for customers and also for users, which is why now we can change information on our own account and also on users account. I didn't show you that earlier, but when we had the role user here, and all these roles are coming from the database, by the way, they're not hard coded in the front end. All of these roles are roles that exist in the back end that I'm showing here. So yeah, I didn't show you that earlier, but the user didn't have this icon. So now we can change our picture if we want, and I'm going to do that in just a second. And also, if we were to go to the home page and then we check one of these users, for example, or customers in this case, then we wouldn't be able to change their information. Okay, all of these would be grayed out, but because we're an admin, then we have access to change all this information. So let's go back to our profile. And the first thing I want to do is to just change my image here. So I'm going to click on this icon and then go to pictures, and I'm going to choose my picture here and then click select. And that changed my picture. As you can see here at the bottom, we have profile picture updated, and the picture was updated here also in the navigation bar, and I didn't have to refresh the page or anything like that. So again, you can just choose a different role here. I just chose role sysadmin. I had admin before. Now I'm going to be sysadmin, which is an elevated permission. Now, if I save this, you're gonna see that this is gonna change. That list of permissions is gonna be more because now I just elevated my role or my permissions. You can see now everything has been updated. I have these two new permissions that I didn't have before, which is the delayed customer and then the delayed user. So the sysadmin has the most power. The admin has power, the manager has some power, but the admin and the sysadmin, they have the most power. They can delete. Only the sysadmin can delete. And of course, you can take this and manage it however you want. You can choose who can do what in your application. I'm just giving you an example here. So that's for the authorization. And then for the account, this is where we can make the account active or inactive. You can just uncheck this and then click update. Obviously, I'm not going to do that, because then now I won't be able to access the account because this is account unlocked. It's not unlocked because this is not checked. So if I log out and try to log back in, I'm going to have to access this in the back end and then change it. So I'm going to put this back and then update it. All right, so our account is unlocked and it's also active. And then in the authentication, this is where I'm gonna enable multi-factor authentication because I want you to see that in action. So what I'm gonna be doing to show you this in action is I'm gonna be recording my screen on my phone. I have an iPhone, so I'm gonna be recording my screen. So you're gonna see that my screen is gonna pop up either on the right or on the left, and then I'm gonna show you how the message is gonna come in. But before I start recording my screen, there's something that I want you to see here. So I'm gonna go ahead and enable two-factor authentication because I want to secure my account more. So I want to make sure that when I log in, I'm asked to put in another code. So I'm going to click on enable, and this is going to send a request to the backend. The request is going to be processed. And then now you can see the message. It says that I need a phone number to change two-factor authentication or multi-factor authentication because we're going to be sending them a code. So if they don't have a phone, then it makes no sense that they have this enabled, because how else are we going to be able to contact them other than sending them an email? And we can't use the email anymore because it's a two-factor authentication. We need a different means to contact the user so that we can give them maybe a code or a verification number or something like that. So I just wanted to show you that there is a lot of logic into this application. And I know this video is getting really long, but that's because I really want to show you that this is not a course for someone who is not ready to become a software engineer or full stack software engineer. So if you're really serious, this is your course. This is for you. So let's go back to my profile, and I'm just going to fill in some of this information here. For the phone number, I also have another verification on it. So if you don't put in 10 digits, then it's not going to work because that's not a valid phone number. And I'm just not going to show you that this time. Maybe in the course as we're building this, I'll show you all these other features that we're doing that we don't have time to go over in this demo. But I'm going to put in my real phone number, and I'm just going to go ahead and blur it again because that's my real phone number and I don't want to expose my number. So I'm going to put in my real phone number. And I'm just gonna fill in everything else. I'm gonna do 101 Main Street, New York or something. That's not a real address, by the way. And let's do software engineer. And all right, so just to fill in this information so that we have something here. So I'm gonna go ahead and update my user profile information. And of course, make sure you're using a real phone number if you're testing this, because otherwise you won't be able to log in. So I'm gonna go ahead and update this. And again, once I update, all the inputs are disabled and I have the loading here. So now we have a phone number. Again, if we didn't put a real phone number, it would give us an error, say, hey, this is not a correct phone number. Just make sure you use a real phone number. Now I'm gonna go back to authentication, and then I'm gonna enable multi-factor authentication again. And now you can see it's been enabled. I have user updated, and then now I have the enable. Now, if I go and log out and log back in, you're going to see that I'm not going to be able to log in. I need to put in the code that I get in my text message in order to be able to access the system, even though I put in my correct username and password. So I'm going to go ahead and log back out, and I'm going to paste this in again. So the same email, I'm going to put my password. Now, before I click on login, I'm going to go ahead and start recording my screen. All right, so my phone is being recorded. So I'm recording my phone screen. And then now I'm going to click on login. And then now it's asking me for a verification. And if you heard this, this is the message that I got. So I'm going to open that message. We need to put in the verification code in here. So even though I put in my correct information, I'm still asked to put in the code because I have two-factor authentication set in my account. And you heard when the SMS message came to my iPhone, you heard the sound. I'm going to go ahead and turn the sound down because I don't want to disturb the recording. One thing I want to show you is I'm going to put in a bad code, okay, just to show you what's going to happen. So now I'm going to click verify code. And you see now it tells me the code is invalid. So let's go ahead and put in the correct code that we see on my phone. That's CLAYVBX and A. Okay, so this is the correct code. Now, if I click verify again, you can see the message went away because we're in a different state. And you can see verification code sent to my phone number. I'm only showing the last 4 because we don't want to expose the phone number of the user. And now we're back into the system. So every time we log in, as long as we have two-factor authentication set up, we're going to be asked to put in the verification code. So that's a feature that I wanted to show you in action. And all these things that you actually see in, real world application, either your bank application or a Facebook or social media application or any other applications where you have an account, you don't really see people show you how you can actually do this. And this is what we're going to try to address in this course, like real world scenarios, like how can we actually do this? We have a lot of tutorials everywhere on the internet, but a lot of them don't actually show you all these things. And these things are very, very common in the applications, and nobody's showing you how to do this. And that's what we're going to be doing in this course. So I don't want to get a message every time, so I'm going to go ahead and disable this. All right, so now this is disabled. I have stopped recording my screen. This is all the user features that we're going to be having. So the profile information, the password management, which we're not going to go over because I'll show you that when we're not logged in. Authorization, where we can change the different permissions, which is going to affect how the application is displayed to the user or what the user can access in the application. Also the account, so the account where we can unlock or inactivate the account or whatnot. And then the authentication, where we can set up multi-factor authentication to make the application more secure. So this is some of the features of the users. I'm pretty sure I'm forgetting some other stuff that I'm not really thinking about. And also at the bottom, you can see all the different account activities that we have. So the settings we updated, the profile picture was updated, we logged in again, the role was updated. So all of these different things are here. And if something is wrong or we feel like we didn't do something, then we can report it. Of course, the device that was used, the browser, the computer, the IP address of the computer, that's my local computer. But if that was on the internet, then it would be the internet IP address, so you know like who is trying to access your system. So now let's go back to the home page. So we can either click on the secure capita at the top, or we can click on home. So now we're back to the main actual application, like what the application actually do. Everything we just looked at is just for the user, because say that the requirements were we need to manage the users, manage their permissions and all of that. So just to quickly show you what would happen. So now that I'm a sysadmin, say I wanted to take a look at this first customer here. So I click to view, and then I can access their information. You can see everything is unlocked. So if I go back here and say I go to my authorization, make myself a user, update this, and you can see now I have a lot less permission. Now, if I go back to customers and I try to view the customer again, now everything is locked. Okay, so those are usually things that you would want in your application because you want to control access to the application. Sometimes you don't even show some pieces of UI because the user doesn't have a certain permission. So let's go back and make myself a sysadmin, which I'm going to have to go back in the backend and do. So I'm going to go ahead and log in the admin portal and then change that. So I just changed myself again to the sysadmin, and then I'm going to refresh. All right, you can see now I have access. So now let's look at the actual features of the application, which is the customer/invoice feature. So like I mentioned before, this is where we're gonna manage customers and invoices. And really, I just made this up because I was just trying to think of something that I can use as an example. So here we're just using customers and invoices. So at the top, as you can see, we have the menu. So I can click here and I can create a new customer, put in the customer information, or I can go to all customers. Now, when I go to all customers, this is different from the homepage. You can see that I don't have the statistics anymore. But if I go to the homepage, then you see that I have all the stats and also the customers. You can choose to put the invoices or the customer information or even more statistics, whatever you want to put here. It's up to you really after you've gone through this course. The only difference is when you're on the homepage, then you don't have access to the search. So you can see there's a search here that I don't have access to, as opposed to if I go to all customers where I don't have the stats, then I have this form that I can use, for example, to search customers here. So for example, if I put a lowercase e here and then search, we have one page now. If I remove this and then search all customers, now we have two pages. As you can see here, we can navigate to these two pages. So these are the customers. And then if we view a customer, for example, we're just gonna see their information that we can update, their status, if they're active, information about their email, what's the name of the institution or the person, how much we have billed them, and how many invoices that they have. And all the invoices would be displayed here. For example, let's see if I go to this guy, you can see that he has one invoice. So you can see total invoice is 1, and then we've billed them a total of 150. So that's just a quick stat that we're keeping track of. And of course, the profile detail information. And we can update this information. For example, I'm going to give this guy a middle name, for example, and then update. Again, this has been updated real quick. We can change the status, whatever the case might be. So let's say we go to customers. We can create a new customer. For example, I can do John. Let's do John Doe. So that's going to be John Doe. And then here we're going to say John D at gmail.com. We give him some address and some phone number. Say they're an individual, well, that's the name of a person, and then their status is, for example, pending. Okay, and then we can give them an image. I don't have any image. I'm just gonna put some. I can actually take an existing image. So let's open this in a new tab and just copy this image address. Oh, that's a person. Let's copy this guy here and then paste it in here just to make sure that they look okay. So save that. And you can see the customer has been created, the form has been reset. So now if we go back to customers and we go back to the second page, you can see this guy is here, John Doe, and their status is pending, they're individual. So that's the adding a new customer, and then we can go to all the customers, which is this page that you're looking at here. Let's go back to the first page. So that's all for the users. Pretty simple. Again, you can add more features if you want, but that's pretty simple. And one last thing is we can search that I already showed you. So you can put the name of the user here. So for example, if I put J, for example, I should get all the people with J in their name. You can see here, John Doe, Josh, etc. Say I put GE, then I get this guy here, Jean Pierre. Okay. All right. So that's pretty simple. And if I don't put anything, I search, I get everybody back. So let's go back to the home page. And one last thing, you can see this little icon here, which is the Excel icon. This is to generate a report. So sometimes we might want to send some report to someone, and we might want to send them a spreadsheet of all the customers that we have. So if I click on this, what's going to happen is there's a process in the back end. It's going to look at all the customers, grab them all, create a spreadsheet, and then send it over to the front end where we can download that spreadsheet. And that's in relation to reporting, because a lot of times when you have applications like this, reporting becomes really important because you want to be able to pull different reports. Sometimes there is regulations where you have to actually produce reports every quarter or something like that because you're being probed by some government organization or institutions. So if I go ahead and click on this X here, you can see that I have a report that's been downloaded. So that's the customer report. And then I can just open it just to show you guys what it looks like. And if I bring it over here from my other screen, you can see that we have an actual report. Okay, so we have all of the information, the ID, name, email, type, etc. So now we can use this spreadsheet to do data analysis or send it to someone else, etc., whatever the case might be. And again, I'm on Linux, so this is why I have LibreOffice. In your case, it will probably be Excel. So I just wanted to show you that. And this is the case again for the customers and for the invoices. So if I go to invoices here, you can see I have the same icon and it's just going to download all the invoices. So back to customers, just making sure that I cover everything. So I think that's everything for customers. And now let's go to invoice. So if I go to invoice, I can go to all invoices, again, see all the different invoices and their status, the date, and the total of the invoice. So I can go click on print. And now I'm presented with an actual invoice page. You can see here we go from home, invoices, and the invoice number here, which is the same as this number that you're looking at here for the invoice number. And we have the different services that were provided, the total and the tax. All of this is done dynamically. None of this is hard coded. And then the grand total of the invoice itself. Now remember that I mentioned this is to build customers. So we have the customers. You can see here, this is for Denise Robinson. If we quickly go to customers real quick and we'll search for Denise. So that's the customer that this invoice is for. Okay, so if I go to view, you can see that we have all these invoices here. So let's go back to invoices. Was it the first one that we clicked on? Yeah, it was the first one. What you can see here is just where the invoice is coming from. So this is us. So this is our application and this is who we're billing. Okay, again, all of this is dynamically generated. And then at the top here, I can export this as a PDF. And I'm going to show you what that looks like. So if I go ahead and say, hey, you know what? We need to mail this to this client or to this customer so that they can have a copy of it since this is already paid. So let's go back to invoices. Let's say this overdue one. Let's click on print. So this is for Jean-Pierre and we want to send this to Jean-Pierre because it's overdue and we want them to pay. So we can click on export as PDF. And you can see that it's been downloaded with the invoice number .pdf. Okay, so this is different from printing using Chrome. So I'm gonna go ahead and open this and then show you what it looks like. So let me go ahead and open my file explorer on my other screen, and then I'm gonna open it and then I'm gonna bring it over so you guys can see it. So if I bring it over here, you can see that this is an actual PDF file and you have the invoice number, and then PDF. And you see here that this doesn't include all the other page information because that's not what we want. We only want the invoice part. So we don't want this header. We don't want all this navigation. We don't even want this export as PDF to be part of the actual invoice. And I'm going to show you how we're going to do this. So we didn't do a right click and then print because that would look something more like this. Okay, so you see that we have everything that is on the page. That's not what we want, and this is not what I implemented in this application. So that's not what we just did. Let me bring this back up. So you can see here, we don't have all the headers, all these noise. We don't have all this stuff in the invoice. We only have the invoice, as you can see, with just the information that we need. And we're going to send this information back to the customer in this case so that they can pay us. Okay, so I just wanted to show you this feature. And the other thing that we can do is we can go ahead and create a new invoice. So if I go and create a new invoice here, I can put in the different services that were provided. And here I have the list of all the customers that I can choose from. So these are all the customers that I have in my system. And then I can just pick one and then create the invoice. So for example, say I'm going to pick this invoice date of the 27, and I can choose the different status. So either if it's paid, cancel, overdue, or whatever the case. Let's say in this case, it's being canceled, for example. And let's say this is for PCS radio, and let's say there was one service, and that was let's say advertising on radio, for example. And let's say that was for like let's say I don't know, let's say $450. Okay, so that's gonna be the invoice total. Tax is gonna be added later. So here we're gonna say, all right, the total is $450, and then I can save this invoice, and you can see that invoice added to customers. So now if I go to customers here, and let's say I search for PC, and then this is PCS radio, and then I view this customer, you can see that the new invoice has been added here. Now there's something that I forgot to put here, which is a class to show the status if it's paid, but you can see here this is cancel and this one is paid. So that's something that I forgot to put in the class for, but you can see that the invoice is here. And of course, I don't have to go to invoice and search the invoice to print it. I can just print it directly. So I can click here to print, and it's going to take me back to the page again, and then I can export it as a PDF. It's going to be downloaded, and then I can mail it to the customer. So this is something that I just made up just so that I can show you how you can build an actual application, but it's up to you, whatever you want this to be. You can take it and modify it or whatever the case. It's really up to you. The sky's the limit. You can take it and make it yours. And I don't know if you guys noticed, but now we have increased the total bill that we have and the total invoices. These numbers would be updated automatically without having to refresh the page. So I'm pretty sure that I'm forgetting something, and I know this video is very long for just a demo, but I just wanted you to understand that this application is for serious people only. So if you're serious about being a developer, you really want to learn, you really want to do this, then this is a course that you've been looking for. So make sure that you're ready for this, because we're going to be building building all these things, and I'm going to take you all the way from the backend to the database design to the Java application or Java/Spring Boot application, all the way to the UI application. Now, a couple of things that I want to mention before I close out here is that we have some backend functionalities that you don't see here. For example, we're using JSON Web Token to authenticate the user whenever they send a new request. So when I log in, I get a token. I have implemented refresh token. So automatically, if our token has expired, we have a refresh token that the system is going to use to get a new token. And then we're going to take that new token to make another request to the backend. This has happened automatically, so you didn't see anything. I don't know if I have any logs here, but I just don't want to get too technical. But there's a lot of other features like caching that is being done in the backend and the refresh token that is happening and a few other features that I'm just not going to get into because they are too technical for just this demo. But there's way more going on in this application that you can see with your eyes that I just demonstrated here. So if you're really interested and you really want to become a full stack software engineer, that one course can take you there. That one course can teach you that. And like I mentioned, I'm probably forgetting a few other features, and I know this video has already been too long, but all these things you're gonna see them in the course. So I hope you're excited, and my name is Junior. I'll be your instructor for this course. So without any further ado, let's go ahead and jump right into it. So you just saw the application in action, you saw the different features that we have implemented. And before we go into any code or anything, I want to give you a quick architectural design overview of the application. The application has two main parts. So we have the backend, which is the backend server, and then we have the front end, which is the client. So the server is an API and the client is just communicating with that API to manipulate the data. So that would be to create data, save data, update data, or retrieve data. And this is done using the HTTP protocol. So if you look in the middle, you can see that we have HTTP. So the communication between the client and the server is done over the HTTP protocol. The first thing we're going to be doing in the course is to focus on the server. So we're going to build the backend first. Now, I usually build the backend first in my courses, but I want you to know that it's not always the case. You can build the front end and then build the backend. So there's no really an actual order in which you should do this. You can build the front end and then use some mock data or some local data or some cache data, or you can just use some array inside of your JavaScript, and then you can use that to build the front end and make sure that it's working as expected. And then once you have the backend ready, you just switch all your services to make HTTP calls to the backend service and then retrieve the same data. So there's no real order, in building the front end or the backend first. But in this case, we're going to be building the server first. So we're going to be building the backend application first. We're going to be using Java and the Spring Boot tool, which is a tool that you use for Spring Framework. And Spring Framework is a framework for Java. Spring Boot, like I just mentioned, is just a tool on top of Spring Framework that just makes working with Spring Framework a little bit easier by providing a lot of predefined configurations and things like that. You will see that we're going to be using Java with Spring Boot, and Java is just a high-level programming language that is very object-oriented, and Spring Boot is really just a tool that is built on top of Spring Framework, which is a framework for Java. It's used a lot in building microservices and web application, but you can use Spring Framework to do other things with the Java language. But the backend is going to be built using Java in Spring Boot, and that's how we're going to create this microservice. I would say that you can, pause the video at some point and just look at the different components we're going to be working with in the backend. So you can see that everything goes through filters. So whatever requests that comes in, they go through a number of filters, and then they go inside of resources, which then communicates with a service, and the service communicates with a repository, and the repository really is what's doing all the heavy lifting. So the repositories, they're communicating with the database either using JPA or SQL. They're communicating with the workbook API to generate the report, with the email API, and also with the SMS or Twilio API or Twilio API. I don't know how to say this. And this is really very, very, very high level. And I'm showing you this because I don't want to confuse you, because there are so many different parts to this application. And I think that it's going to be very beneficial to you to have this design in mind as you build the application. And we're going to be coming back to it and making sure that we're following exactly this design. And if you look at at the bottom, I have my SQL and I also have AWS RDS. So for the local development, we're going to be using an instance of MySQL, which is going to be in my network or in my local network. It's not installed on my computer, and I'm going to show you how I have an instance of MySQL that I can use using Docker. I don't want to get into that just yet. And then once we have the application deployed, then we're going to be using an instance on AWS, and I'll show you how to do that. And also worth mentioning, you can see that we're going to be using both JPA and SQL. I could use JPA to do all this work. I could also use just SQL to do all this work that I'm going to be doing in the app. But you have people that like JPA, and then you have a bunch of other people that like SQL. In my personal experience, from what I've seen in the real world in companies that I work with, SQL is actually used a lot, and JPA is also used. So that's why I'm using both of them, so that I can show you that you can actually work with both of them. And there's really one thing you have to keep in mind is I'm trying to achieve this specific thing. What tool can I use that will be the best tool for me to build this thing? So as a software engineer or as a person, you're always going to have a preference for certain things. You know, some people don't like Java, they like Python, and some people don't like Python, they just like Java, and some people don't even like backend, they like frontend, they like TypeScript, JavaScript. So you're always going to have preference. But when you building an application, it should boil down to, I'm trying to achieve this specific feature, I'm trying to build this, or I'm trying to solve this specific problem. What are the tools that are available to me to do that, and which one would be best suited for the job, taking into account many different things, you know, how expensive it is, how maintainable it is, etc. So you really have to understand this is how things actually work. You don't just say, hey, this is what I prefer, I'm going to use this specific thing. You're going to miss your deadline, you're going to build a crappy application. So you really have to go with what would work best for that specific scenario. So in this course, we're going to be using both SQL and JPA at the same time, because in my opinion personally, I like both of them. I don't have any problem with writing all my queries. I don't have any problem with JPA either. And my preference personally would be, if I'm building an application that is a little bit complex, then I'm going to be using SQL, because I want to have full control of all of my database queries, and sometimes some of these things can get really complicated, so I want to be able to write all of my queries. But some other developers, they're like, hey, I want to focus on the code, I don't want to have anything to do with SQL. And if you really want my advice, I would say, if you're trying to be a real full stack software engineer, you want to have this top position, or you just want to do this for whatever reason that you have, maybe you don't want to work for anybody, but you have some other goals that you want to achieve, then I would say you have to look into the entire life cycle. So that's all the way from the database and all the way to the UI. And that's the true full stack engineer. So either way, you need to know SQL, you need to know how to manipulate the database, at least the basics. Even if you're going to be like a backend or a front end developer, you should know some database stuff. So make sure you look at this design, and if you have any questions, just reach out to me, send me an email and let me know. We can discuss it, and if you have some ideas, we can go over them, etc. So that's going to be for the server. And then for the client, as you can see, we're going to be using Angular, and we're going to be using TypeScript, because Angular by default uses TypeScript. So we're going to be using TypeScript. Now the second thing is, for the client, we're going to be using Bootstrap, and this is the only library that I would use for the front end, because it's really just HTML and CSS. There's nothing super crazy that is going on with Bootstrap. It's just a team that created a bunch of classes that you can work with and then build your UI. So that's why I'm choosing to use Bootstrap, because I don't want to use a UI tool that is too fancy, and it's going to take away of you understanding how you can manipulate the UI with the logic that you're going to be building in Angular. And if you want to do this by hand, like you want to write all your CSS, I don't know what applications you guys will have, you feel free to do that. If you want to build everything from scratch, you want to write all your CSS rules and everything, just go ahead and do that. But in this course, we're going to be using Bootstrap, and that's not going to take away anything from the learning of manipulating the UI, because it's not something like Material UI, where you have a bunch of pre-built components that are not real HTML components. So I didn't want to do that. I didn't want to introduce another layer of complexity in the UI. So we're going to be sticking with plain old HTML and CSS, and we're going to be building all of these functionalities that you saw using just Bootstrap to make it look pretty. But we're not going to be using a component based library like Material UI or something like that. And also for the application state, you can see that I'm going to be using RxJS observables. Now RxJS observable is the next level. So whenever you're working with Angular, you really have to master or have a very solid understanding of RxJS observables, because they're the core of this framework as far as I understand it. A lot of the different things or the different different modules that are built around Angular, they're using RxJS. So you really have to make sure that you understand this. And I have a lot of free courses on RxJS and how you can work with it in Angular applications. So if you need a refresher, just make sure you take these free courses. And that's what we're going to be using to save the application state. There is another library called NGRX. It's using the Redux pattern to build a store for working with the application state and Angular application. And this is really another level of complexity that you really have to understand. So I didn't want to use NGRX because this application is going to be so complex, and I didn't want to introduce another library into that. So the next course that I'm going to have is going to be using NGRX. But for this course, we're going to be using observables to save the application state. But as a standard for Angular application, really, I would say one of the best ways to manage your application state is to use NGRX. But in this case, I'm going to be using RxJS observables and save the application state in different components. And this is really interesting for you to master, because once you understand how you can do this, then it will be a lot easier for you to work with NGRX, which is, like I said, another layer of complexity. So we want to make sure that we build a very good, solid application, but at the same time, we're trying not to make it too complex, because I know some of you guys might not have a lot of experience. Some of you guys will have some experience. Some of you guys will have a lot of experience. But for those of you who would like to see the application state being managed by NGRX, the next course that I'm going to have, which is going to be coming out soon, is going to be using NGRX. And in this course, I'm going to explain the differences between, RxJS observables to work with the application state and NGRX. But for this specific course, we're going to be sticking with RxJS observables. So again, for the client, make sure you look at everything, make sure you understand what we're doing. I don't want to go over what you're looking at already, because you can already see what's happening here. We have components and they're waiting for some user event to trigger some action and then reach out to the state. The state might reach out to the service. Service is going to make HTTP call, but these calls can go through interceptors, and the interceptors can look inside of a cache to see if we already have the data. If we don't have the data, then we're going to make a call to the backend. So this is just a really very, very high level overview. There's a lot more details into this that is not being shown here. At least this is the picture you should have in your head when you're coming into this course, because you really have to understand the architectural design of what we're trying to build. So a backend, which is going to be the backend APIs, and then a client, which is going to be communicating with that backend to retrieve data, manipulate data, save data, etc. And then what we're going to be trying to do is to mount this entire structure onto Docker. So you can see at the bottom here, I have Docker. So we're going to Dockerize both the backend and the front end, and then we're going to deploy the application using Docker. So, and that's another layer of complexity as well. And Docker is so popular, I don't think it would make sense for me to go through this entire course and not show you how you can work with Docker for an application like this. So we're going to go into Docker, and I'm going to show you how we're going to Dockerize both the backend and the front end, and then have both of them running, and then have the application working using Docker in the Docker engine. So very, very high level. There's absolutely no details here, but this is very important because I really want you to understand at least the architecture of what we're trying to build. But for now, I would say you can, take a 10 minutes or a 15 minutes break and just look at this design and make sure you understand how things work with each other, and make sure you understand what we're going to be doing. And we're going to be starting with the backend. So we're going to be starting by building the server, and actually we're going to go all the way to the bottom. So we're going to be working with the database. We're going to configure the database and make sure we can have a successful connection. So that's going to be the first thing that we're going to be doing. All right, so make sure you look at the design, and then we're going to continue. Now, what we're going to be talking about is what you need to have for your development environment. So you just saw that we're going to be using Java for the backend, and I just opened my browser and just Googled Java. So if you don't have Java installed on your computer, I assume that most people coming into this course will already have Java installed on their computer, like a newer version of Java. So you can just search for Java, or you can search for Java JDK download, as you can see here. So you can search for the JDK, and you can download from Oracle. So make sure you have Java installed. And the other thing I would say is, if you have any latest version of Java, so anything from Java 1.8, then you should be good to go. I don't think there's going to be anything really specific to any version from 1.8 to now. I'm recording this video in August of 2022. So as long as you have at least Java 1.8, then you should be good to go. So if you don't already have Java installed on your computer, then go ahead and make sure you can install Java on your computer. Now, I'm not going to go ahead and show you how to do this. I'm assuming that you guys already know how to install Java. coming into this course. So make sure you have Java installed. And then I just Google Spring Framework. As you can see here, the Spring Framework is an application for the Java platform. So Spring is the framework that is a wrapper around Java that we're going to be using to build a backend application. Now, you don't have to do anything. As long as you have Java or the JDK installed, then you should be good to go. So you don't have to install Spring Framework or anything like that. And also, I want to talk a little bit about Spring Boot. You can see Spring Boot is here. It's really just a tool that is built on top of Spring Framework, and it makes working with Spring Framework a little bit easier by providing a bunch of configuration for you. Like there's a bunch of things that are pre-configured for you. It's also easy to make changes as well. So if you want to go in and then change those configurations to your liking, then you should be able to do that pretty easy with Spring Boot. So I just wanted to mention that. And again, you don't need to install Spring Boot or anything like that. I just wanted to go over it. And the next thing we're going to need is MySQL. Now, you can use any relational database that you want. In this specific course, I'm going to be using MySQL. So if you want to use Postgre, feel free to do that. That's no problem. And you will only have to make some very minor changes to the SQL queries that we're going to be writing. But I'm going to be working with MySQL. And I'm just using MySQL because it's so popular and everyone knows MySQL. So if you want to use Postgre, like I mentioned, just feel free to do that and make the changes appropriately to Postgre in the SQL queries that we're going to be writing. If you're learning how to use the SQL language, I would say start with MySQL. It's been around for a while. There's a lot of resources out there about it, so you're gonna find answers to pretty much almost all your questions. So if you're just learning the SQL language, I would say that's just my personal preference. You can start with MySQL. You can start with Postgre too. I like Postgre a lot. I work with Postgre a lot. But in this case, I'm just going to choose MySQL. And you can just install MySQL on your computer if you want. I don't have it installed on my computer. I have it running in an instance in Docker. But that's the same thing, really. It's just running in an isolated way, which in this case is just a container. So go ahead and just Google MySQL. Pretty much click on the first link and make sure you have it download and install and connect to it just to make sure it's working properly. So that's for MySQL. And then I'm going to be using the IntelliJ IDE because it's one of the most popular IDEs for Java. But if you want to use anything else, feel free to do that as well. You don't need to have the same code editor or text editor or integrated development environment as me. But I would definitely encourage you, if you want, you should probably use IntelliJ because it's just really good. So I'm going to be using IntelliJ for that. Another thing I want to say is IntelliJ is not free, so you might have to pay for it. I have a free version because I'm still a student, so I was able to get a free version. But if you want to have a lot of the features that we're going to be using, I think you might have to pay for it. I'm not entirely sure what it would look like right now if you don't have a paid version, because I haven't had the paid version in years, which means I've been a student for so many years. So I don't know, but I'm going to be using IntelliJ IDE. I have the paid version for free, and hopefully you can have the paid version as well. But that's the tool that I'm going to be using. If you want to use something else, feel free to do that. You're still going to be able to follow along. It doesn't really matter. And these tools are only for the backend. So the Java JDK, make sure you have that installed, and then make sure you have MySQL installed, and make sure you have some kind of text editor or code editor or integrated development environment that you can use to write your code in. When we're going to start working on the front end, I'm going to have another video like this, and I'm going to go over the different tools that you need to have for the front end. For now, I want to keep it simple. I'm just not going to talk about the front end just yet. We're just going to be focusing on the back end. So Java, MySQL, and then the IntelliJ IDE if you want to use that. Now, there's a few other things that I want to say before we actually start writing any code, and that's what I'm going to be talking about next. So just a few things I want to make sure you guys are aware of when you're taking this course. The first thing is this course is video based. So we're going to have all video lectures throughout the entire course. And I'm pretty sure you already knew that already, but this is a video based course where all the lectures are going to be in videos. And that's the only format that we're going to have in this course. They're also going to be presentations. So some of the videos are not only going to be about coding, but we're going to have presentation where I'm going to go over the concept. So the 3 points that you see in the first row. So video lectures, presentation, and then concepts. So in these lectures, if I'm going to talk about something new before we actually start writing any code, I'm going to have a presentation, and then I'm going to go over the concepts with you just to make sure that you understand from a conceptual level what we're trying to accomplish. And then after the presentation, once you have a pretty good understanding of what we're going to be doing, then we're going to jump into writing the actual code. So we're going to do the implementation of whatever we just went over in the presentation. And if you have questions, you can ask me questions. So I have questions after writing code, but you don't have to wait until we at the writing code to ask your questions. So during the presentation, when we're going over the concepts, if you have any questions, of course, reach out to me and make sure you clarify everything. Make sure you're clear on what we're doing. So always ask your questions. Make sure you understand everything before you move on to the next section, because I don't want you to be confused and not get the best out of this course. So video lectures, this video lecture is going to have a lot of presentation. These presentations are going to be going over the concepts. Once we understand the concepts, we're going to be writing the code. And if you have any questions, make sure you ask me your questions. And the best way to do this is to just send me an email as your instructor. So just email me whatever question you have. And if you're having a problem with the code, just send me a screenshot of, the code that you think is giving you the problem, or the stack error that you have in the console. You can attach whatever screenshot you want to show me the error that you're getting with your questions. And then lastly, we have resources, and these resources can be either resource that I think is really important for something we went over, like a concept or something. So I can give you some links to some articles where you can go and read further about them. And the second resource we're going to have in this course is the source code. So make sure you get the entire source code, both the back end and the front end. So that's going to be the entire application, the way that it's going to be built at the very end. But in every section or in every module after we implemented a feature, I'm going to give you the source code for that as well. So as we progress through the course, you're going to have the code for that specific progress that we made throughout the course. So for example, if we just went over the UI for the login page, then I'm going to give you that code. So you can take that code and you can look at it and make sure you understand what it's doing. And then say in the next module, that's when we're going to be building the functionality to, log the user in. Then I'm going to give you that code as well. So as we go through the different sections and through the different modules, I'm going to give you the code for that as we build it together. So resources can be external links. So things that I think are really important for what we're learning. So you can go and read. Probably going to be a bunch of links or articles or PDF files that I think will be useful for your learning. And also the source code. The source code is going to be the entire source code. So the entire finished built application source code, and also the source code for every section or every module in the course. You're going to have that source code as well. So make sure you understand this coming into this course. It's important for you to have an idea of the format of the course so that you can get the best out of it. And questions, really make sure you ask those. So whatever question you have, there's no silly questions, there's no bad questions. If you don't understand anything, something is not clear, and maybe like you search on the internet, you couldn't find an answer, or you just want to ask me, then feel free to do that. I'll answer every question within 24 hours. So it's never going to take me more than 24 hours to get to everyone with their questions. So I think that's everything you need to know coming into this course. What we're going to be doing next is actually getting our hands dirty. So we're going to go and start building the application and start putting in the first configurations. So I'll see you guys in the next one. Right now, I am at start.spring.io, and this is a website that you can use to bootstrap a Spring application. So the project is going to be Maven based, so we're going to let Maven manage our dependencies. It's going to be using Java, and 2.7.2 is fine with me, so I'm going to keep the default here. And I'm just going to change some of this information. So here I'm going to say Ohio, I get arrays, and delete the rest. And we're going to call this secure, and I need to spell that correctly. All right, now what we have to do is to add our dependency. So we're going to click on add dependencies, and then we need the web dependency because that's going to be a web application or a RESTful application. We need the MySQL, so we're going to say MySQL. So that's the driver to connect to the MySQL database. We're also going to need Spring Security, so we're going to install Spring Security here. JPA, so we're going to say JPA. And select that, and we also need JDBC, so I'm going to say JDBC, and that's the second one here. So Spring Data JDBC, and we're also going to need Lombok, so I'm going to do Lombok, and I think we need validation, so let's do validation. This is going to allow us to have some validation with some of the incoming requests coming in, so we can use that, and you're going to see how this is going to play out in a minute. And I think that's everything we're going to need for now. I'm using more dependencies than just these, but these are the ones that I'm going to get from Spring Initializer, and everything else we're going to add a little bit later in the course. So let me just change the description here. Okay, so application to manage invoices and customers. All right, so make sure you have all of this in place. Well, actually, you don't even have to have this in place. You can put whatever you want here, whatever name you want your application to have. It doesn't have to be the same name. All right, so once you have all this in place, you just click on generate, and that's gonna create a zip file, as you can see here. So what I'm gonna do is open IntelliJ, unzip this file, and then open the project in IntelliJ, and then we're gonna continue. So I unzip the folder and I have the application open in IntelliJ. And the first thing I want to do is to just check the POM file. So let's open up the POM file and let's make sure we have all of our dependencies. So we have the starter JPA, JDBC, Spring Data JPA, we have Spring Security, we have the validation, and then the web for our web service, the MySQL connector, Lombok, and the tests. And down there we have the security tests. Okay, so we have all of our dependencies. Now we're gonna be coming back here and add more dependencies into this as we need them throughout the course. There's probably like 5 more dependencies that we need inside of this POM file. And we're gonna also add some profile configuration for when we deploy to different environments. So we're gonna be doing all this as we go through the course, but I'm not gonna do them now. The second thing that I wanna check is to make sure that the application is running as it is right now. So because we have the MySQL connector dependency here, if we try to run the application, it's going to give us an error because it's going to look for some kind of a data source configuration. So we can quickly put that in. So I'm going to open the source, expand the main, and inside of the resources, I'm going to expand that. We should have this application.properties file. Right now it's empty, and I'm going to go ahead and refactor that because I don't like to work with properties file. I prefer YAML. So I'm going to change it to YML. And then I'm going to click refactor. Okay, so this is done. I don't think we're going to need this template folder and this static folder, but we can just keep them for now. The configuration that I need to put in is the configuration to the database so that when we run the application, just to test it to make sure it works, it doesn't fail. So let's do Spring, and we want to do, let's do data source. So data source, and we want the URL. So I'm gonna pass in URL, and here I'm gonna say JDBC, and we need my SQL, and then // and I'm gonna put in where my SQL is running, and that's a computer on my local, that 168, and that's 1, and that I think it's 216 if I remember correctly, and it's running on the same port, so 3306, and we want to connect to this database called secure. Okay, so that's the name of the database, and then I can pass in the password, and I think it's let me in. Okay, so this is our development environment, so this password is fine, and the username is going to be, so the username should go up here, and it's the root, I believe. Okay, so this is for our local environment, and this has to go over here. So we're putting in the data source configuration, and I think we need let's do JPA, let's do database dash platform, and we want this to be org.hibernate .dialect .my SQL 8, and we're gonna say dbd dialect. Okay, and this has to go back once because it's under GPA, so we're gonna move this back once. And another configuration we need is the DDL, so we're gonna say generate DDL. We're gonna set this to true, and we need the show SQL. We're gonna set this to true as well, and we need the hibernate, and I want the DDL auto, and we're gonna set this to update. Okay, under, we can pass in some more properties, so we're gonna say properties, and here we're gonna say for hibernate, and let's do globally underscore quoted underscore identifier, and we're gonna set this to true, and dialect, we're gonna set this to the same thing, and then I want the format underscore SQL and set this to true. I think that's all we're gonna need for now, and I need to copy this and paste it here, and we don't need this part. Okay, so MySQL 8 dialect, and I need to put one more, and that's gonna be under Spring, and that's SQL, and we're gonna do init, and we're gonna set the mode to never, okay? Because we don't want this to run because we don't have any SQL statements for now. So this is for SQL. And whenever we have our queries, we're gonna change this to always so that the application can run the queries against the database. And this has to be under Spring, so I'm gonna move it back once and move everything back once. Whenever we have all of our queries and we want the application to run the queries against the database, then we're gonna change this to always. And we're only gonna do that like once, or if we want to crash the database with all the tables and then recreate them again, then we're gonna change this to always. But you're gonna see how I'm gonna be using this. So that is the data source configuration. I don't think I have this database created, so I'm gonna copy this name, and then I'm gonna open my SQL workbench, and then I'm gonna create this database. So let me open the workbench, have it open on my other screen, and I have this connection, which is the connection to my local network, as you can see here. So the same IP address, 192.168.1.2.16. I'm gonna create on this icon here, which is create a new schema, and then I'm gonna paste that name. So we want this secure capita as the name of the database, and then I'm gonna click apply, and then apply, and then finish. Then I'm gonna minimize this. Now, if we run the application, we should get the application running and a successful connection to this database on my local computer here in my network. So let's go ahead and take this for a spin. I'm gonna go up here and then click on this green button. So let's click that and let's see what happens. All right. Okay, so everything seems to be working fine. We didn't get any errors, so that means the connection to the database was successful, and we have the generated password, so we know that Spring Security kicked in. So everything seems to be working fine, and I just wanted to make sure that the application was working before we do anything. So if you're getting any errors at this point, make sure you get the application to run at least for this first time, and then we're gonna come back to it in a minute. So the configuration, you should have it, so make sure you have it. It's gonna be in the resource, so you don't have to type all this stuff by yourself. You can just copy and paste it, and it's pretty straightforward. We're just setting some configuration for the database connection. So what we're going to be doing next is to work on the user login. So the user login in the backend is the first thing we're going to be working on. And then once we're done with the user, then we're going to move on to the customer and invoices. So the first thing is we're going to make sure that we can get the user feature working. So the user login, the user permission, and all this stuff. And that's what we're going to be working on next. What we're going to be doing next is going through a process called data modeling. And the first thing that I want to do is to describe what data modeling is. So data modeling is the process of creating a model for the data that we would like to store in our database. And this is a step that a lot of developers just like to skip, so they don't like to go through the data modeling process. But it's actually really important that you do that because you want to have some kind of representation of your data model before you actually start writing any code or anything like that. So I would say if you're designing an application, and it's an application that's going to be used by some customers, it's an application that will be deployed in the real world, then you should definitely have a data modeling process that you go through so that you can design the model for the data that you want to store in a specific database. Now this process, the data modeling process, it has 4 steps. The first one is to understand the application requirements. And this one is usually a pain because you have to go to so many meetings and ask so many questions, and there's just a lot of back and forth involved in this step. But for us, it's going to be really easy because this is not a true real world application, because we came up with this application. So we define the requirements ourselves, which means we already know what the requirements are. But in the real world, there would be a lot of meetings. Say you were building this for someone else or for some client, you would need to clarify so many things. So there would be a lot of back and forth, a lot of emails, and you would at the end have a documentation of the application requirements, and that would be a base to start your different models, like you can see here, the conceptual model, logical model, and physical model, because you need something to go off of, and that would be what you would be going off of, the application requirements. So we already have the application requirements, and I'm just going to go over the requirements again in a document just so you can see what we're going to be trying to do. But the first step in data modeling is to understand the application requirements. Now, once you understand the application requirements, you're going to move on to the conceptual model. Now, the conceptual model will just identify the things or entities that the business will have and the relationship between these entities. So it's just a visual representation of the concepts that you actually share with the business or business people, because it's not very technical. So you might have some squares to represent the entities, maybe some lines that connect the entities with each other, and you would describe the relationship with them. So that would be a simple conceptual model. And then we have the logical model. So the logical model will be the data structure for storing the data. It's really a refine of the conceptual model. However, it is still abstract and database technology agnostic. So in the logical model, you're not going to have anything specific to any database management system. So it's still going to be very abstract, but it will be the structure for storing your data. So in other words, it's just a refine of the conceptual model. And we're going to have examples of all of these. So I'm going to be going through the process with you, so you would see what every single model would look like if you were to just design your application going through the data modeling process. And then lastly, we have the physical model. So the physical model, again, is a refine of the logical model, and it's going to be very specific to a database management system such as MySQL or Postgre. And it's also the implementation of the logical model with the exact syntax and data type and relationships and all the tables, the default values, the primary keys, the views, the stored procedures, etc. So in the physical model, you have to be very specific to the database management system that you're going to be using. So the biggest difference in the physical model is that it's very database technology specific. So you have to be very specific in your data type and the relationships and the primary keys and the default values that your model will have in that specific database management system. And what that means is that if for some reason you decide to use a different database management system, say you were using MySQL, but you want to change to Postgre, then you can use the application requirements, you can use the conceptual model, and also the logical model. And the only thing you would have to change is the physical model, because really that's all you're changing. So everything else that you did will still be used because that's the model of the application. So that's the advantage of going through the data modeling process and have a model for your system. So you can give that model to anyone, and they can use any database management system to create the physical model, and then they will have the same application that you have. So this step is very important when you're designing an application, and that has to be done before you start writing any code whatsoever. And that's the data modeling process. And again, it has 4 steps. The first step is to understand the application requirements. The second step is to create the conceptual model, just identifying the different entities in the business and their relationships. And then we have the logical model, which is going to represent the data structure for storing the data. And then finally, you will have the physical model, which is going to be very specific to a database management system such as Postgre. And in the physical model, you have to use the syntax for that specific database management system. So that would be the data type should be defined, the relationships and all the tables should be defined, the default values, the primary keys, if there are any views or any stored procedures, all of these should be defined in the physical model. So what I'm going to be doing is to show you every single one of these 4 steps in action. And the first thing we're going to be doing is going over the application requirements. And then we're going to start designing the different models. And once we have the model to represent our data, so once we're done going through the data modeling process, then we're going to start writing the code that we need to actually have an implementation of all of this. This process in itself is helping you taking something that is written, in this case the application requirements, and then turn it into a data model to store the data that you want in a database. So it's a very important step. A lot of developers like to just skip this step, but it's really important, and I would encourage you to always incorporate that step in your application development process. So let's go ahead and dive into each one of these steps.
I just want to take a minute so that we can go over the requirements for this application. So this document is typically something that you would get from like a business person, and there would be like a bunch of meetings that you would have to go to, and they would take a lot of time and then come up with some requirement documentation that they would then pass maybe to your manager or maybe your tech lead or something like that. Since one of the goals is to try to give you a feel of what it's like to be in this field, so I went ahead and just created the document myself. But I just want you to know that that this is something that you would get from your business or your customer. And when I say customer, I mean the person you're building the application for, what they want. And there would be like a bunch of meetings. Some of these meetings you would have to go to them. Some of them maybe you won't have to go to them. Maybe some of them your manager would go. I mean, it depends on the organization and etc. But the point is, after a lot of meetings and talks and all that, there's going to be a document that they're going to give to the team or the development team. And it's going to look something like this, like a bunch of requirements that they want the application to have. Some of these would be ambiguous and you would have to go back to the business and ask them to clarify. And sometimes these change when you start building the application because there might be like some performance issue that is raised because they're trying to do certain things and then you propose different ways to do it. So there's like a bunch of back and forth communication that's going to take place until you can reach to a point where everyone agree that we can build the application that way and it's going to meet the requirements of the business. And that's what I'm trying to replicate here. Now, we're not going to go through all these meetings or anything, and I just create this by myself, but in the real world, it would probably look something a lot more verbose than what you're looking at right now. This is just me putting down some of the points that I want to have and then talk about them, which we're going to be building in the course. But just so you know, this is something that would probably come about after like a zillion meetings or something like that. But it would be your application requirements and it would be what you would go off of whenever you're building the application, and your team will like sit down and prioritize what would make sense to build first and what we would do later and everything. But in any case, you would have your application requirements. And for our application, so what we're going to be doing in this course, we're going to be focusing on two main features or two different set of functionalities that we want to provide inside of the application. So the first one is going to be the user. So the user logging into the application and using the application, we have all these requirements for them. This is a requirements file that I created. By the way, it's a markdown file, and I have an extension in my browser, as you can see here, so that I can make a markdown file look a little pretty. And I'm going to give you that as well as part of the resource of the course. But in this documentation, we're going to have the user, so all the features that we're going to be building for the user feature, and then we're going to do the same for the customers and the invoices. So these two can be combined to be one, but I just put them on two separate lines. But going back up, for the user feature, we need to handle the account creation. Every user should have an email that is unique. So that's going to be how we're going to differentiate one user from another. In addition to the primary key, that's going to be their ID in the database. Email address is going to be also unique to every single user. And the business want for us to send an account verification, which is going to be a link. They want the user to have a profile image, and the user details information should also be captured. So name, address, email, phone, position, etc. And I put the phone in bold here because the phone is so important for the two-factor authentication. So I put it in bold, and then being able to update this information as well, which you saw in the demo of the course. And then passwords reset when the user is not logged in. We have to make sure that we can allow the user to reset their password even when they're not logged in, and we're going to give them a link that's going to expire after 24 hours. So we're assuming that this is a requirement from the business. That the business say, hey, our application is sensitive. We don't want people to have access to a link that's indefinitely valid, whatever. And then they say, make it expire after 24 hours. And of course, user login. So we're going to be handling user login. They're going to use their email and the password to log in. And we're going to give them a token, and that's going to be a JSON web token, and also refresh token that's going to be refreshing seamlessly, and then give them a new token so that they can keep using the application. So in a lot of cases, you would have to define how long they want this token to be valid for, because the refresh token can be valid for a longer period of time, but it will also expire at some point, which is going to prompt the user to log in again. But typically you have the token that the user is using to authenticate that's going to expire in a very short amount of time, and then this one is going to expire in a longer amount of time, but they both will expire at some point. And then the business also want us to mitigate brute force attack by using an account lock mechanism. So we're going to be implementing that, and say the business wanted 6 failed attempts before you try to lock the account. And also role and permission based application access. So access control inside of the application is based on role and permission. So the business say, hey, we have all these different people, they're going to be working in the same application, but we want to have a way to control the access inside of the application itself. Now in the demo that I gave you, I didn't use the full potential of these roles and permissions because I just wanted to give you an idea as to how you would be able to do that. But in your application, you will be using these roles and permissions all over the place to make sure that each user has the proper access and nothing less and nothing more inside of the application. So we're going to be using roles and permission to control the access inside of the application. And then two-factor authentication. Again, the business say, hey, we want our app to be very secure. And they might even say, hey, we want to require every user to have two-factor authentication. authentication, but you usually don't see that it's required unless it's like an internal application that is not for the public to use, like some inside application that an organization is using, they might require that. But typically for like, say, like a social media application, you wouldn't be required to have two-factor authentication set up. They might encourage it. Even with bank application, they might encourage you to have that. They might say, hey, you need to set that up just to be on the safe side, but they don't usually like require it. Like it's a hard requirement to have that. It's good to have. It's another layer of security. So we're gonna be doing this for the business because they want the users to have access to do that in the application. And then of course, lastly is to keep track of the user activity on the account and also have a way to report that. And the information they want us to track is the IP address, device, browser, date and type, etc. Whatever the name that we think that we can do, we're just gonna go ahead and do it for them. So all of this is for just the user feature, so the application user. And then for what the application does itself is going to be managing customers. So they want to have a list of customers that they can manage and keep their information, so name, address, etc. Customer can be a person or they can be an institution. And customer should also have a status. For some reason, the status is in bold because the business say, hey, this is really important to us. Maybe like they're going to do some reporting, or maybe they're not going to work with customers that are banned or something like that. But for whatever reason, the status is really important for them. So we really have to make sure that every customer has a status and then they can use that for whatever purpose. And then customers will have invoices. So they want to have a way to create invoices for those customers and then print all the customers in a spreadsheet. And then search customers. So they want to be able to search customer by name, and they want the customers to be laid out in different pages. So they don't want to have to go through a long list of users. They want to have different pages that they can go through and then see all the customers like that. And then lastly, the invoice. So they want to be able to create invoices, add the invoices to customers, print the invoices so that they can mail them to customers, and then have them print out also in a spreadsheet. Maybe they're going to do some data analysis on them, whatever the case might be. And also they want to have a way to download these invoices as PDF files so that they can mail them. So this third point here and the last one can be the same because they want to be able to just print them or download them, but they want it as a PDF. And that's what we're going to be doing for them. So obviously we're not going to start building everything at the same time. And like I mentioned before, we're going to be working first on the application user. So everything we're going to do is going to be, for now at least, is going to be concerning the user of the application. So we want to make sure that this feature is built. And then once this feature is built, then we can start working on the customer feature and the invoices feature. So that's all I wanted to go over with you guys. And you're going to have a copy of this file as well. But if I right click and go to view source, you'll see that this is a markdown file. You can see all the markdown syntax and everything. I like to use Markdown a lot. I like to use my terminal, and I have Vim installed on my Linux computer. Right now I'm using my Windows computer, but a lot of this work is actually done in my Linux computer because I like to use Vim mostly when I'm working with text, because I can type so much faster and get things done a lot faster when I'm typing in Vim than when I'm typing in a typical editor. But you will have this file and you can just take it and take a look at it. You can use it as a starting point as well if you want to add or remove things or features in the application requirements, because I know a lot of you are just going to take this application and then make it your own. So you can use that file as well as a starting point for the application requirements. All right, so what we're going to be doing now is to start designing this entire feature, because right now you can see we have a lot of things we have to do. So we can't just start doing things and don't know what we're doing. So the first thing is we have to design how we're going to capture all of this information and meet all these requirements that the business is asking us. So next thing we're going to be doing is to start designing this entire architecture and see what it's going to look like.
The first thing that we're going to be looking at is the conceptual model. Now, if you remember, the conceptual model identifies the entities and the business and their relationship to each other. So we just need a very simple representation, or visual representation in this case, just to see the different entities that we're going to be working with and the relationships that exist between them. There are many tools that I think you can use to do that. You can use Microsoft Visio and a bunch of other online tools, but I just want to talk a little bit about UML and entity relationship diagram. So one of the tools that you can use to do that is called UML. And as you can see here, I just Googled it. It's Unified Modeling Language. Now, this is very generic, like it's used in so many different applications. And when I say applications, I mean in many different disciplines. Like you can use it to do very different things that actually don't have anything to do with software development, because it's such a generic tool and there's a lot of implementations of it. So you can use any UML tool that you want to use, or you can use entity relationship diagram. So entity relationship diagram is more geared towards software development. So for example, if I click here on images, let's click on the first one, for example, you can see that this is usually the starting point of some database management system design. You can see the different entities, the strong and the weak entities, and the relationship between them. So for our case, I'm going to be taking the entity relationship approach because it's more aligned to what we're trying to do. But you can use any UML tool or the UML language, which is a general purpose language, as you can see here, to do that as well. But typically in the software development world, you would see that entity relationship diagram is used, and you can use either one really. They're just going to give you a visual representation of whatever it is you're trying to design. So it doesn't really matter in this case. You can use either one. And what I'm going to be using for this is a free tool that is an online tool called draw.io, and I'm pretty sure you guys are familiar with it. If you're not, you can just Google it. Actually, I can just Google it while I'm here. So if I do draw.io, or maybe just io, and then search it, you'll see it will take us to this flow chart here. And also notice the URL is different now, so it's app.diagrams.net, but for the longest time it was just draw.io. And if I click on images here, you can see here that it's just an online tool that you can use to create your design, and then set the relationships between the entities or whatever it is that you're creating. You can use whatever tool that you already know that you have that you can use to do this, or anything else, as long as you can create a visual representation of the conceptual model. So when you go to draw.io, it's gonna look something like this. So you have a blank sheet, all of the different tools on the left, and I also have the application requirements open here. I'm just going to give you a very subtle example of what that would look like, because I want you to really understand how this whole thing works. What I'm going to do is I'm not going to look at every single relationships and every single attribute that we have here, because we have a lot of them. What I'm going to be doing is showing you how to do this using code, which is going to be the SQL code that we're going to be writing. But I do want you to see how the data modeling process goes. So looking at the requirements, there's just at least two things that I can already see, right? So we're gonna have a user, obviously, and then say we're gonna have customers, right? We know that there's not a direct relationship between a user and a customer, right? There's a relationship between customers and invoices. However, there's a relationship between user and their role or their permission. So we can start with that, since we're gonna be starting with the user. We're not gonna be working with the customers just yet. All right, so say we wanted to have some kind of visual representation of what that would look like, and being able to go back to the business and show them what we're thinking. So in this case, we would go into our diagram and see if I can zoom in here a little so you guys can see better. And if I collapse the general and I go under, I think, entity relation, and here you can see that we have all the different things that we can play with. One that I'm going to use is this one, which is entity, but you can use this one as well, which is more like a table. But for the conceptual model, we don't really need one that is like a table, because we're not going to be specifying any primary key or anything like that just yet. This is not what the conceptual model is about. So let's grab the entity, and I'm gonna scroll over here and zoom in a little. So this is gonna represent the user, so I'm gonna change this to user. And then what we're gonna try to do is try to capture some of the attributes that we know we're gonna have in the user. So I'm going to select everything here, and let's say we're going to have a first name, for example. So first name, well, let's use camel case in this case. And then last name, so we're going to have a last name for the user, obviously an email. And then let's say they're going to have a password. Okay, so we can just start with these for now. So we know we're going to have a user, and then I'm going to select everything by just left clicking on it, do Control C and then Control V so that I can duplicate it. And then over here, I'm going to put the role, okay? Because we know that the users, they're going to have roles. So now we have role, and then now we need to capture the attributes of the role. So the role is going to have a name, and they're going to have permissions. Okay, so that's going to be like all the different permissions that this specific role has. We can now define a relationship between the user and the role, and I'm going to go to the left here and scroll down, and you can just over these, and they will tell you what the relationship is. Now the relationship that we need, at least in our application, is a one-to-one relationship, because a user can have one role. Now that role will have many different permissions, which is why you see here I put permissions in plural. So what I'm going to do is go to the left here and just search for a one-to-one. You can see this one-to-one. I'm just going to click it, and then I'm going to drag this over to the role, and then drag that other end to the user. Zoom in, make sure this connects. All right.
and zoom back out. So now we have a simple relationship between the user and the role. So we know that every user is going to have one role, and then we can put a label on here. So I can double click that line. It's going to bring in this text box, and then I can say just has, for example, and maybe I can increase the size of this, make it a little bigger, just like that. So this is everything we really have to do for the conceptual model. So we would say we would have a user, and that user will have a role. And because we define a one-to-one relationship, we know that every user will have one role, not more, not less. So this is a representation of our conceptual model here, and that's all we'll have to do. And notice that I don't have any ID, I don't have any data type, I don't have any of these things. I like to think of the conceptual model as just boxes and then lines between them, because that's really what you're doing, because you don't want to get too technical and then confuse your business, okay? Because you usually use the conceptual model for discussions with the business, so you don't want to be too technical because you don't want to confuse them. But if I was doing this and actually going through every single one of these attributes, obviously these would be like a lot longer with all the different attributes. But I'm going to give you just a sense of the data modeling process and what it looks like. So this would represent our conceptual model, and we're going to build off of this model, and we can also use this model to have discussions with the business because it's not super technical. So this is a representation of the conceptual model. Next, we're going to be looking at the logical model. Now we're going to take a look at the logical model. And what I did is I just made a copy of the conceptual model, and then I renamed it to logical model. And we're going to start building off of what we already had in the conceptual model. Now, what we're going to be doing in the logical model is define the type of these attributes that you see here. This is not going to be specific to any database management system or any programming language or anything like that. We're just going to define what these attributes are going to be. So for example, for the name here, I already know that the name is going to be a string. So I can come up here and in parentheses, actually you have to do that in parentheses. I'm just going to say this is going to be a string, and I'm going to do this for all the other attributes. So I'm going to copy this, go to the last name and then paste it, go to the email and then paste it, go to the password and paste it as well. And also let's give this user a phone. So we're going to say phone, just so I can show you something different. And in the phone, let's say we're going to store the phone as a number, for example. In the application, I know I'm saving the phone numbers as strings. But the reason I put number here is to show you that you're going to have to come back to this and refine it. So whatever you do the first time is not the final product, and you are allowed to go back and make changes. And I'm going to do the same thing over here to the role. So I'm going to paste this again. So that's going to be a string, and the permission, that's also going to be a string. So notice here, I don't have anything like varchar or anything like that, because varchar is specific to a database management system or a database management system. We're just defining what these attributes are going to be, what type of data they're going to be. Say that I wanted to know the time that a role is assigned to a user, because a user can have the role user, and then later we can say, all right, we're going to change them to role administrator, or maybe role manager, or role finance, or something like that. So say that we wanted to capture when a specific role was assigned to a user. Obviously, we can't put that information inside of the role, and we can't put that information in the user because it just simply doesn't belong to any of these entities. So that means that we're going to need a third one. So I can copy this, and I'm just giving this as an example. Let's say, for example, user role, for example. Okay, so in the user role, we can capture a few things. So for example, we can say, for example, time, and here we can say, well, this is going to be a date, let's say a date time, for example, and that's going to represent the user role. And here we're going to have other attributes like the role ID, the user ID, but remember, this is the logical model. We're not dealing with those things yet. So now what we have to do is to remove this and then recreate the relationship. So in this case, I'm gonna go ahead and move this over here and select it, make a copy, so copy paste, and go over here and then change that relationship here. Okay, so it's still gonna be one-to-one. One user can have one role. So in the user role, it's still gonna be a one-to-one relationship. But now, since we're in the logical model, we just dig a little bit deeper, and also we specify the data type that we're gonna be working with. So say, for example, I was dealing with product, for example, and I wanted to register a price. I'm just gonna put it on the user, but that's just for me to show you what I'm trying to illustrate here. So here, for example, I'm gonna say price, and just gonna make this a little bigger. So for the price here, I would say something, for example, like a float. Okay, so that's a floating point number, which is just the general way of describing a decimal point number. Notice here, I don't have anything like double for Java or decimal for MySQL. I just put float to indicate that this is going to be a decimal number, but I don't use any specific programming language data type to describe this. So that would be what you would be doing in the logical model. And I'm going to go ahead and remove that. This would be a logical model. Now, it wouldn't look like this because we're not actually looking at all the different attributes and everything that we're going to be doing just yet, but I'm just walking you through the process of how you would do this. If I were to do this, it would actually take me a lot of time, and you would usually have a team that would just go and start putting all this thing together. But I do want to show you how applications are designed. You have to do your data modeling, and that's what the logical model would look like. And next, we're going to be looking at the physical model. Now we're going to take a look at the physical model. Remember that the physical model is a refine of the logical model for a specific database management system. In the physical model, we actually have to tailor everything to a specific database management system such as Postgre or MySQL. And for this again, I'm going to show you a small example of what that would look like. But what I plan to do is to show you how we're going to write all of this in SQL, and then we're going to do a reverse engineering so that you can see the model that we're going to create. With that being said, since we have to use a specific database management system, for this case, then I'm going to open my SQL Workbench. So I have my SQL Workbench open. What I want to do to show you this example is to go over to File, as you can see here, and then create New Model. So you just click on New Model. It's going to open this MySQL model page or a GUI for you. And as you can see here, it's creating this database called MyDB. But if you right click on this, you can edit schema. And for example, let's say this is going to be the secure copy tab, right? Because we created this database in a previous lecture. So we know that our database is going to be named secure copy tab. What we're going to do now is to just click on this add diagram button. So I'm going to click on this or double click it, and it's going to open to this page. For the physical model, remember, we have to be very specific with the syntax, with the data type, the relationships in all the tables, the default values, the primary keys, the views, the procedures, everything. First thing I'm going to do is to recreate everything that we had in the logical model. So I'm going to click on this icon here and then click here, and that's going to create a new table. And then I'm going to double click that, and you can see here I can change the table name. So since we're using MySQL and we need a physical model, so I'm using the MySQL Workbench to do that. In your work or in your situation or in your particular example, it doesn't necessarily have to be MySQL Workbench. So if you're using a different database management system such as Postgre or Oracle or Microsoft, then that's going to be whatever tool that they have available for you to create these data models. But in our case, since we're using MySQL, which is very easy for everyone and very common as well, and they also have a lot of resources online, so if you have questions, you can just Google stuff. You're probably going to find all the answers you're looking for. And that's also another reason why I chose MySQL. So here we're going to go ahead and change this to users. Notice I'm calling it users now because I'm trying to be specific to MySQL, and usually table names are plural. So in this case, I'm naming it users, and then I'm going to click anywhere outside of this box, and then now you can see that this is named users. What I can do is I can add columns. You can see here, I can double click that. I can start adding things. So the first thing I'm going to do, well, not user ID, I'm gonna add the ID, okay, and that's gonna be a big int. So I'm gonna say big int. This is gonna be a primary key, so you can see primary key is checked here. We also have not null and also unique, but I guess if it's primary key, it's gonna be unique, so we don't have to click that. And then I'm gonna do this AI here, which stands for auto increment. So that's gonna represent the ID. And then we can go down here. I can do first name. Again, I'm using underscore because in MySQL world, you have to use underscore. So I'm going to change that to 50, and this is going to be not null because we always want to have a first name, and it doesn't have to be unique. Everything else can be unchecked. And then I'm going to double click again, and then we're going to do the last name. So we're going to say last name, and that's also a varchar of 50. I'm setting 50 here for the number of characters, but depending on your use case, you can change that to whatever number you want, up to 255. And just expand this a little just so we can see what that looks like. So you can see this is coming together. Let's do maybe like the email
and we're gonna do varchar of maybe 100 because we know that emails can be long. This is also gonna be not null because we always want to have an email, and let's say the phone for now. So we're gonna stick with just these. So the phone, and maybe we can do something like 20. Okay, it should really be 10. We're being a little bit lenient, so we're just gonna set it at 20. Now we have all of these different attributes that we know exist on the user table or the user data model, and I'm just gonna go ahead and expand that so that I can see all of the column names. What I'm gonna do is to copy this, so Control C, Control V, duplicate and move it over. I'm gonna change the name of this to say roles. So that's gonna be the roles. So the roles are gonna have a primary key. They also gonna have a name. I'm gonna set this to 50 characters, not null, that is good. And then we're gonna have the permissions. So here I'm gonna say permissions. Permissions, I'm gonna set it to the max because the permission is gonna be a long string. So I'm gonna say 255, and it cannot be null. It doesn't have to be unique. And then everything else I can just delete. So right click, delete selection, right click, delete selection. This right here is gonna represent our roles. Okay, so this is the role table. Also notice that at this point, you're using your actual knowledge to design the data model. So the way that you actually want the application to work, the way that you're going to code it, that's actually what we're doing here. So I'm going to click on this again, Control C and Control V, click on duplicate, and I'm going to go ahead and change the name as well here. So double click that. And this is going to be the user roles. Okay, so this is the table that's going to represent the relationship between the user and the role. And let me move this over here, just so we can see everything nicely. So we have the user, we have the roles, and then we have the user role. So what I'm gonna do is to just delete this. So delete, delete. The user role is going to have the ID. So that's going to be the primary key for the user role. And then we're going to have the user ID inside of this table. And also we're going to have the role ID. We need to set some relationship between these three tables. So if you look on the left here, you can see that we have all of the different relationships that we need. And remember, we're going to need a one-to-one between the users table and the user roles table because one user can only have one role at a time. And then we need another relation between the roles and the user roles. So to establish this one-to-one relationship, I'm going to click on this one-to-one as you can see here. So I'm going to click it, and then I'm going to click on the user roles, and then I'm going to click on the users. Now you can see that the relationship is established, and also the user ID is put into this user roles table. And all I'm going to do is to just rename it to like user_ID. So that's the first thing that we need to do. In our model, so if we go back real quick, you can see that I said that the relationship between the role and the user role is going to be a one-to-one. But this is actually incorrect because the same role can be repeated in this table many times for different users. So the relationship between the role and the user role is a one-to-many. So I'm just gonna select this and delete it, and then I'm gonna go to entity relation, and then I'm gonna look for this one-to-many. So this is the one-to-many. I'm gonna click it. So we're gonna move this over here, and then move that over here. Okay, so we have our one-to-many relationship. So one role can be repeated many times in this table. So this is the relationship that we actually need. So now let's go back to the workbench, and then I'm going to click on this one-to-many relationship, click on the user role, and then click on the role table. So now we have a one-to-many between the roles and the user roles, and the one-to-one between the users and the user role. So this is the relationship that we actually need here. And again, I'm going to rename this to role_ID. So this would be our physical model. You can see now we're being very specific, and we're also fixing things that we're just realizing like, oh, this is incorrect. And then we go back and make some changes to our model, and then use that model to recreate our database. And this is how this process actually works, because the first time you're never going to get it right, and you're always going to go back and refine the initial design that you had. So let's go back to Workbench. Everything looks good. So that would represent our physical model. One more thing I want to bring to your attention, which is really important whenever you have relationships like this, is the foreign keys. You can see that we have this little diamond icon here next to the user ID and the role ID. And that's because those are considered foreign keys in this user roles table. So whenever you have foreign keys, you need to tell the child table, in this case the user roles table, what's going to happen if this key is updated in the parent table. Meaning if the user ID is updated in the user users table or if the role ID is updated in the roles table. And this is very important to do because you want to have consistency and data integrity in your database management system. So if you look down there, you see we have this foreign keys tab, and I'm just going to go ahead and click on it. And you can see the two foreign keys that we have for this specific table. So before you click on the foreign keys tab here, make sure you have this table selected. You can see the user roles table is the table that is selected here. And then I go to foreign keys tab, and then I can see the two foreign keys. And if I click on the first one, for example, so that's the user ID, and look to the far right, you can see that we can specify what's going to happen when the parent table is updated. So that means that if we update the user ID, then what do we want to happen in this user roles table? And we have a few options. So if I expand this a little, you can see we have restrict, meaning we're going to stop the action from happening. We can cascade, which is a fancy way of saying update. We can set it to null, which is not really used very often because then you're going to have an orphan record, meaning there's going to be a record in the user roles table. And for example, the user ID is going to be null. So if you had that, then we don't know who this record belongs to, and that's bad. So usually you don't use set to null. And no action is similar to restrict. So if you set it to no action, if we try to update the user ID in the users table, then it's going to give an error, say, hey, you can't do that. So no action is the same as restrict. Cascade is to update, and set to null is to just set the value to null, which you usually don't want to do unless you have a very specific use case. Now, first of all, you're never going to update the primary key in the users table because you never want to update a primary key. Primary key is not updatable. However, just in case that this were to ever happen, then what do you want to do in the child table? In this case, I want to cascade. So if we ever update the user ID, then I want to update that record in the user roles as well. And I want to do the same for the delete. So if we delete the record in the users table, meaning we delete the user, then we can also delete the role. So I'm going to set this to cascade. And we can go to the second key. So that's the role ID. And then we can do the same thing. So if the role ID is updated in the roles table, we want to cascade. If it's deleted, then there's no point in keeping this record in there. Then we can also cascade. Okay, so that's really important. Whenever you have foreign keys, you have to tell MySQL or your database management system what's going to happen if the record is updated or if it's deleted. At this point, you can consider the physical model complete. However, we haven't written anything on the database, like we haven't run any queries or anything like that on the database. And also, now that I'm thinking about it again, I think that if a role is being used in the user role, which means there's a user that is using that role, we should probably not let that role be deleted. So on delete here, I'm just gonna say restrict. Okay, so I think that's a better approach because if the role is being used in this table, then it can't be deleted. So on delete, we're going to restrict. So at this point, this physical model is complete, but we haven't run any script on the actual physical MySQL database system, which is what this model is about. It's the physical model. So what we're going to do is something called forward engineering, because at this point, this is still just a diagram, right? But we want to turn that into an actual database, like actual database with SQL code. So what we're going to do is forward engineering. And to do this, we just go over here and you click on database and you click on forward engineering. And that's going to bring this pop-up window here, and you can put the database information. So the database where you want this diagram to create the tables and everything for you. And also notice that we only have tables here, but you could have views, stored procedures, etc., etc. This all looks good to me, so I'm going to click on next, and I'm just going to leave all the default here. I'm going to go ahead again and click on next. We're only exporting tables, so we don't have anything else. So no views, like I just mentioned, no triggers, no store procedures. All of this is good. So I'm just going to keep the table checked, and then I'm going to click on next. And you can see now MySQL Workbench generated all the SQL code that we need to run against our database to generate the tables with this diagram and these relationships. So you see how this can be done. We went from just boxes and lines and then an actual logical model. And then from the logical model, we created the physical model. So the physical model is very specific to the database management system. In this case, I'm using Workbench for MySQL. But if you are using Oracle or if you are using Postgre, there would be like a similar particular tool that you can use to create these models and then translate that into the SQL code. So this is the code that we can actually use to run against our database to create all these tables and have everything ready so that we can start coding. You can copy this code, Control A and Control C, and then you can put it in some file, and then you can push it to your repository or wherever you want to keep it. Or you can just click on next, and it's just going to go ahead and execute the queries. So you can see it's done. Now I'm going to say close. If I go back to the home page and I access my database, so I click on this connection here. So if I extend the secret copy tag, and if I expand that, you can see our 3 tables are here. So MySQL ran the script and it created the table exactly the way that we designed it here with all the relationships and everything. And then we have this. Okay, so you can look here. If I select everything here, you can see we have all of the columns. Let's look at the users, for example. Everything is here, and we can click on this gear and it will show you everything that would define the primary keys and all the different values and everything. So this is what you would do typically when you're building your application, and this is using the forward engineering. There's also a reverse engineering where you actually write the queries first and then you generate this diagram, and that's what we're actually going to be doing. So you see here, I'm not actually using everything that we have in the application requirements because I'm just giving you an example as to how you would go about designing the application. So typically that's what you would do. You wouldn't actually start writing the queries and everything, but since I want to teach you how to write the queries, then we're gonna do the reverse engineering. But in most cases you do the forward engineering when you have all your different models, and then you turn that into a physical model, and then turn that physical model into actual code or SQL code that you can use on a specific database management system. In our case, that's MySQL. So this is the end of the data modeling process that I wanted to teach you, and in the end what we have is just the tables that we actually need for our applications. So you can see how important this is and how it ends with all the tables that you're actually gonna need. So that's the end of the data modeling process. What we're gonna be doing next is to actually use the application requirements and build all of this, but using the reverse engineering method. So we're gonna start with the queries and then generate this in the end. And when we're gonna be doing this, we're actually gonna be looking at the application requirements. So we're actually gonna be doing the real thing this time. But I hope this was very useful to you. And if you have any questions, of course, reach out to me and let me know. But that's how you would go about designing your application before you start writing any code or anything like that. And this is what's called the data modeling process. I want to start this section by just looking at a tweet from DevEd. And I don't know if you guys know DevEd, but he's a YouTuber and he makes videos online about tech and more specifically web development online. Maybe you guys are familiar with him, but the reason I'm showing you this tweet is because a lot of developers don't like to write SQL queries, right? So we have a lot of backend developers, and there are SQL developers, like developers that only do SQL queries, like they only write SQL queries to do whatever they do, generate report or write the queries for some application or whatever the case might be. But there's also a lot of backend developers. So those would be the developers working on the backend code. So that would be either Java or Python or Node, whatever the backend language is that they're using with whatever framework. These developers, they don't like to write queries, and that's what this meme or tweet is about. So developers don't like to write queries. They like to have object relational mapping, which is what JPA is, so that they don't have to worry about the SQL queries and write all of the queries. But the thing is, in most applications that you probably use on a daily basis, they use SQL. If you take an application like Twitter, for example, and say that Twitter was using the Java framework with Spring and everything. I don't know what framework they're using. I don't know what tech stack that they're using. I'm sure they're using more than one. But let's imagine that they were only using Java in the backend. There's no way that they would be able to use JPA to do everything that they have to do in Twitter, because they'll need to have many different tables in a database so that they can manage all of this data. So there's no way that they're gonna have JPA alone to manage all of this. There's no way that's gonna happen because the app is too complex. And when that happens, then you have to use SQL. And what I have seen in my experience is both JPA or any relational database mapper and SQL are used together. So that's what I've seen. And this is why I decided to, for the user part, at least in the application, we're gonna be using JDBC/SQL. The invoices and the customers, we're gonna be using JPA, but for the user, we're gonna be using JDBC/SQL. So we're gonna be writing all of the queries. And I can do both
with either JPA, I can do both with either JDBC, but I think it will be very valuable to you whether you would rather do just JDBC or you would rather do just JPA. Then you're gonna find something in this course, right? Because we're gonna be doing the customer and invoice part with JPA/Hibernate. But for the user, we're gonna be using JDBC/SQL. So we're gonna be writing all the queries, and that's what I'm gonna be doing in the next few lectures. So if you're a developer and you prefer just working with some object relational mapper like JPA with the Hibernate implementation, then that's fine, because we're gonna be doing that in the course as well. But if you want to use SQL/JDBC with Java, then we can also do that. And like I just said, in the real world, in my experience at least, I've seen both being used, because applications get so complex and you just have to use SQL because it's easier to just have all of the different joins with all of the different tables instead of working with a bunch of objects. But some other developers do it. Some other developers just stick with an object relational mapper like JPA. They just do everything with JPA. So it's possible as well. I'm not bashing either one of them. I just think that they're both really important, which is why I want to teach you both in this course. And you can choose to either go with JPA or Hibernate, whatever the case might be. And the last thing I would say is, whenever you have to choose, you have to really look at what you're trying to do. So if JPA is going to be enough for what you're trying to do, then just go with JPA. If you think you're going to need SQL because the application is getting really complex, or you would just rather use SQL, then just do that. There's not one that's better than the other in the grand scheme of things. Now, there might be some performance concerns that you might have to look at if you're using Hibernate with JPA, but in most cases, it will do just fine, unless you're talking about a large amount of data. So in most cases, either SQL or Hibernate will do the job, and most people will go with Hibernate because then they don't have to write all of the SQL queries. So it will really come down to you as the developer and the requirements and what you're trying to achieve. So whatever works best for you, just go with that. But in this course, I'm going to teach you both. So we're going to be using both JDBC and Hibernate with JPA in Spring Boot. So let's go ahead and jump right into it. I'm back in our application and it's exactly the way that we left it. The only thing is I added the files that we worked on. So the draw.io file, so you can see the conceptual model here, the logical model, and the physical model. Make sure you get these files and then you can take a look at these designs. And also I added the requirements. Okay, so the MD file, as you can see here, if I double click it, you'll have access to this file as well. And that's the file that we're going to be using to write all of these queries. So I'm going to close this. So make sure you get these files. So now I'm going to go open the source, and inside of the resource, if we expand that, as of right now, we have the application.yaml file. So that's the configuration file that we put in. I'm going to go ahead and create another file. So I'm going to go under resources and I'm going to do new, and I'm just going to go ahead and click on file. And this file has to be named schema.sql. So I'm going to say schema.sql and then press enter. Right ahead, you can see that it's asking me to configure a data source. Now you can just ignore this, but I'm just going to do it anyway, but you can just ignore that. So I'm going to click on configure data source and expand this a little. This doesn't really have anything to do with what we're going to be doing though. And then I'm going to click here and then I'm going to select my SQL. So here's my SQL. I'm going to name it my local connection. I'm not on localhost, so I'm going to change this to 192.168.1.216. That's where my server is running. And authentication user is going to be root. We're going to change this user, by the way, and the password. I think it's let me in. Save it forever. We can test the connection. Okay, that was success. Apply and then click OK. This message will just go away and it will open up this console. So I don't need this console. I'm going to go ahead and close it out and also close this tab. And now we're just in the SQL file. So here, the first thing I'm going to do is add in some comment, and I'm not going to type it out. I'm just going to go ahead and paste it and right click, and I'm just going to click on paste. All right. So this is just some initial comments. At the top is just some information about who created this file. And here are the rules that we're going to be writing our queries by. So just some general rules that I want to go over. The first one is to use underscore instead of camel case. Okay, so some people would use camel case, some people would use underscore, but I think generally speaking, you would see that underscore is being used. Like most SQL developers that I've spoken with in the past, they've told me they think it's underscore, but there's still some kind of an ongoing debate about this. But I think I like underscore better. So we're going to be sticking with underscore. And then the second one is table name should be plural. Okay, and I already touched on that. So instead of having user, we're going to have users as the name name of the table, and also spell out ID fields. So if you have some table named user and then the user have an ID, so instead of naming it ID, we're gonna name it user ID. The next one is don't use ambiguous column names. That's pretty obvious. And then use the name the foreign key column the same as the column that's referring. That's also another cool rule that I like to follow. I have to say I don't like to follow this rule right here. So spell out ID fields as item underscore ID. Personally, I don't like to use this. I know why it's important, mostly when you have a lot of tables and you have a lot of different joins, and assume that you're trying to match with the IDs. Okay, so if you have a lot of tables and you're gonna have, let's say, like 5-6 joins, then if all of the ID fields are just named ID, then it can be a little bit confusing. But if you use the item underscore ID, then it's a lot more clear when you have all the different joins in your query. So that's why this rule is important. So if I was building an application for a company or somewhere else, something that wasn't my own application, I would go by this rule. But when I'm building my own application, my personal application, I just use ID. It's just a personal thing, but it's not the best practice. The best practice is to use item underscore ID. So user underscore ID, role underscore ID, and not just ID. So I will be using just ID, but you probably shouldn't unless you also want to just use ID. But if you're going to work for someone else, or if you're doing an interview for a job, just make sure that you're going to use item underscore ID and not ID. Okay, so these are the rules that we're going to be playing by. We're just going to try to follow all the other rules except for that one, because I don't like to use item underscore ID. So I have the application requirements open on the right, and we have our schema open on the left here. And we're going to try to see if we can come up with how we're going to capture all of these requirements and then make the application work, right? Because we need to be able to respond to all of these requirements, right? We already saw that when we did the data modeling, but this time we're going to be using SQL, and then we're going to do reverse engineering to generate the same data model. Now we have to write all the queries to capture all of this information, and that's what we're going to be doing. So there's one last rule that I want to put in here. So I'm going to say use caps for all SQL queries. Okay, so that we can distinguish what is an SQL queries and what is just text or something like that. So I'm going to make some room here. So I'm going to just press enter, go all the way to the top. And in here, what I'm going to do is just try to create the schema. Okay, so create schema, and we're going to do if not exist. And that's going to be the secure capita. Okay, so that's the schema that we know we already have, and I just put it on here just to be safe. So if it doesn't exist, then it's gonna create it. If it exists, then it'll just skip this line. And I want to set our character, so I'm gonna say set names, and that's gonna be, let's do UTF-8 MD, I think it's MB4. Okay, so that's just a character that's a little bit bigger. And let's do the time zone. So set time zone, and I am in Eastern US, so I can do US/Eastern, and that should do the trick. And this is supposed to be equal. Another way we can do this is by doing set time zone, and we can set this equal to let's say -4, because I know for me it's -4, so that's my offset. So whatever your offset is, you can set it as well. That will do the same thing. I want to say to use this specific database, so I'm going to say use secure capita, because we want to use this database to write all these queries, and then we're going to start writing the queries for the users. So the first thing I'm going to do is I'm going to do drop table if exist, and that's going to be the users. Okay, so if the table already exists, then it's going to drop it and recreate it. And that's just something that I do every time. You don't necessarily have to do that, but I just like to do this. And then here we're going to go with create table. So we're going to say create table, and that's going to be the users table. So users, and that's where we're going to put all of the attributes. So open and close parentheses. I'm going to close this. So the first thing is we're going to need an ID, and that's going to be a big int. So we're going to say big int. That's going to be positive. So we're going to say unsigned, and that's also going to be not null. So we're going to say not null. It's going to be auto increment, and it's going to be the primary key. IntelliJ is helping us here, and that's really good. So this is the first item that we're going to need, or the first column. So that's going to be the ID. And then we're going to need the first name. So we're going to say first name. And that's going to be a varchar of, let's do 50, for example. That cannot be null, so we're going to say not null. And we also need the last name. So last name, also a varchar of 50, and that cannot be null either. So we're going to say not null. And let me scroll up a little. And then we need the email. So we're going to say email, also varchar. Let's do 255, maybe 50. Not 50. Let's do 100 because emails are usually longer. So 100 and also not null. And then we need the password. So I'm going to say password, also another varchar. And I'm going to do 255 for that one. And that one can be null. So we're going to say default null. If they don't have a password, that's fine. We can have a user without the password. And then we're going to do the address, also another varchar. That's going to be 255. Now, usually you would have a separate table for the address, but like I mentioned before, we're just going to keep it as just one string, and the default can be null as well. And then the phone, another varchar. We're going to do maybe like 30 just to be nice, and the default is going to be null. So we're going to say default null. And then we can do the title, also another varchar, let's say 50 characters, for example, and the default is going to be null as well. We're going to do the bio, another varchar. We're going to do 255 for that one because they can have a long string, and the default also going to be null. We have captured the email, user detail, position, bio, phone, address. We have to do the image, and let's scroll down a little. Okay, password length. This is more logic stuff. This is for authentication. That's good. So we need to have a way to capture the brute force attack. We need to have a lock and account active. Okay, so role and permission. So let's continue here. So the next thing I'm gonna need after the bio is to see if the user is enabled. So we're gonna say enabled, and that's gonna be a boolean, and the default is going to be, well, let's just say false. And we need to capture another boolean, so I'm gonna copy this and paste it twice, and here we're gonna say non-locked. Okay, so that's gonna help us capture if the account is locked or not. We should make this true. This is gonna be using underscore MFA. So if they're using multi-factor authentication, and the default is going to be false. And I think we can copy one of the varchars. So let me just copy that, paste it. And this is going to be the, let's do image URL. Okay, because we have to capture their image. You can see here, if you scroll up a little, they need to have an image. Okay, so that's the string that's gonna hold this information, and that string can be really long, so we're gonna say 255. And we also need to capture the date that the account was created. So let's do created date underscore date, and that's gonna be a date time value, and the default is going to be the current date time. So we're gonna say current timestamp. That's this, oops, timestamp. So that one. The last thing we have to do, we have to make sure that every user has a single email, which means we're gonna need a constraint on this table. So let's scroll up here. So you see here's a unique email address. So to do this, we're gonna do, for example, constraint. That's gonna be a unique constraint. Now there's a naming convention. So for unique, you're gonna say UQ for unique, and then the name of the table. So underscore, that's the users table, so we're gonna say users underscore the name of the field, so that's the email field. Now you don't have to follow this, maybe your company has one, but that's just the name of the constraint, and that's gonna be a unique constraint. So we're gonna say unique, and then we're gonna say which column it's gonna be unique, and that's gonna be the email. So this is everything, I think. All right, so we have profile, name, position, address. Okay, that's more functionalities, and using password reset link, that's the token. Brute force attack, we're gonna be using the account lock. This is more of functionalities again, and for the permission, we're gonna use a different table, so we don't have to put anything here for the roles and permission. Okay, so protect the resources using that. Two-factor authentication, we're capturing that with using MFA. So this boolean is gonna tell us if the user is using MFA or not. The image, so okay, so we have everything. And also for the account activities that you see here, we're gonna use a different table as well, and we're gonna refer the user ID in that table, so we don't have to do anything on the users table for that at this point. I think that's everything. Oh, and for the image URL, we give them a default, so whenever there is an account that is created, we don't ask the user to pass in any image, so we're gonna set a default. So here I'm saying default null, so instead of null, I'm gonna pass in a value. So this is the image that I'm gonna use. I can copy this and paste it here. You can see it's the same image that we have in the application. So by default, this is gonna be their image URL. So I think that's everything we need for now, and I'm just gonna go ahead and format this a little. So this is nicely formatted, and I think we have everything. So ID, first name, last name, email, password, address, phone, title, bio, enabled, non-locked, using MFA, the account was created, and the image of the user. So I think we got everything here. The next thing we're going to be doing is to see if we can work with the roles. Okay, so that's obviously the next thing we need to do. So we're going to be creating a role table, and then we're going to create another table that's going to establish the relationship between the users table and the roles table. Let's go ahead and try to capture the role of the user. So I already have a design in mind, and I'm just going to show you guys what I'm thinking, but you don't have to do exactly what I'm going to do. There are many different ways that you can assign roles and permissions to a user, but I'm just going to do it one way, but you can do it another way. So I'm going to go ahead and copy this just to save time. Scroll down here and then paste it. So again, I'm gonna say drop table if exists, that's gonna be the roles table, and then we're gonna do create table, that's gonna be roles. So this is just gonna be the table that's gonna have all of the different roles. So I don't need all of this stuff. I only need 3 attributes here. So here I'm gonna pass in the name, and I'm also gonna pass in the permissions. Okay, so that's gonna be permissions or permission. So let's see if we can format this a little. All right. So again, we're gonna have an ID, so that's gonna be a big integer, positive, not null, auto increment, and that's the primary key. We're gonna have a name for the role, so role user, role admin, role sysadmin, role finance, etc., and then the permissions associated with that role. So for the name of the role, we can keep 50, that's fine, but for the permission, we're gonna set this to 255 because the permission is gonna be a long string that is separated by comma. So it's gonna be something more like user read and then a comma, user delete, and we can do the same for customer, like customer read. Okay, so that's just a format that I've just been using that I like, but you don't have to follow this format. Sometimes you can represent these with numbers. So number 1 is user, number 2 is admin, etc. There are many different ways that you can go about this, but that's how I'm gonna go about it, by just using a simple string for the permissions, and then I can compare that strings when I need to determine if someone has a specific permission. So I'm gonna delete this comment, and the only thing we want to be unique here is the name. So I'm gonna copy the name and just paste it here. So the names of the roles have to be unique, or the name of the roles have to be unique, meaning we can't have role user twice in this table because it has to be unique. And we're just gonna change this to name and then change this to roles. Okay, so the unique role name is gonna be the name that's gonna be unique, and that's the constraint that we have on this table. So that's for the roles table. Now we need something that's gonna establish the relationship between the users table and the roles table. So I'm gonna copy this one more time and then go down, enter twice, and then paste it. So this is gonna be the user role. So we're gonna say user role table. Okay, so that's the user roles table. Paste it in there as well. For this table, we're gonna need an ID, so that's gonna stay, and I'm gonna see if I can delete most of these things because I don't need them. So for the user roles, what we want to do, we want to establish the relationship between the user and their roles. So for the user roles table, they're gonna have an ID, that's gonna be the primary key of that table, and the next thing we need is the user ID. So we're gonna say user underscore ID, and that's gonna be the same as this. I'm gonna copy all this stuff, paste it here. The only thing is it's not gonna be auto increment or primary key, okay, but it's gonna be the same type, which is what this type is in this table as the primary key, but the user ID is also the primary key in this table. So the big int undersigned not null is also valid for this user ID here. The only thing we don't need is its auto increment and primary key. And the second thing we're gonna need is the role ID. So I'm gonna copy this again and then paste it here, and then I can delete this. So the second thing is the role ID. So I'm gonna say role ID. So the role ID is gonna be the same, big integer, not null. And now we need to establish the foreign keys for these, because we're just saying, hey, this is gonna be the user ID, this is gonna be the role ID, but we're not telling MySQL in this case that these two are foreign keys from these two tables. So we have to come down here, and then we're gonna say foreign keys or foreign key, and then we're gonna specify which is the foreign key. So the user ID is a foreign key, and then we're gonna say references. So what is it references? So it's referencing the user's users table, and specifically the ID on that table. And we want to tell it what we want to happen when we delete that key or when we update that key. And to do this, we're gonna say on delete, we want to cascade. So if they delete the user, then we can delete that user role as well. And we're gonna say on update, what we want to do, we want to cascade. Okay, so if the user is updated, also update this value. So this is how you establish the foreign key relationship. So you say we're going to establish a constraint. This is also a constraint, which is the foreign key, and we're going to say the foreign key is for this column here, so the user that we have in this table, and it's referencing the users table, the column ID on the users table, and then we specify what should happen if this ID on the users table is deleted or if it's updated. We say cascade. In that case, we're going to update the value in this table as well. So also remember that a user can have only one role, right? So there is like a one-to-many relationship with this table and the users table, because we can't have a user in here twice, because a user can only have one role. That's just the design approach that I'm taking. A user can have multiple roles, but in my case, the permissions is where most of the role power is, if you want to put it that way. So if I have a role user, then I know what permissions that I have. So instead of having many different roles that I can attach to a user, I just give them one role, and then in that role we're going to have all the different permissions that's going to determine what that user can do. Okay, so that's why we have to specify that a user can have one role at a time. So they can either be a user, or they're a finance, or they're an admin, whatever the case. So to do that, we're going to add another constraint. So I'm going to use the same constraint that we already have here, and this is for the user role. So I'm going to copy this and then pass in the user role as the name of the table, and that's going to be on the user ID. So I'm just going to say user underscore ID. Okay, that's the name of the constraint, and it's going to be a unique, and that's going to be for the user ID. So copy this and paste it in here. But that means is that whenever we put a record inside of this table, the user ID has to be unique, which means there will always have one entry or one row in this table for a specific user. We can't have a user twice. So this is going to ensure that one-to-many relationship, because a user can only be in here once. And again, that is just a design approach. You can take a different approach if you want. That's just the approach that I'm taking. And I'm gonna align things a little. And now we have to do the same for the role ID, because remember that the role ID is also a foreign key. So we're gonna copy this and then paste it. We're gonna do this for the role ID. So role ID, and then we're gonna say this is gonna specify the roles, the ID on that roles table. And then on delete, we're gonna restrict. And then on update, we're going to cascade. So if the role ID, which is the primary key, that's never going to be updated. But in the case that it was ever to be updated, we're going to update it in this table as well. But if it's going to be deleted, we're going to restrict that from happening, because if the role is being used, then we can't delete it because it's being used in the user roles table, which means there's a user with that role. So we can't delete that role. And that's everything that I showed you in Workbench as well. So we're just doing it in code this time. So I think that's everything that we have to do for this, and we're gonna go ahead and continue with the user event. Remember, we just capture how we're gonna get the user role and their permission. Now we have to do the user event. Okay, so we're gonna need to have a way to link a table that's gonna have the IP address, the device, the browser, the date, and everything with that specific user, and that's what we're gonna be doing next. Let's go ahead and continue by trying to capture the activities on the account, right? So we know that we have to capture the IP address, device, browser, date, and the type. So the way that I'm going to represent this is I'm going to create a table that's going to keep information about the event. Because notice that if we don't have an actual event that occurs, then we don't have an IP address, we don't have a device, we don't have a browser, we don't have a date, we don't have a type. It has to happen before we can have all of these spaces information. Now, if you've done anything with SQL and SQL design before, you know that calls for at least 2 tables. So what I'm going to do is I'm going to go ahead and copy the roles table. I'm going to copy it, scroll down, paste it down, and this is going to be the events. Okay, so I'm going to name it, I'm going to name it events, and I'm going to copy it and paste it here. So that's the events table, and it's going to have an ID, so that's going to stay. It's going to have a type instead of a name, so we're going to have a type, and it's going to have a description. So description. All right, watch out to 55, not null. Now, we don't have any IP address. We don't have any device, browsers, or the date. We have the type, so that's the type that we're keeping here. But we don't have any of these other information. So whenever we're going to establish the relationship between the user, the event, which is going to be the user event, that's when we're going to capture all of this information, because that's when we have that information. Also, I'm going to make sure that the type is unique. So the type has to be unique. We don't want to have duplicates of the same type in this specific table. So let's go ahead and fix these as well. And it's going to be the type. So type. So that's going to be unique. That specific column name. Now we need to have the user role. So let's copy, well, not the user role, the user event, which is going to be similar to this. So copy that and come down here, paste it. That's going to be the user event. So that's the table that's going to represent the relationship. All right. So now what we need for the user event, of course, it's going to have an ID. That's the ID for that specific table. We're going to have the user ID, and then we're going to have the event ID this time. So we're going to say event ID, and let's just update these foreign key references. So this is referencing the events and the ID, same thing. So we can't delete that specific event if it's being used in this table, but we can update it, and we're going to cascade for the user ID. So that all looks good. I'm going to get rid of the unique because we can have multiple different events for the same user. So we can keep multiple records of the same user in that table. So we have to remove that unique. It doesn't have to be unique. But now we can capture this information that you see here. So whenever we're going to put an entry or a row inside of this table, we can say, okay, so what was the IP address that was used? So let's go with the device first. So we're going to say device, and that's going to be a varchar. So varchar of maybe 100. And this cannot be null, or yeah, it can be null because we're not going to have a device every single time. So default null, we're going to have the IP address. So we're going to say IP underscore address, also another varchar, and we can set this to 100 as well. And the default is null. And then the date this was created, because you see here on the right, we need to capture the date. So we can say created at, and this is going to be a date time. So we're going to say date time. The default is going to be the current date time as well. So we can just copy this and then paste it down here. Okay, so that's the default. In the user event, we have the ID. So that's the ID for that particular table. Then we have the user ID, and then we have the event ID. So that's the event here. Okay, so that's going to be the type. It's going to be like user login or something like that, login attempt, login success, or profile update or something like that. And then we're going to have the device. So whatever device they were used, like Chrome or a Linux system, and then the IP address, and then the date that the event was created. And I'm going to copy this and update the users table as well. So instead of created date, we're going to have created at, and I'm gonna need to format this, but I can do that later. So let's scroll down here. So this all looks good. Another thing I want to do is to define the different types of event that I want to do here, and I can add another constraint here. So we know that we don't want this type to be null, but we can also pass a list of all the types that we will accept. So it's not going to be null, and we can add a constraint with the check keyword. So we're going to say check, which is going to check for specific types, and then here we're going to say check to make sure that the type is in this list. So here I'm going to pass in a list. So here we can say something like login underscore attempt, and then we can pass in login underscore attempt failure, and that's supposed to be a string. And I'm just gonna go ahead and type this out and then fast forward the video so that you don't have to see me typing all of this stuff. Okay, so I just typed out all of this information, and I'm just gonna walk through what I just did here. So in the events, we're gonna create the ID, the type, and the description. For the type, we're only gonna accept specific types. Okay, so I'm adding a constraint to the type. So I'm saying, well, this type is gonna be 50 characters, and it's not gonna be null. And whenever we're trying to insert a record inside of this table, make sure that the type, so this value that they're adding here, it's one of these. Okay, so that's how you do this. That's another way that you can add a constraint with the check constraint. And then here you can say that I pass in a list of strings. So login attempt failure, login attempt success, profile update, profile picture update, role update, account settings update, password update, and MFA updates. Okay, so as long as we put one of these as the type, then it's not going to give us an error. If we put anything else other than what we have in here as the type, then that's going to give us an error. And that's just another way that you can add a constraint. Okay, so when I'm adding my events, I have to make sure that it's one of these values in this list. I'm just going to go ahead and format this again. Okay, so that looks good. Everything is aligned, and I'm gonna go ahead and do the same thing for the users table, but I'm just gonna do that off camera. So we're making good progress here. Now we have to capture the let's see here. We still have to capture the link. So here we need to send a link to the user to reset their password. We need to do something similar whenever they create an account, because we need to make them verify their account. So we're gonna be doing those next. What we have to do now is to try to capture the account verification. So you see here it says account verification. So whenever a user creates a new account, we need to save their information, make sure their account is disabled or is not active, and then we're going to send them a link. So we have to have a way to capture that. So to do this, I'm going to create another table and I'm going to store the user ID with information that I need for the account verification. So let's go ahead and copy this one more time, and then I'm going to scroll up a little, enter twice, and then paste it. So this is going to be the account verification. Account verifications. Pass that same name down below as well. And it's going to have an ID. That's going to be the primary key. And then we're going to have the user ID. So we're going to keep that. And then we're going to have the URL. So here we're going to say URL. And that's going to be a varchar. So let's just copy this and paste it here. And we're going to change this to 255. Okay, because URLs can be pretty long. Another thing we can do, we can have a date here. So if you want to have this to expire, so let's set this as a date time, and we can say something like not null. Okay, so this cannot be null, which means you want to give the URL a time to expire. Okay, so whenever you would try to access the URL, you would check that date to see if it's past like 24 hours or something like that. I don't think I'm gonna need it in this specific example because I don't have any logic for it in the application. And the reason for this is because when I was building this application, I wanted to keep track of who is creating accounts in my system. So I wanted to keep this information the way that it is. And at any given time, I can go ahead and see who created accounts and are these accounts still active. So I was just doing this in some other application and I decided not to use it in this specific application. And we don't need anything else here, so I'm gonna delete everything else, and we're gonna need to delete this as well. But we do need the user ID and the URL to be unique because we can't have a user in this table twice. Okay, so if they create an account, we create a URL for them, this data is gonna be in this table, then we can have that twice. So we have to make sure that the user ID is unique and the URL is unique because we can't have multiple URLs for the same user. So let's just go up here and see if we can copy this constraint right here and then come down here and paste it. Put a comma first and then paste. So what we want for the account verification, so I'm going to copy this name, pass that name here. We want the user ID, so I'm going to say user underscore ID, lowercase, and we pass in the user ID here. So this is us saying, hey, the user ID has to be unique, and also the URL, we want that to be unique as well. So let's copy this and then go down here and paste it, and we're gonna say this is for the URL, and then pass in the value here for that column name, so URL. So the user ID is gonna be unique, the URL is gonna be unique, and I'm just gonna go ahead and format this a little. All right, and I'm gonna go ahead and remove that date as well. Well, I'm just gonna keep it here just to remind you that you can have a date of expiration in here, and maybe you can have a trigger or some batch application that's gonna run maybe like every 24 hours. And if it checks this date and it says that this user has passed, let's say you set this to like expire after 24 hours, then you can remove that record so that you can allow that user or that email address to create an account again, which means that you would have to delete that record in the user's table. So I'm just, giving you some other scenarios that you might want to go to. But for our case, I'm not going to use this date. So if someone created an account, they haven't verified their information, so they haven't verified their user email, then we're going to keep that record in this table indefinitely. So I can use that for auditing. I can use it for reporting so that I can see, how many people create an account and they actually never use this account. And for the foreign key reference here for the user ID, if it's being deleted, then we can delete that record. If it's updated, then we can update the record in the account verifications table. So this is going to stay the way that it is. That's all we have to do for this table. Whenever a user creates an account, we're going to create a user for them. So we're going to capture that information in here, and then we're probably going to set their account to be like disabled or locked or something like that. And then we're going to put an entry inside of this table until they verify this URL. Okay, and you're going to see how this is all going to play out. This URL cannot be null, so I'm going to say not null. So the URL cannot be null. It has to have a URL. So this is how we're going to capture the account verification. The next thing we have to do is the passwords reset. Okay, so it's going to be something similar to this. Actually, it's going to be like almost a mirroring of this account verification, and that's what we're going to be doing next. So let's go ahead and copy this one more time, and I'm going to scroll down, paste it, and I'm going to name this to reset password verification. So reset password verification. Okay, so because we need to have a way to capture that as well. That's gonna have an ID, the user ID as well, because we need to know what user this is referencing. We're gonna have the URL, so the URL that they need to click on, and we need this date. So this is gonna be like the expiration date actually. So we're gonna say expiration underscore date. We need that date this time because if they don't reset their account within 24 hours, then they're gonna have to reset their account again. So this is really important in this case. And then we have the foreign key, so the foreign key for the user. Okay, all of this looks good. We also gonna have a constraint for the user ID and also another constraint for the URL because these have to be unique. And now we just have to change the name of these constraints here. So I'm gonna pass in the name of this table just like that. Okay, and I'm just gonna format this a little. You don't have to format anything. I just like to see things formatted. Like you can see here, everything is aligned. It just makes me feel good. But you don't have to do that. You can just keep things next to each other. So reset password verification, the primary key, the user ID, the URL, the expiration date, which is going to be 24 hours from the date that they request the reset password verification. And then the foreign key, we're passing it for the user ID, and then two constraints for the user ID and the URL because we want these to be unique. So this is going to allow us to capture the reset password when the user is not logged in, as you can see here in the requirements. So I think the next thing we have to do is the two-factor authentication, because when the user logs in with their correct credentials, if they have two-factor authentication set up, then we have to put another record inside of another table so that we can ask them to verify. And that's what we're going to be doing next. It's going to be very similar to this, but instead it's going to have a code instead of a URL. So let's go ahead and work on that. Now let's go ahead and work on the two-factor authentication. So let's go and copy this again and paste it down. I'm gonna scroll up a little more. So we're gonna call this two-factor verification. So let's do two-factor verification. I'm gonna copy this and change the name below as well. Okay, so we're gonna have the user ID, an ID for the table itself as the primary key for the table. The user ID, instead of a URL, we're gonna have a code. You can give this any name you want, by the way, but in my case, it's going to be a code, and let's just set this to 10. I don't think I'm going to pass more than 10 for the code. Not going to be null. User ID also not going to be null, and we're going to have an expiration date. We can keep the expiration date here and write more logic to say, hey, if the code is expired, then you have to log in again. We have the foreign key for the user ID here. That's all good. And then we have a constraint for the user ID, also all good, because we don't want to have two records for the same user. And here, instead of URL, we're going to pass on the code because we want the code to be unique. Okay, so the codes, they have to be unique. We can't have the same code for two different users, and we have to change the table name for this constraint name as well. So I'm gonna change that here, and instead of URL here, I'm going to change this to code. Okay, so that's all we need here. So I think that's everything we have to do to capture all of this information. Let's just make sure we have everything we need. Scroll up a little. So we have the user, so this is all good. Okay, that's more functionality related. So we have the reset password. So we define that down below here. User login. So this is just token. So that's stuff that we're going to send to the user when they log in. We're going to save it on the client, so we don't have to do anything here. For the brute force attack, we're going to use the account lock. So we're going to count how many times they try to log in. And if they pass the threshold, then we're going to set this maybe account lock to true. Okay. And role and permission, we're going to use these two tables, or this table and this relationship table, to establish that. And in the UI, that's why we're going to protect resources. Well, we're going to be doing that in the backend as well with the roles and permissions, but this is more going to be in the UI. And then two-factor authentication, we're using the two-factor authentication table here to capture that. That's why we're going to send them the code. Keep track of user activities. So we have the user event that's going to capture that as well. So the event and the user event will capture that. So I think we have everything we need. Now I can just use this one screen just to make sure that you can see everything. Okay, so what we're going to do is we're going to run this application because we have the this configuration. So if I scroll down a little, so this configuration here, we're going to set it to always. What Spring is going to do is it's going to run all of this schema against our database. Okay, so we'll be able to see that everything is working properly. And now that I'm thinking about it, there's another configuration that we can put here, also really important. So down below here, I'm going to pass in continue on error. Okay, so by default this is set to false. Okay, so if we have an error in our SQL query, then it's gonna, throw an exception in the application. So the whole application will not start. We're gonna be using true or false here, but I just wanted to make sure that you're aware that this configuration exists. Okay, so this says that to always run this schema file or another data SQL file if we had one. And this says if there is an error, should we stop the entire application or should we continue? Like if we have an error in the SQL query here, because sometimes you might not care like if these queries fail in the database, so you want to make sure that your application starts anyway. So that's what this configuration is for. So continue on error, true. Actually, we're gonna set it to false. Okay, so if we have an error, then don't continue. And if I hover over it, you can see whether initialization should continue when an error occurs. Okay, by default, it's false. So we're gonna keep this here. So I think this should work. We're gonna go ahead and start the application and check it out in the database. Make sure everything works. And I'll also show you how we're gonna create the design off of these queries as well. But I think we have everything we need so that we can run the application. So that's what we're gonna be doing next. So before I run the application, I want to make sure that I clear my SQL so that we don't have any of the tables that we had. Otherwise, it's going to give us a conflict. So let's open my SQL workbench here, and in the secure capita, which is our database. So I'm going to expand the tables, and then I'm going to delete these 3 tables that we created in the previous lectures. Okay, so I'm going to drop these 3 tables. Just drop them. All right, so now we don't have any tables in here anymore, and we can collapse this for now. So we can run the application, and Spring should pick up this schema file and then run all of these queries against our database. So let's go ahead and start the application. Let me double check the application properties first. Okay, so we have all of our database information in here. Okay, so let's go ahead and take that for a spin. I'm gonna click on run. Okay, it's coming up. All right, it looks like it works. So we didn't get any errors or anything. So let's go ahead and check my SQL workbench. Make sure we have our data in here. Click on this little icon here to refresh. Okay, we don't have any tables. And that's because if we go back here, we have to set this to always. Okay, so we're gonna set this to always. That's gonna initialize this schema SQL file. All right, so now it should work. So I'm gonna go ahead and rerun it. Stop and rerun. This time it should create all of our tables. So let's see. Okay, and we get an error, incorrect time zone -4. So let's see what we did here. Okay, I put -4, that should be -400, like -4 hours, I guess. Okay, so that should do it. So let's go ahead and run it one more time. Okay, let's see what happens this time. It should take a little longer. You can see it's paused because it's running all the queries, and now it's done, and then it started. Okay, so we're good. Now let's go ahead and open Workbench and see if we have our tables. So let's open up, refresh, and you can see here we have all of the tables. So everything looks good, and I'm gonna show you how we're gonna do the reverse engineering so that you can have the same physical model that we had when we did the data modeling. So you can see that there's 2 ways to do this. You can do the forward engineering or you can do the reverse engineering. With the data modeling, we did the forward engineering. This time we're gonna do the reverse engineering, and that's what I'm gonna show you how to do now. So in my SQL workbench, you just have to go to database, and then you're going to click on reverse engineering or reverse engineer. And it's going to ask you for the credentials. So whatever credentials that you put in for your connection, and that's all looks good to me. So I'm going to click on next. Okay, so it just ran everything here. I'm going to click on next again. So it's going to ask me which database that I want to do this for. So I'm going to click on the secure capita and then click next. Okay. And then click next again. So it's going to show me that there is like 8 objects, which is our tables. You can see here, that's all of our tables. So if we didn't want something, we could just remove it or add it here. But I'm going to keep everything because we want everything. I'm going to click execute. Okay, it's going to take some time. Now it's done. I'm going to click next and then finish. And you can see if I scroll over here, I can do Control A and select everything and move it around. So here is our physical model with all the relationships. And I'm going to see if I can put the user in the middle just so that you can see everything better. So password reset, and then we have the account verification. So I can put these 2 at the top here. And then we have the role, which will go with the user role. So let's move this over here like that, and the user role here. Okay. And then we have the user event with the event. And then we have the 2-factor authentication, which is right here. Can move this up a little, just like that. Make sure this is aligned. Okay, so you can see at the end, we end up with the same design, or just the design stemming from the SQL queries that we just wrote. And this is the reverse engineering. And I'm gonna go ahead and save this diagram and give it to you guys in the file and the resource, just so that you can have it and play with it. But we did the forward engineering, now we did the reverse engineering. And in the end, you end up with the same thing. So whichever one you want to do first. Now, in a lot of cases, what I've seen is there's usually a design, like the data modeling design, and they go through the process. Once they get to the logical model, they have a pretty good understanding of what they're trying to do, then they write all of the queries. But it's really up to you. You can do the forward engineering with the data modeling, or you can do the reverse engineering. You write all of the queries first, and then you produce the design. It's really up to you. But at least now you know how to do both, at least using MySQL. Now, like I said, there's going to be a tool, or hopefully there's a tool for all of the different database management system. For MySQL, it's MySQL Workbench, and you can see how powerful MySQL Workbench actually is. But there's similar tools in all of the major database management system, and you should be able to do the same thing, either forward engineering or reverse engineering. So this is all good, but now we don't have any logic for anything that we're actually doing in the application with these users. So we're going to be getting into the Java part of the application, where we're actually going to be writing, the services and the implementations, and fetching all of this data, and write all of the different logic to make the application work the way that we want it to work. So we still have a long way to go, but we'll get there eventually. So I hope this was useful to you. Again, if you have any questions, just reach out to me and let me know. If you have any ideas about the design as well, just feel free to let me know. We can discuss it. That's no problem. Like I said, this is just one approach, but there can be many different approaches to everything, really. So if you have any different ideas, you can just reach out to me. If you have any questions, also reach out to me as well, and we can have a little chat. But just make sure that you understand every single line of code that we've written so far. Again, reach out to me and ask me a question. You can do that by sending me an email, or just reach out to me on Discord, and I should be able to help you. So in the next section, we're going to be writing some more Java code. So we're going to be doing more Java instead of SQL, and designing stuff like that. So we're actually going to start getting our hands dirty with Java code. But make sure you really understand everything that we've done at this point, because this is also really important in application design and development. We've made a lot of progress so far, and hopefully you are able to take a quick break before you start this new section. What we're going to be trying to do now is to create the functionality to create a new user. And I'm looking at this here on line 12. I see this says camel case, but this is actually Pascal case because we're starting with a capital letter. So I'm going to put a lowercase here. So this is the actual camel case. Okay, so you start with a lower letter first, and then every word is going to be, the first letter is going to be capitalized. But if you start with a capital letter, then that's Pascal case, and that's not what we want. So use underscore instead of camel case. But anyways, back to what I was saying. So yeah, we're going to be starting by creating the functionality to create a new user in the application. So we're going to be writing some Java code and defining the different folders that we're going to have in the application right now. So you can see we only have one file, which is the main file for the application. So we're going to be starting by adding in some of the structure that we know that we're going to need. So repository implementation, service, resources, etc. And I'm going to come back and show you how we can put some data in there. So you see we have all of these tables in our database, but we haven't added any data in there in any other tables yet. So we're going to be doing that a little bit later. But for now, I want to add the functionality to add a new user. So we're going to be working on that going forward. So without any further ado, let's go ahead and jump right into it. I'm gonna go ahead and start by creating a package. So we're gonna go here, and then we're gonna say package, and this is gonna represent our domain. So here I'm gonna say just domain or model, either one. And I'm gonna create another one for the repositories. So I'm gonna say repository and press enter. And in domain, we're gonna create a user. So I'm gonna do new Java class. So that's gonna represent the user that we've been working with. So we're gonna say user. And in the repository, I need to create the interface to represent the user interface. So Java class again, and I'm gonna say user repository. So repository, and that's gonna be an interface. So I'm gonna select the interface and then press enter. I want to make this a little bit flexible. So here I'm gonna say whatever extends our class is what we can use here. So we're gonna choose the user that we just created in our domain. Whatever extends this is what we can be working with in here. And then we're gonna put the basic CRUD operation. So let me put a comment first, and then I'm gonna say basic CRUD operation. So it's gonna be just the basic CRUD operation. So like, create, update, read, and delete. And I'm gonna collapse this for more room. So what I wanna do here is to define the create. So we're gonna say create, and that's gonna take the data. So we're gonna say T is gonna be the data. So this is for create. Okay, so that's the first of the CRUD operation. So that's the create.
And then we need to do the read. So let's do a collection of whatever the class is. So T, and I'm gonna call the read list. And we also wanna take the page. So we're gonna say page, and also gonna take the page size. So we're gonna say page size. So, every time we're going to be looping and grabbing data from the database, we don't want to grab everything all at once. We want to be able to page the data. So that's why I'm passing in the page and the size of the page. And then we need the get. So the get is going to take the identifier. So here we can say it's going to be a long, which is going to be the ID. And then we can do the update. So T again for update. And for the update, we need to get the data as well. So we're going to say T, that's going to be the data. And the last one we need for the CRUD operation is to delete. So I can do void and delete. Again, pass in the ID. So we're going to say long ID. So for the CRUD operations, we have, create, read for the list. And then, well, this is also a read, but just one. So create, read, update, and delete. And instead of making the delete return void, I'm gonna make it return a Boolean because that way I know that if it was successful, then return true to the user. If it's not successful, then we can throw an error or return false. So that way I can use the return value here to determine if the operation was successful or not. So this is the basic CRUD operations, and I'm just gonna add another comment here, and I'm gonna say more complex operations. Okay, because we're gonna be putting those in a little bit later, but for now we're gonna begin with the create, read, these two, and then update and then delete. So that's good. So the next thing I want to do is to fill in the fields for the user. So let's go inside of the user class, and I'm gonna pass in some annotations here. So the first one is gonna be add data, because we need getters and setters. So data from Lombok, and then we need the super builder because we're gonna use the super builder pattern. Oh, not super builder. And we also need the no args constructor. So I'm gonna do no args constructor in the all args constructors. All args constructor. And lastly, I want to add the JSON include. So I'm going to say JSON include, and then in here I'm going to pass in let's say non-null. Let's do non-default. That's better. And I'm gonna click on this and then go over here. It's gonna give me this little light ball, and I'm gonna do a static import, and then I'm gonna clean this because we don't need these imports. All right, so for the user, we need to add a few things here, right? Because we need to be able to map whatever we have in the database to this user in the Java code. So to do this, we're gonna define a private, which is gonna be a long, that's gonna be the ID. We're gonna define the string for the first name, so first name, and then we're gonna have another private for the string for, Control Z, string last name. So pretty much everything that we had in the SQL queries. So we also had the email. We had the password, so another private field. Password, and we had the, let's do private, I think we had the address. We represented that as a string. And see if I can scroll up. I'm just gonna put some more space here and scroll up a little just so you guys can see this at the top, and then I can remove this space. So after the address, we had the phone, so we're gonna do private string phone, and I had the title, so another private string title, like the title of the user, whatever they do in our company. And we had the little bio for them, and also the image URL. So private, that's another string, image URL. And we had the private, that's going to be a Boolean, that's going to be the enabled. So if the account is active or inactive. We had another private Boolean that was going to be the is not locked. Okay, and I'm going to show you why I named this is not locked. Like, why am I using the negative form of this? Why not is locked? Okay, because that's the way that Spring has it. So I'm just trying to be consistent with it. So we're going to have another private, and that's going to be the Boolean for is using MFA. Is using MFA. So if the user is using multi-factor authentication or not. And then lastly, we're gonna have a local date time, and that's gonna be created at. So whenever the account was created.
And I'm gonna go ahead and clear all the space. So really everything that we had in the schema. So if we go inside of the schema, all of these fields is what we're defining. And let me make sure that I'm not missing any one of them. Yeah, so we have everything. So you can see here in the user, we're just gonna have the same fields. And then we're gonna be able to mirror everything from the SQL to this object whenever we're working in the Java code. And I'm gonna add some annotation here for validation. We wanna have the not empty. And we can pass in a message. So I'm gonna say here, let's just say first name cannot be empty. Okay, just a simple message. And you're gonna see how I'm gonna use this a little bit later. We're gonna do the same for the last name. We're gonna do the same for the email and the same for the password. And I'm gonna show you how we're gonna use the password. So we can say password cannot be empty. We're gonna say last name, well, email cannot be empty, and this is gonna be the last name, so we're gonna say last name cannot be empty. And there's also an email one, so we can use that as well. So I'm gonna say email. You can see it's coming from the validation. So here we're gonna pass in a message as well. I'm gonna say message invalid email, please enter a valid email address. So just some validations that we're going to be using in the resource when we're going to build the controller, so that we can make sure that all the data we're receiving is the way that we're expecting it to be, because we don't want users to be, you know, sending requests without having a first name or a last name or something like that, or an email, because those are really crucial. So we have the user, we have the repository. So at this point, what we're going to be doing is to create an implementation of this interface. And that's when we're going to actually start writing all of the different logic that we need to write to be able to create that user in the database. And that's what we're going to be doing next. Let's go ahead and create the implementation for this repository or this interface. If you guys are using IntelliJ, you can use the keyboard shortcut if you want. I think if you put your cursor on the interface and you press Alt Enter, then it will give you the option to create the interface. But I'm not going to be using these fancy key bindings because I want you to follow everything that I'm doing, but feel free to use those. I know some of them, I don't know all of them, but I'm not going to be using any key bindings or anything like that. So I'm going to open the folder again inside of the repository. I'm going to create another package here, and that's going to be the implementation. So I'm going to name it implementation, and inside of there is where I'm going to create the repository implementation. So in here I'm going to create a new Java class, and then I'm going to call it user repository implementation, or just IMPL, and then press enter. And in here we're going to say implement the user repository. Okay, again, it's the same of type user, which is the user coming from our domain. Okay, now we have to define all these methods. So implement all of them, collapse this. This is where we're going to be doing all of the dirty work. So all of the different logic that we're going to be putting in, all of the statements, all of the database queries, they're all going to go inside of this file. Okay, so, and I'm going to show you what that structure look like. So for now, you see that we have the implementation inside of the repository, but we're going to step back a little just so we can look at the structure of the folders that we have here, but we'll do that in a second. So here, the first thing I need to do is to bring in the JDBC template, and we need the JDBC template because we need to execute queries on a database. So to do this, I'm gonna do public. That's gonna be final, and I can use the JDBC template, so I can do JDBC template, but I'm not gonna use the JDBC template. I'm gonna use the named parameter JDBC template. So named parameter JDBC template. Okay, so that one. So this JDBC template is technically the same one. The only difference is it's named instead of question mark. So if we go in there, for example, and I download the sources so that we can have the actual documentation here. So you can see it says template class with a basic set of JDBC operations, allowing the use of name parameters rather than the traditional question mark you can see here. So instead of passing in question mark in my queries to denote where I'm going to pass some variable, I'm just going to put a name with a colon. So we're going to put colon and then the name, and you're gonna see that in a second, but it's pretty much the same thing. It's just doing the same thing. And at the top here, I'm gonna add some annotation. So the first one is the repository, so we're gonna say repository, and I need the constructor, so I'm gonna do required args constructor, and then we need some log in here, so I'm gonna bring in the slf4j, and that's coming from Lombard. So now I'm gonna put a space here.
So we have this database C, so we can make requests to the database and then query the database. So that's what this is going to be doing. So now we can start working on these methods that we have to implement here. One thing I like to do is to define what I'm trying to do in this method right here. So this create method, we know that we have to do a few things. So before I start doing anything, I just put some comments and list out everything that I know that I need to do for this specific method. So for example, I know when I'm going to create a user, right? We need to check to make sure that email is unique. Okay, so check the email is unique. Okay, because we can't insert a new user with an existing email because the database is going to throw an error and the whole process will just fail. So we got to make sure that before we try to save someone, they're giving us a unique email or an email that we don't already have in our database. If that's the case, then what we're going to do is we're going to save new user. Okay, so we're going to save the new user if they come with a unique email, and then after that we need to add role to the user. Okay, because after we save them, we have to give them a role, and then after that we need to send them a verification. So we're gonna say send verification URL, and then after that we're gonna say save URL and verification table. Okay, so verification table, and then after that we need to send email to user with verification URL. Okay, so we have a lot of things to do here, and lastly we can return the user. So we're gonna say return the newly created user. Okay, so you see that we have a list of things that we have to accomplish in this one method, and we're gonna be tackling them one by one. And also one last thing is if any errors. Okay, so if we check, we see that we don't have a unique email. If there's an error while we save the user or add the role, if we have an error in any of these cases, we're gonna say throw exception, because we need to throw an exception with a message. So with message, with proper message. Okay, proper message. So if there's an exception of any kind, then we need to send a message to the user to let them know what happened, right? If the email was not unique, or if we couldn't, save the user for some other reason, or if we couldn't create the URL, whatever the reason, we have to send a message with an exception or with an error to the user so that they know what happens, then they can correct it and then send the request again. All right, so let's go one by one, and then we're gonna complete this method. So the first thing is to check to see if the email is unique. So we're gonna have if. I'm gonna create another method. Now I gotta say, as we work our way through this repository implementation, it's gonna force us to define other things, right? So as we go along, as we work on these methods, then we're gonna create everything that we need to create. For example, exceptions and other services and things like that. So as we go through it, we'll create everything. So here I'm gonna say get email count. Okay, because I want to make sure that when I check the database, I can't find a user by that email that I'm getting from the new user. So when I'm trying to create a new account, I don't want that email to exist already in the database, because if it does, then that means there's already a user using that email. So here I'm going to say user that get email. Well, I'm going to name this as user because this is data. So here we're gonna say user that get email, that we can trim it and then set it to lowercase. Okay, and then we're gonna check to see if it's greater than 0, because we're getting the count. So we're gonna say greater than 0. So if that's the case, then we know that the email already exists. So in that case, then we're gonna throw an exception. So we're gonna say throw new, and I'm gonna call this API exception. So API exception. This doesn't exist yet, and I'm gonna pass in a message. I'm gonna say email already in use, please use a different email and try again. So now we're forced to define this API exception. So I'm going to copy this name, go over here inside of the main package. I'm going to create another package. So here I'm going to call it exception. Okay, and then I'm going to create this new class. So we're going to say new Java class, paste it in here, press enter, and we want to extend the runtime exception. So we're gonna say runtime exception, and we're gonna create a constructor. So we're gonna say public API exception, and here we just want to take a message. So the message, it's a string, okay, And then all we have to do is to pass to the constructor of the parent class. So we're gonna say super and then pass in the message. Okay. And we're gonna come back here and add more constructor if we need to, but for now this should do. And I'm gonna collapse this back and go back to the repository, and here we're gonna see if we can import this. Okay, so everything is resolved. Now we can create this method here. So create method, and I'm gonna put everything private at the bottom. So I'm gonna cut this and move to the bottom and paste it. We're gonna work on this in a minute, and this is supposed to be the email. All right, so we're gonna say, hey, if the email count is greater than 0, then we know that the email already exists. So we're gonna throw this exception, and none of these other things will execute because we throw an exception, as you can see here. So let's scroll down, and to get rid of this error, I'm just gonna implement this method here. So it's gonna return an integer. So we're gonna say integer. We're just gonna do a simple query here. So we're gonna say this is gonna return the JDBC, and we want to do query for object. So query for object, and then I'm gonna pass count user email underscore query. Okay, so that's going to be the query that I'm going to use, and here I'm going to pass in the map that of, and then I'm going to pass in the parameter. So we want the email, so we're going to say email, and then pass in the email that we got, and then we want to tell it what class we want this to resolve to, and that's the integer class. So we're going to say integer.class. Okay, so that's gonna look inside of the database, and then it's gonna count to see how many emails that we have by that email. So technically speaking, this is supposed to be 0. It cannot be greater than 0. If it's greater than 0, then we have to throw an exception. So let's see if we can define this query. So define constant, and we're gonna work on this in a second, but for now I'm just gonna put empty string. Okay, so now we get rid of all the errors, and then we can continue. So again, one last time, we're gonna get the email count, and we're gonna talk about this query in a second. But what we're trying to do is we're trying to see the count by that email in the database or in the users table, which means we're gonna get a count of everything that we have by that email. So if it's not 0, that means there is an existing user with that email. Then we throw this exception. Now we're gonna try to save the user. So here I'm gonna say try, and then have a catch. So we're gonna say catch, and the first thing I want to catch is the empty result set. So we're gonna say empty result data access exception. And then here we're gonna do something when we catch this exception, and I also want to catch the overall exception. So that's gonna be exception, again exception, and then here we're gonna throw that exception again. Okay, so let's go ahead and work on the try block. What I want to do is to be able to get the ID of the user whenever they create a new account. So after we save them in the database, I need their ID so that I can use that ID to give them a role. And to do this, we're going to do key holder, and that's going to be the holder. And we're going to set this equal to a new generated key holder, and this is going to give us the ID of the user that just got saved in a database, because we need that. And then we're going to set all the parameters that we need to set with the request. So the query that we're going to send to the backend database, we need to get all of the different fields that we want to update and everything, and we know that these are coming from the user, so the first name, last name, email, etc. So to do this in a quicker way, I'm going to do SQL parameter source, and I'm going to call it parameter or parameters, and then I'm gonna say get SQL parameter source, and then give it the user. Okay, so we're gonna work on this method, but for now, just to not get an error, I'm just gonna go ahead and define it. So it's down there. Again, I'm gonna cut it out and then move it at the bottom here. We're gonna work on it in a minute. Now, once I get the parameters, I'm gonna update the database, which means I'm gonna save the user in the database. So I'm gonna call JDBC, and then I'm gonna do an update. And then in here, we're gonna pass in the insert underscore user query. Okay, so that's another query that we're gonna define. And then I'm gonna give it the parameters. So parameters, and then I wanna give it the holder. It needs that so that it can return us the ID of the user. And then I'm gonna end this statement. Now let's go ahead and create this query here. So create constant. Okay, and for now, again, I'm just gonna go ahead and set it to an empty string. We're gonna be working on these queries, and they're not even gonna be in this class. We're gonna define them somewhere else. So now, just wanna make sure you see what's going on here. I'm gonna put these on a new line. Okay, so it's clear. And I'll also tell you why I'm catching this exception in particular and then all other exceptions, because I need to know when I didn't find anything so that I can send a specific message. And then if I get any other exception, then I'm going to send another generic message. So after we save the user inside of the users table, so the user is created, we need to give them a role. So to do this, let's set the ID on the user, because we know that when we get this user coming from the request, so whoever is trying to create the account, they don't have an ID yet. So we don't have 0 IDs on this user. So let's see if we can set that ID using the holder. So we're going to say user that set ID, which is a long value. And then we're going to say holder that get key. And this key is going to be like the newly created ID for that user. And we want to get the long value because we know that this ID here on the user is of type long. Okay, you can see it here. The ID is of type long. And this is giving us a warning because it can be null. So we can just use the required non-null. And then I'm going to click on this and then go here and do a static import for it. And I'm going to do Control-Alt-O. It's going to remove any unused import. As you can see here, it says remove one import. So here you can see that we're saving the user inside of the database. If this is successful, then we set the ID on the user. Okay. And then now we're going to set a role to the user, because after we create a user, we need to give them a role. And that's really essential. So here I'm going to say role repository. Okay. Because we're going to have a role repository as well. And then I'm going to do dot add role to user. Okay, because that's what we're trying to do. So here we're gonna say user that get ID, and then we're gonna give them a role. So we're gonna say role underscore user, and we can get the name of that because I'm gonna create an enum. So we're gonna say name. So you can see how we're being forced to define all these things that we're going to be needing because we're creating this one function. And as we do this, we're also creating the structure that we need. And then you'll see how it's all going to come together. So let's go ahead and define some of these things so that we can get rid of these errors. So the first one I want to do is to move all of these queries in a specific file. So I'm going to go over here and then I'm going to go in the main package again, new, and in package, I'm going to call it query. So all of our queries are going to go inside of this package. And inside of the query, I'm going to right click again, create a new Java class, and I'm going to call it user query. Okay, so all of the user queries are going to go inside of this class. And then now I can move. I'm going to close some of these things just to make sure this is clean. So we don't need any of these other tabs. So I'm going to cut them out. And here, I'm going to cut all of these and put them in the user query. So in here. And we're going to change the access modifier to public because we need them to be accessible outside of this class. Okay, so now we can try to import these statically. So here, if I do more action, import static constant coming from our query. Okay, we're going to do the same down here. Actually, I'm going to scroll up and just put a star because I know I'm going to use all the queries. Okay, just import everything here. So now all of these errors in the queries should go away. Okay. And the cool thing about this is if I just hover over it, I can see what the query is. For now, it's an empty string. But if you wanted to see what the query is, then you can just hover over it and then you can take a look at the query. So that's the first thing we have to do. We have to make sure that all of our queries are defined, even though we haven't written the queries out yet, but we will do that in a second. But our names are very descriptive, so we know what this query is doing. So we're inserting the user inside of the users table. So the next thing we have to do now is to define this role repository and this enum here, and that's what we're going to be doing. So let's go ahead and create the role repository. So I'm going to go back again in the folders, and we already have the repository folder here. I'm going to right click it, do new and Java class, and then I'm going to say role repository and then choose interface and then press enter. The role repository is going to be very similar to the user repository. So I'm going to see if I can copy a lot of this stuff here and go over to the role repository and paste everything here. Everything is copied and pasted. I'm gonna collapse this. What I want to do is to change this to role. Okay, we don't have that role yet. We're gonna create it in a second, and all of these are gonna be the same. Okay, so we need to be able to create, update, delete, etc., and then we're gonna add more complex operations a little bit later, but we have the basic CRUDs that we need to have here. And for the most complex one, which is the one that we're gonna be using, I'm gonna create this void add role to user, and that's the one that takes the user ID. So it's gonna be ID, and string is gonna be the role name. So we're gonna say role name. Okay, this should really be the user ID, just to make sure that this is really clear. So the user ID. Now we're gonna define the role that we have here because we're getting an error. So I'm gonna copy that name, and the role is gonna be a domain class. So go back here inside of the domain, right click, new Java class, paste that role, press enter. So let me copy from the user. So I'm gonna copy all of this stuff, go over to the role, and then paste. Okay, we're gonna clean this up in a second. I need to just copy the annotations. So copy all of these annotations, go back here, go down a little, and then paste them. Okay, make sure everything is imported. Now the role is only gonna have 3 properties or 3 fields. It's gonna have an ID, that's the primary key, and it's gonna have a name, and then it's gonna have the permissions. So we can get rid of all this other stuff and collapse this a little. So an ID, we don't need any validation on that. So remove these and then do Control-Alt-O to clean all the imports. And we need the name of the role. So we're gonna say name, and then we need the permissions. So here we're gonna change this to permission. So the role is only gonna have the name, the permissions, and the ID. Okay, so that's all we need to have for the role. We can close that role out. Now we can import it here. Import class, and it's coming from our domain here. And I have a typo here. This is supposed to be lowercase, so user ID and then role name. So let's go back to the implementation. So we have the role repository. We can inject it inside of this class now. So let's scroll up here. We're gonna do something similar. So we're gonna say, well, this is supposed to be private. I don't know why I made this public. Private. So yeah, we're gonna say private final, and that's gonna be the role repository of type role, and then we're gonna give it the role repository. Okay, so that's what we need, and then we need to import that role. So import class from our domain. All right, so now we have the role repository. We're gonna add role to user, pass in the user ID and the role name. So the next thing we have to do is to define this enum, where we're going to specify the different roles that we're going to have in the application. And remember, these roles, they have to match the roles that were defined here. So if we go inside of the resource in the schema, if we scroll down here, so it's going to be these roles here. Okay, so whatever name that we set, that's the name that we're going to be using in the repository as well, because they have to match. So let's close this out, and let's go open this project and go to so we're going to go to the main package, and we're going to create a new package, and we're gonna call it enumeration. So enumeration. So that's where we're gonna keep our enum. And then I'm gonna create a new enum, so new Java class, and we can call this something like role type or something, like the different types of role that we have. And then that's gonna be an enum. So I'm gonna select enum and then press enter. And here we're gonna define some quick roles, and that's gonna depend on your application. Okay, so I'm gonna do the basic stuff like role user, role admin, etc. But it's gonna come down to your application. Okay, so role underscore user, and then we have role underscore let's do manager, for example, and then we're gonna have role underscore admin, and then lastly I'm gonna do role underscore sysadmin. Okay, so these are the roles that we're gonna have in the application, but that's gonna be up to you. Whatever roles you want to put in your app, you can just go ahead and put it here. So close that, and here we can import this role. So click on here and then go to more action and then import static, and that should resolve the issue. I'm also gonna move the comments. You see that the comments are down there, so they're not in the right place. So add role to user, we're gonna cut that out and then paste it here. Send verification email, so I'm gonna move everything else down there, just so that we know what we're doing. So first we check to see if the email is unique. If that's not the case, then we don't proceed. We're gonna just throw an exception, and then we're gonna save the user. So we get a hold of the key holder, we create all the different parameters, all of the different fields that we have to send with the query, and we're gonna work on this in a second. But this is just creating all of the different parameters that we have to send with the request, and that's just a way that you can do this by using the SQL parameter source. And I'm gonna show you how this is gonna work in a second. We haven't defined this method yet. And then we update the users table by inserting a new user inside of the database. We get a hold of the user ID. We didn't really need to do this. We could just get the ID from the holder and then just pass it here. But in case that we want to return the user, we want to return the user with a new ID. So that way that whoever created the new account, then they know that the information was saved in the database because they have the primary key. But again, when someone creates a new account, we're not going to send them the primary key or anything like that. We're just going to give them a message so that they can check their email. So this is really just for us when we're developing and testing. And then we add the role user to the user. It's gonna be up to you if you want to accept the role in here, and then whatever role that they want, they can pass it. But typically you wouldn't see that unless you're using like the admin part of the application. So typically when someone create an account, like anyone can come and create an account, then you want to give them the basic role user. So now what we have to do is to send the verification URL, save that URL in the table, and then send the email, and then return the user, and then handle all of these exceptions. functions as well. So in just that one method, we have a lot to do. The next thing I want to work on is the get SQL parameter source. So I'm going to press Control and then click on that so that it can take me down there. And this is going to be pretty simple. All we have to do is to set the different things that we want to save. And I'm going to show you how we're going to do this. So we're going to say return. And we want to return a new map SQL parameter source, and we're just going to add everything that we need. So here we're going to say that add value, and we need the first name. So we're going to say first name, and that's going to come from the user. So we're going to say user that get first name, and then we're going to keep doing this for the last name, the email, and the password. So I'm going to copy this, and let me see if I can put some more space down there so I can scroll up a little. So yeah, we're gonna go here and then put a comma, paste it again, and then put another comma, paste it again for the email, put another comma, and then paste it again for the password. And then we're gonna change all of these values. So here we're gonna get the first name, then we get the last name. So we're gonna change this to last name, get last name. This is gonna be the email, so email, get email, and then this is gonna be the password. So we're gonna say password. We need to encode the password. I'm gonna say get password, and I need a closing parenthesis here. So here and here, and I don't need the comma because I have a dot. Oops. So we can remove these, and then we can close it with a semicolon. So because we have the dot here, we're chaining all of these add values methods. So we need to encode the password here. Also notice that we're only getting the first name, the last name, the email, and the password, because we're not getting everything from the user. That's the only information that we need to serve a new user in the database. So that's why we're getting only these 4 values. So we need to encode the password here. So let's scroll up and see if we can bring in the encoder. So we're gonna go up here, and then we're gonna do another private final, and we want the bcrypt encoder. So we're gonna say bcrypt encoder. I'm gonna call it encoder. Okay, we're gonna have to define the bean for this though a little bit later, but we can use that encoder to encode the password because we can't store the raw password inside of the database. So here we're gonna say encoder.encode, and then we're gonna pass in the user password. Let me paste that here. Okay, so that's all we have to do for this get SQL parameter source. We're just saying, hey, for the first name, that's what the value is going to be. For the last name, that's what the value is going to be, etc., etc. And for the password, we encode it and then get the password from the user. And that's all the information they're going to give us when they're signing up. And then up here, we're going to pass this to the update. So the update here that we're using, you can see it takes the string, which is the SQL, and then it takes the parameter source, and then it takes the key holder, as you can see here. And that's what we're giving it here. We give the query, the parameter source, and the key holder. That's it. Now, the next thing we have to do is to send the verification URL. So let's see if we can define a string. That's going to be the verification URL. And we're going to set this equal to get verification URL. That's going to be a method. And what we can do here is to just give it some random ID. So we're going to say UUID, that random UUID. Okay, so let's select the second one, and we want to just make this a string. So we're going to say toString, and then we're going to give it the type, because we're going to use that same get verification URL method to generate the password verification email, the password verification URL, and also the new account verification URL. So here we're going to create an enum that's going to allow us to determine the type. So we're going to say account that get type. Okay, we're going to create that. We don't have it yet. Okay, so that's going to be some kind of an enum, and then we can say, hey, this is going to be the account, and then this is going to be the password. So now we're going to pass in the account, okay, because they're creating a new account. And we're only doing this because we want to be able to leverage this method so that we don't have to create another one to create a verification URL for the password reset. So we want to make sure that this is reusable. So let's go ahead and create this method down there. So we're going to say more action. Okay, so it's not giving me the option to create it, so I'm just gonna go ahead and copy it and then go and create it myself. So here we know that this is gonna return a string. You can see I'm assigning a string to the return type for this method. So let's go down there, and then down here again, we're gonna say private string, and then pass in the signature, and then open and close. And we're gonna change this to be a string, so the type and that's going to be the key. So the unique key that we're going to need as the key for the specific URL, because every URL needs to have a key so that we can look in the database by that key. So that's what we're defining here. Okay, so that's going to be the key and the URL. Once I put this all together, then this is going to make sense, because you can see up here we're giving it a key, okay, a random UUID. So that's just the key. So let's just create this account so that we can get rid of these errors. So I'm gonna go inside of the enum again and right click, new Java class, and we can call this one verification type. Okay, so the different types of verification, and then we're gonna select enum and then press enter, collapse this. And what I want to do is to just define the two that I'm gonna need. So it's gonna be the account, and we're gonna define the type in here. So we're gonna say account as a string. Okay, and we're gonna define the other one, which is the password. So we're gonna say, well, we need a comma first and then password. Okay, so we're gonna have two different types of URL, either a new account or a password, and then we're gonna say password. Okay, and we need to define a few methods here. So let's define a method to get this string. So the string inside of these enums, we're gonna say private, and that's gonna be final string. That's gonna be the type. Okay, because we need to have a way to get this type somehow. And then we're gonna create a constructor that's gonna take the type. So we're gonna say type, and then just assign this type to it. So we're gonna say this dot type equal the type that we get in the constructor. That's it. And then we can create one last method just to get this type, as you see that we're doing in the implementation. So this one is going to be public, and it's going to return the string, which is the type. And we're going to say get type, and it's not going to take any parameters, and it's just going to return the type. So we're going to say return this dot type. Okay, so whatever the type, it just return it to us, and we can just turn this to lowercase as well. So we're going to say to lower case, okay, because we want it to be lowercase. So that's going to return us this string here, the string inside of the enum. So that's why we had to define all these, because we need to be able to get this enum. So hopefully you guys are familiar with enums. And I have the typo here, so I gotta fix that. Okay, so now everything should look good. So now if we come back here, we can import this, static import, and this should be of type verification type. And now we have to change the actual type. So this type is going to be a string, so that's going to be the type, okay, because that's what we're passing in here by calling the get type. Okay, remember get type, it returns a string. You can see it here, a string. So this method takes two string, the unique ID of the key, which is a UUID in this case, and then the type, which is also another string, because we're getting the actual type. And the reason we're doing this is because I can just look at this line right here, and I can tell that this is for the account. So instead of passing in a hard-coded string here, we're just passing in this enum so that we can clearly see that this is the account. And we might need to use this in some other places as well. So that's why we're doing this. And now we're gonna have to work on this method around here so that we can return a URL that's gonna contain the type and the key. Let's go ahead and complete this method. So I'm going to scroll up so you guys can see better. And here for now, we're going to return a backend URL. Okay, so remember that this application is an API. So whatever URL we return to the user, it has to be the front end URL. And I'm going to show you how we're going to do this later. But since we're going to be building this API and then test it with Passively Postman, then we need a backend URL, like a URL of the server instead of the client application. So for now, we're going to just return a URL of the server. So to do this, we're going to say return, and I do servlet URI. Okay, that's the one that I'm looking for. So the component builder from context path, and we're gonna pass in the path, and that's gonna be the we can do something like /user/verify. Okay, so for now we're gonna keep it like that, and then another /, and then we need to pass in the key or the type. So +, type, and then plus, and then we need to pass another /, and then we can pass in the key. So we're gonna say plus, and then pass in the key, and then we're gonna turn this to a string, so to URI string. Okay, so this is the backend URL. So that's gonna be whatever URL this server is running on, /user/verify /account or password, and then / the UUID. In this case, that's the key. We can probably name this UUID or something, but key sounds cooler. But in the future, it's going to be the URL of the front end. So all of this part will be removed, and we will add the URL of the front end, /user/verify /account or password / whatever the key is. Okay, so that's good. So now if we scroll up here, this error should be gone. Okay, so now we have the verification URL. Now with that verification URL, we not only have to save that URL inside of the verification table, we also have to send an email to the user with that URL. So we still have a few things to do. So let's go ahead and save the verification URL. So here we're going to say JDBC, and we want to update this table again. And here we're going to say insert underscore verification query. We can change that name later if we want. And then here we're going to say, I'm going to pass in the map. So we're going to say so the util map from Java. And then there, we're going to pass in the different keys that we want. So we want to save the user ID. So we're going to say user ID, and we're going to give it the value. So that's going to be the user.get ID. And then we need to pass in the URL. So the second key is going to be the URL. And then we're going to pass in the verification URL. So this is going to save the verification URL inside of the account verification table. I should probably name this account as well. So account underscore, so insert account verification query. Let's put URL just to make it clear what this is doing. So insert account verification URL query, and that query is going to need a user ID, and it's also going to need the URL. And those are the two values that we're passing in here as a map to this update. And I'm going to statically import this. So I'll click here, static import, Control-Alt-O, and then it removes to import. So that's what we need here. Now let's go ahead and define this query. So I'm going to hover over it and then create constant, and just going to cut it out from here and go inside of our queries. So we can go inside of this guy right here, and then we're going to paste it down here. And for now, we're going to set it equal to an empty string. We're going to come back to this, like I said, but I don't want to focus on the queries yet. I just want to make sure that we understand the logic that we need to build in the user repository, and of course, make this public. So that should resolve everything here. And I think I'm just gonna remove all this. I think when I do Control-O, it does that. So I'm just gonna put a star again, because I know everything that I'm gonna have inside of the user query, I'm gonna use in here. So just put a star to import everything. And that didn't work. I did the wrong thing. So I need to remove this one, and then put a star here. Okay, that should work. Okay, all right, that looks good. Now the second thing is we have to send the email with that URL to the user. So I'm gonna do email service, which I don't have yet, and we're gonna say send verification URL, and then we're gonna pass in the user that get first name, because we need to address the user like hello so and so, user that get email, because we need the email to send the URL to, and then we need the verification URL. So we're gonna say verification URL, and because I'm gonna use this same send verification URL, so I'm gonna pass in true here to denote that this is for an account, and then false if this is for a password. Or we can just use this account here. So here you can see that we're passing in the type, so we can say copy this and then pass in the account type. Okay, and we don't have this email service, we don't have this send verification URL. We're gonna be creating that a little later. And then I'm gonna say user that set enable, because we don't want the user to be enabled, so we're gonna set this to false. This is gonna be the default in the database, but in case that we want to send the user back to the request as the response, then they will see that the enable is false. Then we're gonna set the user that set non-locked or not locked, and then we're gonna set this to true. Okay, so they know that their account is not locked. And then finally, we're gonna return that user. So we're gonna go down here, we're gonna say return user. Okay, so now the only thing we have to do beside handling all of these exceptions, of course, is to create this email service and then send that URL to the user. So we're gonna do this a little bit later. So I'm gonna come here and comment this out for now, because this is gonna be like an entire section in the course. So we're gonna handle this a little bit later. And when we're testing, we're just gonna go inside of the database and take a look, so we don't have to wait for an entire email to come through. And that's just temporary. Okay, so once we get to the email module in the course, then we're gonna create the service and also the method. But I'm gonna comment it out because I don't want to have an error here. Also, another thing, I can just pass in the type here. So instead of get type, which is gonna give us the string, I can pass in the actual enum, and I can use that to do my check. Now it's gonna look more like this. Okay, so we're gonna say that's for the account. And then if it was for a password reset, then we're gonna say password here. So comment this out again. And this, I'm not passing in just the account here because I want the actual string to lowercase, because I'm going to need this as a URL, which is why I'm passing in get type here. But in this case here, we don't need to do that because I'm going to use an if statement to determine if this is account or if it's password. So we don't need to get type as a string. And now we're just going to handle all of these exceptions. So I'm going to scroll up here, just copy this right here because I'm just going to throw another exception, and then scroll down to the left. And if I have an empty result set, then I'm going to come down here and say the only request or the only operation that can give me this error is this right here. When we try to look for a role and we can't find a role, which is going to be right here. But other than that, we're just doing update. We're not doing any select. So we're not going to have this empty result sets for anything else except for this get role here, because we're passing in the role name that we're going to look for to assign to the user. So when I implement this method, I'm going to use a select statement, which is going to give us the possibility of having an empty result set. Okay, which is what I'm catching here. So I know that in this case, I'm just going to say no role found by name, and then we're going to pass in the name. In this case, that's going to be role that user that name. Okay, and I'm going to do the same thing for this exception. So here we're catching every single exception. So whatever exception that we get that's not the empty result data access exception, then it's going to be cut here. So in that case, then I just want to send something generic. I'm going to select all of this, and I'm just going to say an error occur, and please try again. Okay, because it can be anything at this point, like anything that can go wrong in this specific case. And then we can get rid of this. And if I see if I can scroll up a little, so you see how this method is really big. Even though we're trying to like make sure we're doing the minimal, we're still gonna have a few lines of code. Okay, so the comments make it a little bit bigger. And I'm gonna remove the comments because I don't really like comments in my code unless it's really important that I explain what the piece of code is doing. But in this case, it's pretty straightforward, but I just wanted to give you an outline of what we're gonna be doing. So I'm gonna go ahead and remove all of these comments. Okay, just so that I can see the actual size of the method, because we don't want it to be too large. Okay, with that one and remove that one. Okay, so this is acceptable for the size of the method. So we have from line 45 to 64 or something. So that's decent. Okay, I wouldn't make this bigger than this because for now we're already doing multiple different things, but this is an acceptable size for this method. I wouldn't make it any bigger. And I think this is going to be like the biggest method that we're going to be working on. Everything else is going to be smaller than that. So again, just to recap, we check to make sure that the email doesn't already exist in the database. If it exists, we throw an exception. Otherwise, we continue. We access the generated key holder so that we can access the primary key that is generated on the table. We get all of our parameters. We send the query to the database, so we use the update so that we can insert something into the database, and then we set the ID on the user object that we're getting here, and then we add the role to the user by calling the role repository, pass in the user ID and the role name. In this case, we're giving them the role user, and then we get the verification URL, and then we generate that URL, give it a type of account, update the account verification URL table, and then pass in the user ID, the URL, and then we return the user. Now you can take all of this. So from the role repository, all of this, you can refactor it and put it in a different method. Okay, so you can say, assign role to user, and then you pass in the user or the user ID, and then you can create another method that's gonna generate this URL, and then insert it in possibly another method that's gonna send the email. But that's pretty straightforward because those are only one line, so you can just do it if you want. But that's what we're going to be doing in this method, just to create the user. We made a lot of progress so far, and we still have a long way to go because this is just the first method in this entire repository. Now, the next thing that I want to work on is the role repository, because this is really important. Whenever we create a user, we need to be able to give them a role. So let's go inside of the role repository. We need to create an implementation of this repository because we don't have one for it yet. And I'm just going to go ahead and also add some more methods that I know that I'm going to need. So I'm going to make some room by just pressing enter here, and I'm gonna add another one that's gonna be returning the role, and I'm gonna call it get role by user ID, and this is gonna take the user ID, so long user ID. And I need another one that's also gonna return the role, but it's gonna be get role by user email. So since we know that the emails of all the users are unique, we can use it as a primary key to get the specific role for a particular user. So here we're gonna say email, and I'm gonna have another one that's gonna return void, and it's gonna be update user role. So this one is gonna take the user ID, so user ID, and it's also gonna take the role. So we're gonna say role name. And I think that's all the methods that I'm gonna need for this. Let's remove all this space. Okay, so now we can create the implementation for this interface and then see how we can implement all of these methods. Let's go ahead and create the implementation for this. So I'm gonna copy the name. We're gonna do this inside of the same implementation folder. So right click, new class, and that's gonna be the implementation. So IMPL, press enter. And then we wanna implement the role repository of type role. And that's coming from our domain. Collapse this, and now we have to implement all of these methods. Okay. All right, so we need to do the same thing that we did in the user repository. So the first thing we're gonna need is this JDBC template. So we're gonna copy that, go over here, and then paste it in here. And I'm also gonna grab all of the annotations that we have here, and then just paste them in here. Okay, so that's all we need to do. So what I'm gonna do is I'm gonna go ahead and work on these as we need them, because right now I'm working on the create user feature. So we're only gonna be doing what we need to do to create the new user. And as we go through the different features, then we're gonna keep adding the implementations for all of these methods. Okay, so that's what we're gonna be doing. So right now we need to add the implementation for add role to user, which is this one right here. And it's gonna have a similar format with the try catch block. So let's see if we can leverage something here. So let's scroll up a little. I'm gonna copy all of this stuff. Also, I'm gonna close everything that I don't need just to make sure this is looking clean. So close all these things that we're not using right now. And then in here, I'm gonna go ahead and paste it. We're gonna clean this up though, because we don't need this. And I'm just gonna clean everything here and do return. Well, there's no return because this is returning void, and I think everything else looks good. So now I'm gonna do Control-Alt-O to remove all of these imports that were imported with the paste. So now we can start working on this add role to user. And I also notice if I go back to the user repository, I have this log here and I haven't used it. So we're gonna be using this log just to log things so that we know what's happening. So here, I also imported the log as well. You can see it here. We're gonna be able to use it inside of these methods. So the first thing I wanna do whenever this method is called is to log some information. So log info, and we're gonna say adding role, whatever the role is, so the name of the role, to user ID, and then whatever the user ID is. And in here we can pass in these values. So the first one is the role name, so we're gonna say role name, and then the user ID, so the user ID. So the logging that we're gonna have for this is gonna be adding role user to user ID, whatever the user ID is. And then now, since we have the name of the role, we need to find out role in the database. So we're gonna say role, which is gonna be the role. We're gonna set this equal to JDBC, which we imported above, and then we're gonna do query for object, and here we're gonna pass in the select role by name query. So I'm gonna say select underscore role underscore by underscore name and underscore query. Okay, this is a query. We're gonna create that. Obviously we don't have it yet, and then I'm gonna pass in the map. So the map of, and we need to pass in the different values that we're gonna need. So here we only need the role name to go inside of the query. So here we're gonna say the role name, and then we're gonna pass in the name for the value. So we're gonna say role name, and then we need to map this. So whenever we get the response from the database, we're gonna have a bunch of rows. So we need to be able to map these rows into an actual Java object. So to do this, we're gonna create something called a row mapper. And this is the first time that I'm introducing this. So we're gonna say new row mapper. Okay, that's what we're gonna call it, because we need to map all of these different fields from the database, or row from the database, in this case all the rows in the database. We need to map that into a Java object. We're gonna create that in just a second. And then here I'm gonna say JDBC, and then I'm gonna say update. So we need to update the user inside of the user role table, and then I'm gonna say insert underscore role underscore to underscore user. And then I'm gonna pass in the map again. This time I'm gonna pass in the user ID. So we're gonna say the key is going to be the user ID. So user ID for the key, and then the value is the user ID. And I don't have the queries yet, but this is all gonna make sense once you guys see the query. And then the second key we need is the role ID. So I'm gonna pass in role ID, and we're gonna pass in the value. In this case, that's the role that get ID. That's gonna inject the user by that ID inside of the user role. So insert role to user. This is supposed to be underscore query. Okay, we're gonna end every query with the word query. And let's define this constant. I'm just gonna define them for now as empty strings, just so we can get rid of these errors. So I'm gonna do the same for this one. Okay, empty strings for now. And also we need to create this role mapper. So as I said, as we go through, we'll create everything that we need to create. So I'm gonna remove that space at the bottom and then create this role mapper. So let's open this again and let's create a new package here. So we're gonna call it role mapper, and then here we're going to create the role mapper. So class role mapper, press enter, and this needs to implement the role mapper. So we're going to say implement role mapper. Oops, that's not coming from swing. This is supposed to come from JDBC. You can see it here, and then we need to give it a type because it's a generic. We know we're gonna be working with a role that's coming from our domain. And then now we have to implement this method, which is the map role. So we're gonna map all the different roles in the database as the result into a Java object. So that's what we're doing here. So let's collapse this, and I'm gonna do the same thing again. So press enter just so I can scroll up so that you can see this clearly. And all we have to do here is to return the role. We can call the builder and pass in the different values. So builder, and then we need the ID. So the ID is a long, and we're gonna get the result set. I'm gonna rename this to result set. So result set, and then we're gonna use that result set get long, and then we're gonna pass in the name of the column. So in this case, that's gonna be the ID. Okay, so we're gonna map the ID inside of the ID of the role in the Java object, and then we need to pass in the name. Again, we're gonna call in the result set, and then get string, and then we're gonna pass in the name. So that's gonna be the name. So that's the name of the column, and then we're gonna pass in the permission. So that permission, again, we're gonna access the result set, get string, and then we're gonna get the permission column. So we're gonna say permission. Okay, so that's just what we have to do for this. And then here at the end, we're just gonna do that build because we're done. Now, the reason that we can use this like this, if we go inside of the role, is because we have this annotation here, which is super builder. So this is a pattern that you can use instead of creating a constructor and then use the setters and getters. You can just use this builder here, but it's doing the same thing in the background. So that's why we're able to use the builder and then pass in the ID, the name, the permission, and then call build in the end whenever you're done. And it's just gonna create a constructor and then pass in all of the values using the setters, and it's gonna return that to you. So it's just a nicer way, a more elegant way to do this, but it's just doing the same thing. So now we can go back to the role repository and then make sure we import this role mapper. Okay, so everything looks good, and I think everything else is fine. So again, just to recap, we're gonna add a role to a user. So we're gonna say, give me the user ID, give me the role name, and then here we're just logging what we're trying to do. And then on this line, we try to get that role in the database by the name, and you're gonna see where I'm getting this role name, role ID, user ID. Whenever we're gonna write those queries, these are the names that we're gonna specify in the queries so that they can be replaced. Okay, and you're just gonna see this whenever I'm writing all the queries. It's just gonna make sense. And I'm gonna make a static import for this and do Control Alt 0 just to remove unnecessary imports. And we're getting a warning here. That's because we have to do the required non-null. So we can do that as again here, and then also do a static import for this, and then Control Alt 0 to remove that unused import. Okay, so that looks more elegant and more clean. So yeah, we're just trying to get the role in the database by using the name. So that's going to be like role user, role admin, role manager, and then we're gonna get the role, and then we insert inside of the user role. That's this query that we don't have yet, but we're gonna define the queries in a minute. And then we're passing in the user ID, which is the user ID we get here, and then the role ID, which is the role that we just fetched from the database. So that's gonna add that role to the specific user in the user role table. And then the two exceptions that we have here, they can stay because they just make sense. You can see this coming from the other class, then that's just fine. So another thing that I'm noticing as well, since we're catching this exception here And we know that we're also trying to catch it here. Okay, you can see we're doing that twice, so it's really unnecessary to do it twice. So I'm just gonna remove these two lines here. Okay, because we don't need to do that since we're already catching that inside of the add role to user method. So we don't need to do that again. It will be cut here and it will throw the exception, so the code will not even make it down there. Okay, so the next thing we have to do probably is to work on this email service, but we can leave that for a little bit later. Now what we can do is to be able to test this functionality. Okay, so we have the implementation, we have the repository, so we need to be able to test that this works, right? And to be able to do this, we need to actually write those queries that we defined. We haven't written any of the queries yet, so let's go ahead and work on the queries next. Let's go ahead and start working on the insert query. So I'm going to press Control, left click on it, which is going to take us to this class. And here, I'm going to put this at the top, I'll cut it and then paste it here. So what I want to do is to just write a query to insert the user in the database. So that's going to be pretty simple. So we're going to say insert into the users table, so users, and then we're going to give it the value. So the value is going to be first underscore name. Okay, so that's the table name from the database, last underscore name, because we're using underscore, email, and then password, and that's all we need. And then we're going to pass in the values. So we're going to say values, and then we're going to pass in the values in here. Now this is the difference between the regular JDBC template and the name parameter template. If we were using the JDBC template, you would do like question mark, comma, space, question mark. Okay, but in this case, since we're using the named parameter, then we have to use the actual name. So here we're going to say first name. So first name. Okay, camel case. Where is this first name coming from? So this first name is coming from here. Okay, so you can see we're passing in the parameters here, which we're getting from get SQL parameter source. And if I go down there, you can see we're setting it as first name. So whatever we set here as the key for the first name, that's what we need to set here as the key. And then we have to put a colon in front of it. Okay, so that's how the name parameter works. And it's very clear what we're trying to do as opposed to using question marks. Okay, so that's why I'm using it instead of question marks or instead of the regular JDBC template. So that's going to be whatever the key that we pass either in the parameter source or in the map. So whatever the name of the key is, that's what we have to replace here, but we have to prefix it with a colon. Okay, so first name, and then we get the last name. So I'm gonna say colon last name, and then we're gonna pass in the email. So colon email, and then colon password. Okay, so that's what we have to do. So we're gonna insert into the users table. So that's the table that we created. If I go down in the schema, that's this table here. You're only gonna get the first name, last name, email, password, and everything else is gonna be the default. So we don't have to pass everything else. And that's what we're doing here. So insert into the users table, first name, last name, email, password. The values are gonna be first name, last name, email, password. Okay, and then we have the get user email count query. This one is also gonna be pretty straightforward. We're just gonna do select count of everything. So count of star from the users table. So we're gonna say users, and then we're gonna pass in the where email equal whatever email that we're going to pass. Okay, so I put the colon again and then the email. The next one is the insert account verification URL. So if you remember, if we go back where this is being used, so it's being used up here. So we need to pass in the user ID and the URL inside of the account verifications table, as you can see here. So what we have to do inside of this query is to just say insert into, and that's going to be the account verifications, and we're gonna insert the user underscore ID, and we also need the URL, and the values are going to be, so values, and that's gonna be a colon user ID, and then we also need to get the URL, so that's gonna be the URL, and then we're gonna close that parenthesis. Okay, so insert into the account verifications, we're gonna pass in the user ID and the URL. And if you remember the account verification, let's scroll down a little. This is the table that we're referring to. So we're gonna put in the user ID and the URL. This ID here is auto increment, is the primary key, so we don't have to pass it. So that's the table we're entering the information into. So at this point, all of our queries are here. Now we have to do the query for the role. So if we go inside of the role repository, you can see we have two queries here, and they're defined at the top. So we have the insert role to user query, and then the select role by name query. Okay, so we have to define these two as well. So I'm gonna cut them out from here, And then I'm gonna go back, go inside of the query folder. So this folder right here. And then we're gonna say new Java class. Just gonna call this role query. And then I'm gonna paste them here and make sure I change the access modifier to public. Okay. So we're gonna define these two queries as well. So the insert role to user query is gonna be very straightforward. We're just gonna insert into the user role. So we're gonna say insert into user roles. So that's the name of the table. We need to pass in the user underscore ID and also the role ID. So role underscore ID, and the values are going to be role ID. So that's going to be the user ID and then colon role ID. And then the next one is select role by name. So this is going to be pretty straightforward. So we're going to say select everything from the roles table. So roles where the name equal to the name that we're going to be passing. So we're going to put a colon and then name. And that's all we have to do. And then I'm going to go here and scroll down, make sure these are imported. So I'm going to do more action, import static. And then I'm going to go up here. Instead of importing just that one, I'm going to put a star so that we can import everything, because all the queries that I'm going to have inside of this file, they're going to be used here. So all of our queries are in place. Of course, we're going to need more queries than these. We're not going to need a whole lot, but we're just going to need a few of them. And as we go through the features that we're building, then we're going to be adding these queries here. Okay, so what I want to do is to just go by feature. So if we're building the create user feature, then we're just defining everything that we need to do to create that user feature. So for now, I think we should be able to test this function or this functionality to create a new user. The only thing that we don't have working yet is the email notification. Okay, so to send the notification with the user email, and we're going to be working on this a little bit later. So now what I'm going to do is to define the rest of the structure. Okay, so if I go down here and expand this a little, you can see now we have the domain, enumeration, exception, query, repository. Inside of the repository, we have the repository implementation, and then we have the role mapper. So we're gonna need the service and also the resource or the controller, and that's what we're gonna be working on next so that we can test this functionality. Let's go ahead and create the user service. So again, I'm gonna right click and then create a new package. I'm gonna name it service, press enter, and then I'm gonna create the user service. So I'm gonna right click Java class, and then I'm gonna say user service. And this is an interface. I forgot to click that, so we're gonna see interface here. And then now I'm gonna collapse this. So the user service is gonna need a few methods. So the first one is gonna be the create user. So we're gonna say, well, I'm gonna make this return void because I don't have the DTO yet, and I'm gonna talk about that in just a moment. So we're gonna say create user, and this is gonna take the user. So user, I'm gonna see if I can import this user here. Make sure it's coming from our domain. Okay, the user is imported. Now there's a pattern in Java called the DTO pattern, and DTO stands for data transfer object. So basically what it is for example, if we go inside of this user, you can see that we have a lot of fields and stuff in here, like a lot of properties. Now sometimes a lot of these properties, they don't have anything to do with the users, but they have to do with business logic. So sometimes you just have a lot more fields here than you would usually have that they just don't have anything to do with the user, but you need them so that you can implement some business logic. So in this case, you wouldn't want to send all of this information to the front end. So for example, when a user create an account and I create the user for them, I'm never going to return them this string, which is the password. Okay, so in our example, we don't really have a crazy application here with a bunch of business logic and things like that. So we don't really have a lot of fields here that we don't want to return to the user. I actually want to return all of these fields to the user or to the front end except for the password. Okay, so that's why I'm gonna give you just an example on how this works, because it's a very popular pattern in Java that is used a lot, because a lot of times you don't want to return certain fields to the caller or to the outside world. But in our example, we want everything here except for the password. Okay, so we never want to send the password back to the user, okay, the encoded password that we're going to have in the database. So we're going to use that as an example just so that I can show you the DTO pattern or the data transfer pattern or object. DTO stands for data transfer object. So what I'm going to do is open this file tree again, and then I'm going to create a new package. This time I'm going to call it DTO. So DTO. And then inside of this package, I'm going to create a new Java class. I'm just going to name it user DTO in all uppercase. and then I'm going to press enter. Now the user DTO is going to be used to mirror the user. So let's go here and copy everything here, go back here and then paste. Okay, so we don't need these validation, so I'm going to remove all of these validation, remove, and remove this as well. And I think I need everything else here except for the password. Okay, so the only thing that we don't need to send to the front end is the password. And let me put the, for example, the data annotation here, just so that everything can be in a color so that you guys can see what I'm doing here. And also we probably don't need the data, we only need getters and setters in the constructor, but I'm gonna keep data for now. But you should probably use getters and setters in no args constructor. I'm gonna remove the password. Okay, so I'm gonna get rid of the password because we don't want to ever send that to the front end or to the caller. This is only gonna live inside of the application, like for example in the repository and maybe in some other business logic. We're gonna be using this user that you see here. But whenever we're gonna send a response with the user information, we're gonna send them this user DTO. Okay, so the DTO pattern is exactly that, and it's gonna allow us to map this user, so this guy right here, into this user and then send it to the front end, which if you're guessing is just a bunch of setters and getters, and then you know, set things over and then mirror this and then send it back to the front end. And in our case, we're sending everything, so we don't really have a great use case for this, but we're not sending the password. Okay, so that's why I got rid of the password here. I'm gonna do Control-Alt-O just to remove all of the imports that I'm not using up here. So this is the user DTO. So now we need a mapper. So we need a way to take this user and then transform it into a user DTO and vice versa. So we also need to be able to take the user DTO and then transform it into a user. So that's the DTO pattern. So I'm gonna go back here again and then create a mapper. So we have the DTO where we're gonna have all the DTO domain, and I'm gonna create a DTO mapper. I mean, you could put it inside of this folder as well. I'm just gonna, well, I don't want a class, but yeah, I'm just gonna keep it in a separate package. So I'm gonna say DTO mapper. Okay, so that's gonna hold all of the mappers, and then I'm gonna create the class user DTO mapper. So user DTO in all uppercase and then mapper. Okay, so that's gonna map a user DTO into a user and a user into a user DTO. So I'm gonna collapse this, and then I'm gonna add the add component so that this can be picked up by Spring. Oops. So add component, and here we're just gonna define some static method so that we don't have to create a constructor for this. So I'm gonna say public static and then user DTO, because that's what it's gonna return. So user DTO, and we're gonna say from user. Okay, you can come with any naming convention that you want, but I'm just gonna do from and to, okay, so that we understand what we're transforming. So here obviously I have to pass on the user because it's from the user, and then what I'm gonna do is just return a user DTO. So here I'm gonna say create me a new user, user DTO that is, and that's gonna be the user DTO, and then we're gonna say equals new user DTO. Okay, so we just call the constructor, and then I think there is a library and Spring that you can use called bean, I think it's bean utils. Yep, that one. And then you can say copy properties, and then you give it what you want to copy from. So we're going to copy from the user to the user DTO, and then we can just return this. So we're going to say return user DTO, and we need to import this user here, import. All right, so that looks good. And then we can do the same thing to a to user. So we can copy this, and then I'm gonna just press enter multiple times just so that this can be at the top here, and then paste this, and then we're gonna call this to user. So to user, this is gonna be just the reverse of what we just did. So this is gonna take a user DTO, so it's gonna return a user. It's gonna take the user DTO, and I'm gonna name it user DTO, and this is gonna be the user, so that's the user, calling the constructor. Okay, and then we're gonna do the same thing. We're gonna copy from the user DTO to the user. Okay, and then return that user. Okay, so we have a to user and the from user. So this is our mapper and this is the user DTO. Okay, so we're done here. Now in the service, instead of returning the user, I put void here temporary, we're going to return the user DTO. So that way, when the controller or the resource calls this service to get the user or to create a new user, then it's going to get the user DTO and not this user here that has the password, because the user DTO doesn't have the password. And another thing you would see in the DTO classes as well is everything else that is associated with the user. So for example, the role and the permissions, you would define them here. So you would have another string that's going to be the role, and then maybe a list of strings that represents the permission. And then you would have another mapper that would just take, maybe the roles and the user and then map everything to a list and then return just one single object with just this information in addition to the list of all the roles and also the role name. So that's another thing that you would do as well, but we don't have to do this here. I just want to make sure that you're familiar with this pattern because it's used a lot in Java or in big Java applications, and I wanted to introduce you guys to it. So the user service is not returning the user but the user DTO, and now we need to create the implementation for this user service, and that's what we're going to be doing next. We're going to come back to the user service to add more methods. But for now, since we're just dealing with the create user feature, so we're only going to keep this for now. But later, we're going to come back and add more methods as we need them inside of this user service. So let's go and see where we are. So we are here in the service folder. In this folder, I'm going to create another package that I'm going to call implementation. So the same thing that we had for the repository. And then here, I'm going to create the user service implementation. So I'm going to say user service impl and then press enter, and in here we're going to implement the user service. So implement user service, and it's going to force us to define all the methods. You guys already know how this goes. Implement methods, and we only have one for now. So now we have to import the user repository. So we're going to do the same thing again. So I'm going to go up here. First of all, we have to define this as a service, so that's going to be a service, and also we need the required args constructor, and then we're going to define the dependency injection here. So that's going to be private final. We need the user, that's uppercase, user repository of type user, and we're going to give it the name of user repository. So that's that, and I'm going to do the same thing again, just put a lot of spaces at the bottom just to make sure this is up here. Okay, so now we can work on the create user, which is the implementation of the user service. And now all we have to do is to just say return the user DTO mapper. We're going to call our mapper, and then we want this to be from user because that takes the user. And then here we're going to call the repository. So user repository that create user, and then we pass in the user. Okay, so you can see how this is coming together nicely. So we're saying, all right, we need to be able to map the user after we create that user to a user DTO. Okay, so we're calling our mapper, and then we say, well, call the repository, give it this user, which is gonna, if we go inside of the implementation here, it's gonna do this. Okay, so it takes the user and then it's gonna do all of this and then return that user. Once all of this is done, then we give this user that is returned from this code here, the repository, we give it to from user. And if we go inside of from user, it's gonna take the user and then create a user DTO and then return the user DTO, which is what this is returning. Okay, user DTO. And that is what the controllers or the resource are gonna use because we don't wanna expose the user password. And again, very small example because we're only removing one field, but you can see how this can become really handy when you have a lot of fields here that you don't want to return to the caller, or you don't want to expose to the outside world, but you just want to use them for your business logic. So this is the user repository for now. And the next thing we're going to do is to create a controller or a resource in this case, since this is an API. So collapse all of these and go to the main package, create another package. That's going to be the resource package. And then we're going to create the user resource. That's the file, user resource, enter. So this is going to be our controller, and I'm going to come down here. This is going to be at REST controller, and I'm also going to define a request mapping. So we're going to say request mapping, and we're gonna put everything under let's define the path to be under /user. Okay, so everything is gonna leave under user. Again, I need more space here. I need to come back and clean these up, all these spaces that I've been putting. All right, see, I didn't remove all these spaces. Okay, all right, but anyways, we can do that later. So here we're defining this as a REST controller, and then we're calling the request mapping to set everything under /user. And then I need the required required args constructor from Lombok. And then now we're gonna define the user service. So we're gonna say private final, that's gonna be the user service, and that's gonna be name user service. All right, so that's our dependency injection. And now we're gonna define our first controller method. So this is gonna be post mapping, and that's gonna go to, let's do /register. Okay, when we register a new user. And then we're gonna say public, and it's gonna return a response entity of type HTTP response, which I don't have yet. So HTTP response. Okay, so I don't have that class yet. So let's go ahead and create this HTTP response real quick. So go back here, and this is gonna live inside of our domain. Okay, so the domain here, we're gonna create a new class, call it HTTP response. Okay, so this is our custom HTTP response. All right, and here we need the data. Oops. So data, and we need the super builder. So super builder, and then we need the JSON include. So JSON include, and we need non-default. So non_default. Okay, and again, make sure I do a static import for this, and then Control-Alt-O to remove unused import. And I'm gonna add in some space here just to make sure you guys can see this clearly. So again, if you're familiar with any of my courses, you know that I like to keep my APIs very consistent, and that's what this response is representing. So we're gonna be sending this response every single time we have a request that comes in. Either if the request is successful, if it's a failure, this response is what we're gonna send back to the user. And that's how I like to build my APIs. So I'm gonna use protected here because you can access these from outside of this class inside of the same package. And then I'm gonna do string timestamp. And then I'm gonna do protected again. We need an int for the status code. And then I need another protected for the HTTP status. So HTTP status coming from Spring Framework. That's gonna be the HTTP status. We can just call it status. And I need the protected for a reason. So protected, which is gonna be a string for a reason. Okay, so if there is an error, we're gonna send a reason. If there's no errors, we're gonna send a message. Okay, we also need a developer message. So protected string developer message. This is more for logging. We can use it in the front end as an API. We can just send it back to the front end, but we don't have to. But this is something that we can use for a more techie developer message so that we know what happened. And then we're gonna have the protected for a map. That's gonna be of type any for both the key and the value. And this is gonna represent our data. Okay, so every time we need to send some data, we're gonna be using this data here. And I think that's all we have to do for this HTTP response. And let's go back to the resource, and here we can import this class now, import, and that's coming from our domain. Okay, so HTTP response. And then I'm gonna name the method save user, for example, and we need to pass in the request body. So we're gonna say request body, and also the valid annotation. So we're gonna say valid, and we need to get a user. Okay, and I'm gonna import this. So the valid annotation is gonna make sure that if any of these things are empty, as you can see here, I think null as well. If any of these fields are empty or they give us a bad email, then it's gonna throw an exception. And we're gonna be catching this exception and then customize them a little. But either way, the request will be declined if any of these fields are empty or invalid, at least for the email here. So back to the resource, and we're gonna put the body of the method. And what we want to do is to just call the user service and call create user, give it the user, and we can get a hold of the response as well, just so you guys can see it. So user DTO, just gonna name it user equal, and then, well, we can't name this user DTO because we already have user here. And we're gonna call the return, and we need the response entity, and then we're gonna call the created, and we need to give it a URI. I can pass null for now. We're gonna change that though, and then we're gonna pass in the body. I'm gonna close this just so I know what I'm doing here. And inside of the body, we're gonna pass in the HTTP response because we mentioned that this is the type that we're gonna be passing in. And again, we're going to call the builder pattern. So we're going to say builder and then pass in the timestamp, and we can pass now, and we're going to do to string, and we need to import this now. So more action, import static method, and we need the local date time. Okay, so that's the one that we need. And then we can pass in the data. Here I can say for the key, we're gonna say user, and we can pass in the user DTO. And since this is a map, we have to do of, call in the map, and then close this. And we need to do the static import for that as well. So more action, import static, and oops. All right, I'll just do it manually. So map that. Okay. Oops. Open. So here I'm gonna do static import. Okay. And then we need the message. So we're gonna have a message this time and not a reason. And we're gonna say user created for the message. And then we're gonna pass in the status. We need a dot. And this is going to be HTTP status, so we can just pass in the created. And then we need the status code, and then we can pass in the created that let's make sure we can import this first. This HTTP that status created, and then we can get the value, that value. Okay, so that's gonna give us the code for created, which is 201, and then we're gonna say build. And I need to move this over here, make it nicer, delete this extra, and let's just get rid of this thing here, this null here. Get URI is a method that I'm gonna create, and let's just create this method down there, create method, get URI. And just so that I don't have to think about this again, so let's say URI that create, and then we can pass in a string. We can do the same thing that we did. So if we grab all of this stuff here and then go back and paste it in here and import these things. So we want to go to maybe like user get and then the user ID. So here we're gonna say user ID, and then we can get rid of everything else. Okay, and close this. So this is the URI, like you have to specify maybe like the location. You can see here the created. If I go inside of it, it takes the location, like the location of the resource that just got created. So you can see they're passing it here as the location. So we're just gonna say, hey, if you go to our API and then go to /user/get, so we're gonna create a method. When you pass get in the user ID, it'll give you the user. So that's the location of the resource that just got created. They just have to look at the ID of that specific resource and then pass it here. And all of this string is just gonna give us the context path, which is just gonna be like the URL. So that's looking good. I'm just gonna do some static import here just to make this look a little nicer. Control-Alt-O to clean all the import. And I think this is all we need. And also notice that you see that I'm returning the user here as part of the data, but that's only because we're testing this. Okay, we're gonna use Postman and then test this functionality to make sure that we can create a new user. But I'm not gonna be returning this user to the front-end application whenever we build the front-end application, because they don't need the user. They just need a message to say, hey, the user was created, please check your email, blah blah blah, and then they can go from there. So they don't need this user here, we don't need it. But since we're testing and I want you to be able to see it, then we're just returning it here as part of our data. So I think that's everything we need. And what we're going to be doing next is to just run the application, make sure everything works, and then test it out and see if we can create a new user here. So let's go ahead and do that next. There's one quick housekeeping item that we got to take care of, which is to populate the different roles in the roles table, as you can see here. And I just typed this out so that you guys don't have to, watch me type all of this out. I'm defining 4 different roles: role user, role manager, role admin, and role sysadmin. And I define the permissions associated with these roles. And if we don't do this, whenever we run the application and try to create a new user, then it's going to fail, because we're going to try to find, for example, the role user by that name. So we're going to say, hey, select everything from roles where the role name equal role user, which is what we're doing in the Java code. And when we run that query from the Java application or the Spring Boot application, then it's gonna go ahead and fail because we don't have that role, like the roles table is empty. So we need to populate the roles table so that the application doesn't fail whenever we run it and try to fetch this role user here, which is the role that we're assigning to newly created users. And I have a few statements here and I'm gonna run them one by one. So the first one is to use the specific database that we want to run these queries on. So I'm gonna go ahead and run that. Okay, that was successful. So now we have the secure copy database highlighted because that's the one that the subsequent queries are going to be run against. I'm going to select everything from roles so that you can see there's nothing there. You can see it's empty because we haven't populated any of these tables. And then I'm just going to go ahead and run that one. So I'm going to go ahead and highlight it and then click here. Okay, that was successful. So now if I go back and run everything from the roles, you can see we got all the different roles that we want to have in the application. And another thing I want to bring to your attention is I'm defining these in a way that I chose to, right? So I came up with this, like I chose to do it that way. I decided to put a string for the role, so role underscore user, role admin, etc. And then I separate the different permissions by a comma, as you can see here. Read user is a permission, and then read customer is another permission for the user role. And then I keep adding more permission as we go down the list. So for a manager, they're not only going to have the permission to read user and read customer, they're going to be able to update user and update customer. And for an admin, they're going to be able to read user, read customer, create customer, update user, and update customer. And then the sysadmin is going to have all of the previous permissions in addition to delete user and delete customer. So this is something that I choose, that I came up with, but you don't have to do it that way. You can come up with your own design and then populate the tables the way that you want to. Sometimes numbers are used, so you don't necessarily have to use strings. Sometimes they represent the different roles by a number. It's really going to be up to you, whatever you're most comfortable with, and then you're going to implement it that way, whatever makes sense to your application. But this is what we're going to have. As you can see, our table is here. We have all the different role names, and then we have the actual permissions that are associated with that role. And I'm also going to give you this, by the way, and I'm going to show you how you can populate your tables from running the application itself. So we're going to put all these queries inside of the Spring Boot application, and then whenever we run the application, we're not only going to be creating all the tables and everything, we're also going to be populating those tables with data as I'm doing here, but we're going to be doing it in the Spring Boot application. And I'm going to show you how we're going to do this a little bit later. So before testing the user registration, make sure you populate your roles table, and then we're going to go ahead and test that functionality. So we've added a lot of code in the application so far, and at this point we're ready to test the register. Since I've been writing code for a while, I'm pretty sure I made some mistakes somewhere, and my guess is the application is gonna fail whenever I run it. And I didn't run it before, I don't know what's gonna fail. And the reason for this is because I don't wanna do anything in the back, like behind the camera. I want to be able to show you how you can go about debugging your code, because this is also a skill that as a developer, you need to have under a belt. When your application is not working, it's breaking and it's giving you an error, you need to have an approach so that you can tackle this problem. So I'm 99% sure that if I run this application right now, it's gonna give me a failure. And I wanna take that as an opportunity to show you my thought process and show you how I go about resolving bugs or issues in my application. So I'm gonna go ahead and just go at the top right corner here and just run the application, and let's see what happens. We're just gonna give it a couple seconds. Okay, it's coming up, so let's see. Okay, as I was expecting, it fails. Now, when the application fails, it's gonna give you some kind of error, right? So what I'm gonna do is just scroll up. Okay, so I'm scrolling and I'm all the way at the top. Let me expand this a little bit more. So I'm gonna scroll down. Okay, so this is info, so there's no error here. I have a warning, but we can ignore that for now. And then here I have an error, right? So it says there's an error. Okay, so I can see that at this point, that's the beginning of the stack. Well, to give the details of the error, right? So application fails to start. So what's the problem? Now it says parameter 2 of constructor. So the constructor inside of the user repository implementation, it says it requires a bean of type bcrypt encoder. Okay, so I already see what the problem is. So let's scroll down. Okay, so it's complaining because we're trying to use the bcrypt encoder to encode the password of the user, but we don't have a bean for this encoder. Okay, so that's a pretty simple solution. We just have to define a bean of this type, and this error should be resolved. And this is actually something that I forgot to do, and I mentioned that as I was using the encoder. So we know it's inside of the user implementation, right? User repository implementation. So let's go inside of this class. So repository implementation, and we're going to go inside of the user repository. And let me expand all this. So it's complaining for this, right? We're passing this in, we're auto wiring it. So we're doing the dependency injection for this, but the bean is not defined. So we have to define it. So I can copy this and I can just put it temporarily inside of the main application class. Okay, so let's go here and I'm gonna expand this and then go down here, and then I need to define the bean. So I'm gonna say this is gonna be a bean, and it's gonna be public. This is gonna be the type. Give it encoder, that's fine, and then we're gonna return that bean. So we're gonna say return a new Bigcrypto encoder. Now another thing we can do, we can give it a strength for the algorithm. So I'm gonna say strength. Okay, and then I'm gonna define this at the top. Let's create constant, it's an integer, and here let's say 12. And I want this to go all the way at the top here. And I'm just gonna call it password encoder. So password encoder. And of course, this is a method, so we need to do open and close. Okay, so that's the password encoder that it was complaining about for the bean. So we created the bean. So far we have one problem, and I just took care of that problem. So now what I'm going to do is I'm going to run the application again and see if it works. Okay, so let's close out of here and let's run it again. Well, I'll still close this and let's run it. So I keep running the application and fix the errors one by one. And now you see the application has started. Okay, so the Spring configuration kicked in. It gave us this password so that we can use. And then you see at the bottom that the application has started. But still, we haven't tested this functionality. We don't know if it's working. I don't know if it's working. So we're going to do it together. And to do this, I'm going to be using Postman. So I'm going to keep the console open because we're going to need to take a look here to see what's failing. And let's bring Postman. So I have Postman here. If you guys want to use a different client, feel free to do that. I usually use a client called HTTPy, but for now, I'm going to be using Postman. So let's create a new request. So we know that it's going to go to http://localhost and 8080/user/register. Okay. And then we need this to be a post request. We need to pass in a body. That's going to be raw and then JSON. And then here we're going to pass in the JSON object. We need a first name and let's say Junior. And I'm going to copy this and paste it multiple times. So we need the first name, we need the last name, and then we need an email. Let's do junior@gmail.com. And then we need the password. So we're going to say password 1 2 3 4 5 6. Okay, for now I'm using dummy data. Obviously this is not a real email and this is a dummy password, just so that we can test. So let's go ahead and send the request. And I got a 401. 401 unauthorized means I'm not authorized to access the application. So this call itself didn't fail, but Spring Security rejected the call because I don't have any security configuration. So it's just gonna stop every request from coming in, every request that's not authenticated. So if I go back to the application now, so you see we have no errors because there wasn't really one, but we get this password that Spring Security provided for us. So we can use this password and bypass the security, but I don't want to do that for now. I don't want to have to deal with the security. That's going to be in the next section where we're going to take a deep dive in Spring Security. What we can do is to deactivate Spring Security because we don't want to deal with it. There's multiple ways that we can do this. One of them is to just go and inside of the properties file, so inside of this file, and then we can specify a specific class to ignore or a specific configuration to ignore. Or we can go inside of the main class and then we can specify a configuration to ignore, for example in here. Okay, so in the Spring Boot configuration, we can pass in an array here of configuration that we want Spring Boot to just ignore. Let me show you that. So I can say open and close, and then we're gonna say exclude. You can see it's coming up, and you can pass in one class or you can pass in an array. So I cannot pass an array, and in here I'm gonna say security auto configuration, and that's the class. So I'm saying, hey, ignore the security auto configuration. So now it's just gonna not spin up an instance of this bean, and we won't have this problem anymore because we're excluding it from the auto configuration that Spring is doing. Because remember, I didn't put any configuration for security, but then when we check the console, we still got a password and we still can't access the application. That's because we have the Spring Security dependency and the POM file, and it comes with a auto configuration, as you can see here, which is this class. So we're just saying, hey, exclude this class in the auto configuration because we're not dealing with that right now. And another way we can do this, you can see the fully qualified path for this class. I can just copy this and go to the application.properties file, and then in here we can do something similar. We can do Spring, and we want to go to auto configuration. So I'm going to say auto configuration or auto configure, and then I want to say exclude, and then I pass the fully qualified name of the class that I want to exclude. Okay, so it's in red, but don't pay attention to that because IntelliJ is being weird here, but that's technically doing the same thing. We say, hey, for auto configuration, exclude the security configuration or the security auto configuration. Okay, so these two are the same. So now if I rerun the application again, I mean, even if we have both of them, that's not going to cause a problem, but I'm going to comment one of them out. And then if I check now, you can see the application started and we didn't have a password, which means the security auto configuration was completely ignored. So now let's bring back Postman and let's send that request again and see if we're going to get an error. So let me send it. Now I got a 500 internal server error. So let's see what that's about. Scroll down here. We can see we have an error. So an error occurred, and in my user repository, it's on line 60. Okay. Now scroll down. I don't see other description, and I can see how it's bubbling up. So you can see it goes in the service and it goes all the way back to the user resource, which means the actual error is in the user repository, but it bubbled up all the way to the resource because that's the endpoint that we called. I can click here. It's going to take me to line 60 here. So let's minimize this and let's take a look here. So you can see that's where the error occurred. So something here in the try block failed. So what we can do is go back here and try to take a look at this. So remember, we're logging the errors. You can see the logs for 3 errors, which is these logs right here. I see, hey, no value supplied for the SQL parameter name, no value registered for the key name. So it's saying, hey, I'm passing in a name in my query, but I don't have that in the actual query that's running on my SQL. So that's the error that I'm getting, and it's coming from the role repository. Okay, so you understand how important it is for us to put these logs here because they're going to tell us where the error is occurring. Now it's bubbling up to the user repository, but you can see if I scroll up a little, it occurred first in the role repository. So let's go inside of the role repository, which is when we call this right here. So we can right click and then we can do go to implementation. So it's happening somewhere here. This is the log that we got, and I'm looking at this query. I already see the problem because I'm passing in role name here. Okay, and if I go inside of the query, I said name. Okay, I put name here in the query, like this one here with a colon, but inside of my role repository, I pass in role name. So we need to change this to name. Okay, so the name of the role, they should match. So this name right here, so I could either change this to role name or I can just make this name. So I'm going to change this to name and then passing in the role name. So that is the error. Now, if I go back here, remember we're here. This is where the error occurred. What that means is that this is all executed already, which means the user was created, but it failed when we try to pass in the role to the user. So technically, if I open the database, I should see the user, but the user is not going to have any role. And I can show you this because I can already see the sequence here. Let's rerun the application and we're going to check the database in a second. Let's rerun it. So it's running. Let's open Postman. And if I run this again, we should get an error for this, the duplication of the email. So send. So we get another error. So let's go back, scroll up, and you can see it here. Email already in use. Please try again. Because the application ran all the way up to line 50 here and it failed on 51. So let's go back to the database. So this is my database connection. I'm going to log in here and then I'm going to go to users and you can see that the user is here. Okay, so the user was created. You can see here with the ID 24. So I'm going to go ahead and just delete it because we want to rerun it again. Apply. Okay, so now if we send the request, it should be successful. So let's open Postman again and then send the request and it's successful. Okay, so you can see the user was created, we get the timestamp, and then we get the data which contains the user. So we just have these values and then everything else is null. The user is not using MFA, so default for false. The account is not locked, so this is true. Is it enable? False, because they just created a new account, so we want them to verify their email and then we're gonna set that to true. So far they won't be able to access the application and everything else is null. Okay, so you can see it's working. So every time you have a problem in your code and it's not working, you just run the application and and then you look in the console to see what the error is, and then you just track it from there. That's typically my thought process. Other developers might do something slightly different, but I just run it and see what's failing, and then I try to get a good understanding of the error message that I'm getting. And another thing too, the logs that we added are really important. So whenever we have an error, we want to log the error. That way we know where it occurred. So for example, if I scroll up here, I don't know if I have the other error, but it will tell you where the error occurred, like what class caused the error. And you can see here we have line 45, which is where the error occurred. Okay, so that's not the log, but for the one before, these logs, like the logs and the catch blocks, they're really important because then they tell you where the error occurs. So make sure you have log properly placed in your application. That's going to help you a lot in debugging. The next thing we're going to do is to set some configuration in the application. So let me close everything here. And what I want to show you guys is how you can have multiple different profiles in a Spring Boot application, because right now we're doing everything on local, but I want to give you all the structures because we're going to be creating a CI pipeline for this. When we're going to deploy it, we're going to deploy it in many different ways. We're going to deploy it in our local computer, we're going to deploy it in our local network, and then we're going to deploy it on AWS. We're going to be using GitHub Actions, and we're going to be using AWS code pipeline. So we're going to be doing a bunch of things. So it's really important that we set out our configuration in terms of the different environments that we have. So far we only have this properties file. Okay, so we're gonna redefine this in different files and then set them according to the environment that the application is running on. And we're gonna use profiles to do that. And what I'm gonna show you is I'm gonna show you how we're gonna configure profiles in the entire application and then pass in different application properties file so that we can run the application in different environments. That's what we're gonna be doing. So I hope that was useful to you. I hope you learned something new. Whenever your application is not working, you just run it and see what is failing and then just go from there. Like you look at the error, you see why it's occurring, and then you go to that section in the code and then you walk through the code and see if you can understand what's causing the problem. And that's what we did, and we were able to save a new user in the database. If I bring that up, if I run this query again, you can see our user is here with all the defaults. Whenever your application is not working, run it, and then when it breaks, you just look in the console, you see what the error is, and then you go from there. Okay, so that's what we're going to be doing throughout the entire course, so that we can solve every issue that we're facing. All right, so next thing, like I mentioned, we're gonna set up some configuration, and that's what we're gonna be doing next. Let's take a quick second just to understand why we're trying to have different application properties file for the same application. So for example, if we're going to deploy the application, we're going to have these properties, right? So we're going to have these properties, and these are pointing to local development properties, right? For example, this URL is a local URL, right? And this is let me in and root. Those are not credentials that you're going to use in a production environment. If we were to just say we wanted to run this application and we want the application to connect to a different database, then we would have to come in here, remove this URL, and then pass in another one. And let's say that we wanted to change, let's say most of these configurations. We would have to make so many changes just so that we can run the application in a different environment. And this is just a silly example, really, because there are so many benefits for being able to have different properties file in your application. But I'm just taking a silly but valid example here. So we would have to come in here and change everything to the production environment that we wanted to point to, and then run the application. And then let's say we wanted to go back, then we would have to come back here again and then change everything. So it would be nice if we can say, well, I want to create another properties file, and instead of this properties file, I'm only going to have production configurations. And then I can just pass in a single flag to switch between the dev properties file and the production properties file. So that would be really easy because then I can switch between the two. And these environment variables, you can also pass them in big cloud infrastructures. So for example, if I'm deploying the application in AWS, either if I'm using a EC2 instance or whatever service that they have, right? It doesn't matter if it's AWS or Azure, they're always going to allow us to pass properties file. So we can pass the flag, for example, we can pass local, and then it's going to pick up the local file that we have for our configuration. Or we can pass in prod, then it's going to pick up prod because in prod, that's where we have the prod URL. Or we can have a sandbox for testing. So we would pass in the sandbox properties file. So it's really important that you separate these concerns so that
that when the application is deployed, everything is more or less seamless so that you don't have a lot of manual or user intervention, which is kind of the whole idea behind the CI pipeline thing, right? We want to make one push and then the application is deployed without having to do any deployment. We just push the code to the repository and then it's going to trigger a series of events and ultimately the application is going to be deployed, right? We're going to get to that later, but you get the idea. So what I want to do is to take all of these properties and then set values for them for a production environment. So the first thing I'm going to do is I'm going to go ahead and copy this file and then paste it here. And then I'm going to give it a different name. So I'm going to say application-dev.yaml. Copy that name too. And then I'm going to come here again. Let's copy this one again. Paste it here. And then I'm going to say this is going to be the prod. So I'm going to say -prod. Okay. It's important that you name it that way because Spring Boot is configured to pick up these files by -prod. Okay. So it's going to match this name with the profiles. Okay. So it's important that you say application dash whatever key you want and then YAML. Okay. So we're going to say, okay, now I have a dev, a prod, and then the regular one. And as of right now, they have all of the same information. So what I'm going to do is I'm going to go inside of the main one. So the application.yaml, I'm going to delete everything. Okay. So I'm going to delete everything in here because I'm passing the same values already here and I'm also passing them here. Okay. So I don't have to have anything in here. I mean, I can still have global properties in here, properties that's global to the entire application. That doesn't have anything to do with either dev or prod. They're just things that we want the application to have regardless of the environment the application is running on. And in here, what I'm going to do is I'm going to say, I want to do Spring and then profiles and then active. Okay, so I'm going to tell it which profile is active. For example, if I put prod, when I run the application, then it's going to run and use this properties file instead of the dev because I specify that it's going to be the prod that's active. Okay, and I can do the same for dev and I can quickly show you that. So for example, I'm going to change this to dev. Let's change this to dev. And then in the prod, let's say I'm going to say, you know, prod URL. Okay, this doesn't exist. Okay, that doesn't exist. So if I run the application now and I specify dev, it should run with no problem because it's gonna point to this dev, right, where we have the proper configuration. And by the way, I'm gonna comment that out because we already have it defined in the application, but you can still have it here if you want to use it that way. But yeah, so what's going to happen is it's going to run and it's going to say, okay, the profile that is active is dev, and then it's going to pick up this properties file instead of that one. So let's go ahead and run it. I just want to show you that in action. So we're going to run it. Okay, so it's running, right? You can see it started. Now if I scroll up a little, you see it says the following one profile is active because you can have more than one active profiles. Dev. Okay, so the application picked up this properties file, so the dev one, and you ran. Okay, so that works. Now let's say I go back here. I'm going to change this to prod. So I'm going to say prod. Okay, so prod. Now if we go into the prod one, you can see that I'm passing in a bad URL here. So which means if we run the application again, then it should fail because that's not a valid URL for the database. So let's rerun and bring this up a little. Okay, give it a second. There you go. See, it failed. And if I scroll up, you'll see prod URL. It doesn't know what that is. It can't connect to it. And we got this java.net unknown host exception because it could not connect to this host. Okay, and if we scroll up again, you'll see that it's going to tell us that the prod was active, the prod profile. You can see it right here. The following one profile was active. Prod. Okay, so that's clear. We have a way to separate prod configurations and dev configurations or local configurations, and we can have as many as those as we want. Now we're gonna take this a step further. I have to come in here again to do this manually, right? I have to come in here and change this to prod and then change this to dev. It's not too bad, but we can do even better. So what I'm gonna do is I'm gonna do at, and then I'm gonna say spring.profiles.active, and then I'm gonna do at again. Okay, so this is a special syntax you can say that we can pass in here so that it can pick up whatever profile that is active that we can set either in the application or in the POM file. So in the application with Java code, we can also set what profile is active, either the dev or the prod. Okay, and again, we can have as many of those as we want. The dev would usually be local or dev because that's like your development environment, and then the prod would be like production, and then maybe you'll have like a sandbox or something else that's in between the development
development and the production, because usually when you build an application, you have a deploy that goes into some kind of a sandbox, which means it's going to be deployed, but the data is not going to be real. And then we're going to have a bunch of people that are going to come and test the application, like UAT testers, user acceptance testing testers, or people that are working in your company that will test the application for you, because you want the application to be acceptable from a user standpoint. So that's called a UAT testers. That's actually what I was when I first graduated from school. When I first graduated from college, I was actually a UAT tester. Like, I would test the software for a specific client before they can deploy it to production. So this is gonna point to whatever is active. Okay, so now what I need to do is I can either do it in the application or I can do it in the POM file. So let's go inside of the POM file. What I'm going to do is underneath dependencies. Okay, so we have all of our dependencies here. So I'm going to go down there before build. So here we're going to have to define profiles. Okay, so you can see it coming up here. And then inside of the profiles, we're going to have a bunch of profiles. So I'm going to say open profile. And then this profile, they need to have an ID. So I'm going to say ID, and the ID is going to be dev. Okay, so that's the same name that we specified in the properties file. Okay, so you can see here dev prod. It's important to follow this naming convention, otherwise it's not going to work. And then after that, we're going to say properties, and what we want to pass inside of the properties is the active profile. So inside of the properties, I'm going to come back in here, and I need to remove this. Okay, so inside of the properties, I'm going to come back in here and then say profiles.active. Okay, so I'm defining which profile is active, and then here again I'm going to pass in dev. So we have the profiles tag, and then inside of that we're going to have a bunch of profiles. We're going to give them an ID, so they're going to have the ID of dev, which is the same name that we defined in the file name, and then they're going to have a properties tag. Inside of that we're going to define Spring profiles active, and then we're going to pass in the same name, and then we can copy this and do it for the prod. So here I'm going to come down, paste, and then I'm going to change this to prod. PROD, and then pass it in here as well. So we have our two profiles. The other thing that I want to do is, by default, I want one to be activated. I want one to be active by default, and I want the dev to be active by default unless I specify another one. In this case, that would be the prod. So what I can do here, I can pass in another tag. So I'm going to say open activation. Okay, you can see it coming up here, and then activation, and then I'm going to say activate by default, and then that's going to be true. Takes a boolean. Okay, so we're going to pass in true here, which means by default the dev is going to be active. Okay, so that's the configuration that we need to pass in here. And then remember, we're gonna have the syntax, and we can still have other properties in this file if we want it. In this case, I don't have any, but you can put any properties here that are supposed to be global to the application. Like, they don't have anything to do with dev or prod. They always should be defined in the application. But in this case, we have a prod one, and then we have a dev one. Okay, so again, gonna copy these two, just paste it in here. Okay, we want to, all right. Okay, so now if we run the application, by default, it's going to pick up the dev, and applications will run just fine. So let me run it again. Okay, it's coming up. Okay, I'm going to go ahead and just scroll down a little. I'm just going to delete this target file so that it can reboot itself. I probably should rerun this to reload the POM file as well. Okay, I'm going to close this, and then I'm going to run. So you can see it's building again, and I bring this up a little. Okay, so it's starting, and everything was fine. And you can see here it says dev. Okay, now another thing you can do, and that's specifically in IntelliJ, you can pass in which profile is active. So I can go up here and edit the configuration. That's the configuration that is ran, which is the main class. And then I can go down here, and you can see active profile, and I can pass in a different profile here. So for example, I can pass in prod, and then I can click apply, click OK. So if I rerun this, it should fail. I don't know which one takes priority. I don't know if it's the one in the POM file. I don't know if it's the one here, but let's see. Okay, so it picks the one that we put in the configuration. So you can see here, it's probably gonna fail. Yep, it's gonna fail. Okay, so we don't want to do that here because this is very specific to the IDE. And when the application is being deployed, it's not gonna have anything to do with IDE. Maven is what we're gonna be using to deploy it, to run the application and pass in different properties to the command or the Maven command. But for now, you can see that we have the two different environments and we can switch between them. If the application is deployed, say on AWS, for example, then we have options depending on the way
way that we're deploying the application on AWS, we will have options to pass in properties, and we can pass in prod so that we can pick up the prod properties file. Okay, so I hope that makes sense. It wasn't really a lot of code, but it's really important that we do this setup a little bit early in the application because they're really important. Also, I'm not showing you the Git part of this because we're building a lot of code here and it's not saving any repository, which means if my computer crashed, then all the work that I did is gone. So that's very bad. So at some point, when you have the basic of the application, you should create a repository for it and then push the code there. Possibly set up your CDCI pipeline, or at least the tests and the CDCI pipeline, so that whenever you push some new code and it's tested and everything is okay. But again, we don't want to go out of scope for this application because there's just so much. I have so much knowledge. I just want to throw it at you, but we have to scope things. I can just throw everything at you all at once. But we're going to be doing the CDCI pipeline and the deployment, which is going to be like way later in the course. So you will see how I'm going to set up the repository for the application. At this point, like right now would be a good time, or even before now would be a good time to take this code and then create a repository for it and then push it to a repository so that if our computer crashes, then we don't lose all the work that we've done. All right, so you already guessed it. Whenever we're going to deploy, we're going to be passing in a different URL here. That's going to be the prod URL and then prod credentials and everything. And then we can just specify to pick up the prod file, and then it's going to run using these credentials and whatever other properties that we have here. And the next thing I want to do is to customize the banner. Okay, so I'm going to show you how to customize this banner. We don't want to see Spring here, so I'm going to show you how you can change that and then put whatever text that you want to put. So let's go ahead and do that next. So in order to customize this banner here that we have here, we just have to pass in a single file that goes inside of the resource, and it should be called banner.txt. It's a text file, so I'm going to call it banner.txt. Okay, so if we put anything inside of this file, that's what's going to be picked up in here. Okay, and I can show you that real quick. Let me see what's going to happen if I put some weird characters in here. I don't know, I'm just passing in whatever. And then let's run. Let's see what happens. Okay, you can see it right here. You see, it got picked up and we didn't have the generic Spring Boot. So what we can do here is put the name of our application, right? We can put secure capita. I mean, whatever I made up. So that's what I made up. In your case, it would be whatever a company, because you want to customize this as much as you can and then make it look like it's yours. You still know it's a Spring Boot application, but you don't want Spring to come up. You want the name of your company to come up. So if I rerun by just clicking here, okay, you can see it up here, secure capita. And I'm going to show you a website where you can pass in a text and then you can select how you want it to look. Let me bring up my browser real quick. And if you go to this URL, I'm just gonna zoom in and give you a quick second to take a look at it. Okay, it's gonna take you to this page, and I really just Google this. Like, I just go on Google and say, hey, how can I change the banner of the application in Spring Boot? And this came up. That was literally the first link, and then I just clicked on it. So you can change the text here for the banner, and then you can select whatever you want here. You can see it's gonna give you different I guess characters for the text. You can also include actual letters, as you can see here, and then it's gonna give you the version and everything else that comes up in the banner when you run the Spring Boot application. So what we want to do is to change the text, so that would be secure capita as the name for our application, and then you can just pick whichever one you like here. Take the first one. Let's see. That doesn't even look like anything. Okay, so you see I can just copy this like that and then put it in my application. Okay, but I don't want that one. I think the one that I like when I looked at this the first time was called Big, that one. So this is pretty cool, right? Looks really nice. So I'm gonna copy this, and again, you can choose whichever one you like. I mean, it's a long list. I don't know if you want to go through all of them, but you can pick whichever one you like better and then paste it in your application. So I got that one for Big. I scroll up a little more. I got the one for Big. Okay, so where is Big? Big, right here. So that's the one that I'm gonna put in my application, not just copy it. I'm gonna copy it again. Okay, copy. And then I'm gonna go back inside of my banner. I'm gonna paste it in. So we can define these properties inside of the properties file, like these two. And this one is going to be picked up by Spring itself. So we don't have to define this one. Whatever version of Spring Boot you have, it will be placed in here. So we don't have to change that one. but we do have to pass in the application title and the version. So I'm going to copy, and we can put it here because that's always going to be true. So I'm going to go down here and then say application title, and then I'm going to cut this and say secure copy time. Oops. Okay, so that's the title for the application. And then we have the version. So we're going to come here, delete this, the version, I'm going to put 1.0. Okay, so that's the first one. And you can see we have this squiggly underline here. That's because Spring doesn't recognize these as properties, and there's a way we can fix this. I can show you that later. It's not really important. So we have this defined inside of the application.properties file. So they should be picked up in here, and then we'll see these values in the banner when it comes up. So if you rerun the application again, stop and rerun, and then I'll scroll up, you can see now we have the name of our application, and then the secure copy version, and then the Spring Boot version. So I hope that makes sense. I hope that was useful to you. I mean, that's not a big deal, I guess, but it's still cool that we changed this because we don't want to be seeing Spring Boot when we can put our own banner here for our company name. And that's what you're going to see in companies as well. Like, you're not going to see Spring Boot come up. They're going to change it to whatever the name of the company is because that's what they want to see. They don't want to see Spring Boot. Okay, so that's all we have. So now we've customized the application. At this point, that's where I would also create a repository for the application. I think we need to move this over a little, maybe like that. Yep, just like that. Okay. But yeah, at this point, that's where you would like create a repository and then push the code there, because you don't want to lose this if your computer crashes or something like that, because you would lose everything. So you don't want to do that. Make sure you create a repository somewhere, GitHub or GitLab, and then push the code so that in case your application crashes, then you don't have to redo all this work that we just did. This is actually in the first steps in the application. Like, we probably should have started with the repository before anything, but it just keeps stressing this, that it's really important because we don't want to lose all the work that we've done so far. Obviously, I've already built this application and it's in my GitHub repository. I'm not going to lose the code, and I wrote the code. I mean, it would be a pain to write it again, but I can write it again if I want to. Okay, so I hope that was useful too. Again, you can change this to whatever name you want, whatever company name you want, or whatever characters you want to put in there, and then it's gonna come up looking like this, and we just have to put it inside of this banner.txt file. All right, so next thing we're gonna be doing at this point is to work on the Spring security so that we can authenticate a user and then start creating our filters and everything. So this section is gonna be pretty intense because we're gonna dive into Spring security. So let's go ahead and do that next. So before we jump into Spring Security and see how it works in the application, so before we put in any configurations or anything, I want to give you guys a quick overview of how Spring Security works. Now, Spring Security, it's not the most complicated thing, but it's not the easiest either. So it's going to take you some time before you can really understand how it works. So in this presentation, I'm going to try to give you a high-level overview of how it works. And hopefully that's going to help you understand the different components that we're going to be putting in the configurations that we're going to be doing. So Spring Security has something called filters, and this is what's securing the entire application. So the filters, they live in front of the servlet or the controllers or the MVC patterns. So every request that comes in, they have to come through the filters. And this is the first thing that you need to understand about Spring Security. Every request will come and these filters will intercept the request, and then they're gonna process the request to make sure if you log in, if you allowed to access a specific controller, etc. So this is the biggest overview that I can give you. Requests are coming in, and before they reach the controllers or the controller methods, then they have to go through these filters that is set up by Spring Security. You remember when we were trying to test the application, we couldn't do so because we had just the Spring Security dependency in the POM file. So once you put in the dependency in the POM file, there's an auto configuration that's going to configure a bunch of default filters. And this is why we couldn't access the application even though we didn't create any security configuration, because there's a configuration by default, which I explained to you guys. So So at a high level overview, you have all of your controllers sitting behind the servlet. We don't talk about servlets anymore, but back in the days it was servlet, but now it's just controllers and REST controllers. But the servlet is still there. And all of this is being protected by Spring Security filters. So there's a number of filters and I'm going to show you a list of them. So all the requests are coming in. Once we have Spring Security is going to put something in front of all of your controllers. And these are going to be security filters or Spring Security filters. And that's what's going to secure your application, because once a request comes in, they're not going to reach your controllers. They have to go through the filters, and the filters, they will process the request and make sure it's authenticated, etc., etc. And then if they're allowed to access the application, then the filters will let the request go through to the controllers. Otherwise, they will reject or throw an exception or something like that. So this is the high level overview, right? Now, how does the flow works? Remember when we put in the dependency, there is a default configuration, right? Which is why the application was secure, even though we didn't add in any configuration. So let's take a look at the security flow. So remember, we had the filters. So the filters on the left, they're going to intercept all the requests that are coming in. And what's going to happen is at some point, these filters, they're going to call something called an authentication manager. And the authentication manager is just going to manage, I guess you can say, the request, right? It's not what's going to do the actual authentication. It's the authentication provider that's going to do that. So the manager will figure out for the specific request or for the specific authentication, which authentication provider supports that kind of authentication. So it will try to find which authentication provider it needs to give the request with the payload to. And then that provider will reach out to something called a user detail service. You think of the user detail service as just what's going to give the users of the application, if there are any users. These users can be in a database, they can be in memory, it doesn't really matter. And notice that I put some names, some class names at the top of each one of these. So you see for the filters, the default one is the username password authentication filter. So by default, the auto configuration, it's going to configure a class or a filter called username password authentication filter. And by the name, you can tell that it accepts a username and a password, and it's going to take this information called the authentication manager to try to do the authentication. The authentication manager will then call the authentication provider. And by default, you can see I put it up here as well. The DAO authentication provider is what Spring configures by default. And that will need to access some user details information. And by default, it's going to use the in-memory user details manager. The in-memory user details manager is just a simple map that they have hard-coded users, and then they generate a random password every time you try to access the application. So even if you don't have any configuration at all, you're going to have for your filter the username password authentication filter, which is going to dedicate the authentication to the authentication manager. Authentication manager is just like a manager guy. So it's just going to try to find out which authentication provider the specific authentication supports. So it's going to call the authentication providers and say, hey, do you support or can you do this authentication? And then the DAO authentication provider is what's going to be the default since we don't have any configuration. So then it's going to give the payload or the information to the authentication provider. In this case, by default, that would be the DAO authentication provider. The DAO authentication provider needs to find a way to get the user information, and that's the user detail service. And by default, Spring implements the in-memory user detail service, which is a simple map, a user with the username user, and then the password is just randomly generated string, and then they print it on the console so that you can use it to authenticate. So you can see this is simple, but it's not that simple. This is still high level, but of course I don't want to flood you with, all kinds of information. Now, there are many different ways that you can implement Spring Security. There are many different ways to implement a security in an application or a web application just in general. So you can have just a simple basic authentication. So you pass in a username and a password every time you're going to access a secure application. You can do a token-based authentication. So the user will log in, you give them a token, and then every time they need to access the application, they have to give you the token. Or you can do a session cookie. So the user would log in, you give them some kind of a session or a cookie, you save it on the browser, and then every request they will send that cookie, or the browser will send that cookie, and then you will do the authentication with the cookie and then allow the request to go through. So in this specific course, what we're going to do is go with the token-based authentication because we have an API. So when you have APIs, it's easier to work with JSON Web Token. So we're going to take the approach of JSON Web Token. But even with JSON Web Token, there are many different implementations as well that you can have. You can use Spring Security JWT that is built in. So the JSON Web Token configuration that comes with Spring Security, you can use it. And a lot of times what you see is developers using a third-party library to generate the token and then give it to the user, which is what we're going to be doing in this course. So what we're going to be doing is we're going to go with the token-based authentication. So whenever the user logs in, we're going to give them a token and a refresh token. So they're going to have an access token and a refresh token. The access token is going to be valid for a shorter amount of time, and the refresh token will be valid for a longer period of time. And whenever the access token is expired, then they can give us the refresh token, and then we're going to give them a new token with the same refresh token. So we're going to give them a new access token. And we're going to take this implementation all the way to the front end, because whenever the user logs into the application, they're going to have an access token and a refresh token. And if the access token is expired, then you as the user, clicking in the application, you don't have to see that your access token has expired. You want that if your refresh token is still valid, then you just get an access token and you don't even know that happens in the backend. So that's something that we're going to be doing in the front end. But for the backend, what we're going to be doing is we're going to be using a third-party library. Now, you don't have to use a third-party library because Spring has built-in JSON Web Token support. So you can use Spring Security itself and then use the configuration that they have for OAuth to server with JSON Web Token. And then you need to give it the keys that it needs to encode the token and then decode the token. But I'm not going to take this route. I'm going to save this for another time. For this time, we're going to use a third-party library to generate the tokens. We're going to create our own filters, and then we're going to give the user an access token and a refresh token. And whenever the access token is expired, we're going to accept the refresh token and then give them a new access token. And with Spring Security, you can create your own user detail service, which is what we're going to be doing in this course. So we're going to keep everything in place the way that you have them right now. The only thing we're going to tell Spring Security is we're going to tell Spring Security, hey, instead of using the in-memory details manager, here is our user detail service. So here is our users. Whenever you need to do any kind of authentication, these are the users that you should use. So we're not going to touch the DA authentication provider. That's going to be the default. We're not going to touch anything else. But if you want to, you can create your own authentication provider. In this case, then you won't need to give it any user detail service because you're going to do all the authentication in the authentication provider. And I'm going to show you that in the security course that I'm going to have. But in this course, what I'm going to show you is how you can set up Spring Security, how you can generate the access token and the refresh token and allow the user to use the refresh token to get a new access token. I'm going to show you how you're going to use your own user details so that you can tell Spring Security where your users are so that Spring Security can use your users to do the authentication for you. But like I mentioned, I'm going to have a course specifically on Spring Security. And in this case, I'm going to give you all the different scenarios. So scenarios with basic authentication or auth through JSON Web Token with Spring, which is built in Spring itself. So I'm going to show you how to generate your keys for different environments and also how to create your own authentication provider, your own filter to do the authentication itself. Because remember, there is another filter that is intercepting the request coming in so that they can give it to the authentication manager. So I'm going to show you how to completely customize Spring Security in the Spring Security course. Even though we're not going to be doing that in this course will also dive a little bit deep into Spring Security because we're going to customize the user detail service and also customize some of the filters that we need to secure the application. And keeping with not overwhelming you with everything, we're going to take kind of a simpler approach to this application with Spring Security. But again, it's going to be super useful to you because you can take that implementation and then really secure any application that you want. So just make sure that you keep these in mind. These two diagrams that I just showed you, everything has to go through filters, and the filters will call an authentication manager. Authentication manager will try to figure out which authentication provider can do the actual authentication that is coming in. Just keep that in mind. Filters call authentication manager. Manager figure out which provider they need to give the authentication to, and then the authentication provider will reach to some user details and then do the authentication and then return the response. All right. So at this point, hopefully you have a pretty good understanding of the security flow and how it works. Now let's get our hands dirty, and then I'm going to show you how we're going to customize it. We're going to take it slow, and then gradually we're going to go into more complicated setup. So let's go ahead and jump right in. So I'm back in the application, and I'm going to go ahead and create a new package, and I'm just going to call it configuration. So configuration, and then inside of here, we're going to create the security configuration class. So security config, and then I'm going to press enter. So remember, before you have to extend web security configure adapter. This has been deprecated, so we don't have to extend anything at this point. Now we have to define a bean, which is the security filter chain bean. So I'm going to say public, I'm going to say security filter chain. So that's this one right here. I can give it any name, and this takes the HTTP security. So we're going to say HTTP security, let's call that HTTP, and open and close. You can have multiple ones of these. You don't have to have one. You can have many of them. Just to make sure this is a bean. Okay, so you can have as many as you need. Okay, so you can have configuration for users, you can have configuration for admins, etc. And I think this is gonna throw an exception, so let me just do that right here. Throws exception. As we start putting in the configuration in here, I think one of the calls that we're gonna make is gonna throw an exception, so I'm just gonna put through an exception here. So all of the security configuration that we're gonna be doing, they have to go inside of this filter now. This is the new way of doing things. Okay, so we're gonna put our configuration here. For now, I'm gonna return null just so that we don't have this error anymore. So what do we need to put in here? Well, we have a number of configuration that we have to put in here. By the way, before I jump into the configuration, I just wanted to show you guys the documentation for some of the things that I was talking about in the presentation. So let me open my browser here. So this is the filter. So I'm gonna put this link in the resource. You can just click it and read about it. So this is the default filter. That's the username password authentication filter, which accept the username and the password, as you can see here, these two fields. And that's what's implemented by default. And this is usually the one that you have to make sure that you have your filters placed before, because you don't want to disturb the filter chain that is in Spring Security. So if you're gonna add any custom filters, you want to make sure that you put them in front of this filter, because you want to keep the same order of the filters. You don't want to disrupt the Spring Security filter in the way that they're listed. So that's the username password authentication filter, and this is the authentication manager. So you can see here it says it's going to try to attempt to authenticate the authentication object that is passed, but this is not what's doing the actual authentication. What's doing the authentication is the authentication provider. Well, authentication provider is an interface, so the implementations of it will do the actual authentication, like checking the username and the password. So you can see here it says it's going to attempt to authenticate the pass authentication object, but in this case for the authentication provider, you see it says performs authentication with the same contract. So this is what's doing the actual authentication, like checking for the username and the password. So whatever implementation of this that you have, this is where the actual authentication is going to happen. And remember, the default is the DAO authentication provider. I can open that in a new tab. So this is the default. And if you want, you can override this and you can give your own implementations for these methods. And I showed how to use this for free in one of my YouTube tutorials online. So you can go ahead and check it. You'll see that I have an implementation actually of the abstract user details authentication. So if I open this, you can see they have similar methods, and I'll show you how you can override this and then do your own, or you can create your own implementation. So instead of using or extending one of these implementations, you can give your own implementation of the authentication provider. There's caveats to it, but you can do that. The caveats are you're gonna have to handle the exceptions yourself, as opposed to if you use, for example, one of these implementations like the abstract user details authentication provider or the DAO authentication provider, then they're gonna catch all the exceptions for you. But if you do your own authentication provider, so you extend this class or you implement this class, then you have to make sure that you handle all of your exceptions as well. But these are the documentations straight from Spring, you can see here, and I'm gonna give you guys these links if you want to go ahead and read or read a little bit more so you understand how these work. And you can see all of these different implementations that we have for the authentication provider. Then you can do that. Maybe look here to see which one will work for your case. And you also see that Spring has their own JWT authentication provider. Okay, so we're not gonna dive into this just yet. I'm gonna show you how to do all of this in the security course. We're not gonna dive into that yet, but I'm gonna show you how to set up OAuth2 with Spring, and I'm gonna show you how to use JSON Web Token with Spring itself without using a third-party library. But in this course, we're gonna use a third-party library just so that you can start getting your feet wet. Because using, for example, the OAuth2 authorization with JSON Web Token in Spring, there's a lot of abstractions. Like you probably have to do like maybe like define like 3 or 4 beans and then everything is working. So I want to show you how you can do this implementation and get your hands dirty and do it yourself. And then later you can use Spring Security built-in OAuth2 with JSON Web Token, and then you can do that yourself. But it's really important that you understand how this all works in the back. Now that's not why I'm not using it. I'm just not using it in this course because I already created the application and I didn't use the built-in Spring JWT with OAuth2. But I'll show you how to do that in another course, which is going to be the security course. That's going to be dedicated to Spring Security. But I just want to make sure that you guys understand this. So I'm going to give you guys these links, and then if you want, you can go ahead and read more on the documentation. So now let's go back to the application and then let's put in our configuration.